Okay. Well, I will turn the videos off. I've muted you guys as well. Kevin, you're already muted. Okay, so but be sure when you want to say something, unmute. So just realize I've muted you on. So all right, now we left off yesterday, sort of in a rush, we were finishing up our work with points. And we're going to start in on some terrain modeling this morning. So we did this, the point groups.
Can I interrupt, Ken?
Yeah.
When I'm trying to commit on here on Zoom, they want me to give some kind of code here, and if I don't give it to them, they're going to kick me out. So,
I think you can safely ignore that. You don't need anything at all if you're joining somebody else's meeting. You need something if you're trying to run a meeting.
Oh, I see. Okay. So if I just X this out or get rid of this dialog box.
Yeah, I mean, you're in now. If it should, all you have to do is join that one thing. Kevin and Jeff, you didn't get any kind of confirmation codes, did you? I know how everything else that makes you confirm things 6 way from.
I think we were on the right track there for a second.
Yeah.
No, I was good. I just clicked the link you provided.
Yep. Yeah, that should be all you need, Jim.
Yeah, I think I'll go back out and try to do that again.
All right. Okay.
Okay, I'll be right with you.
Good. Okie doke. All right, so. Oh, poor guy. All right, so now let's see. So let's talk about terrain modeling and surface modeling. How much of that have you guys done? Go ahead and unmute and let's have a real quick discussion here. Have you done much of that at all?
I'm barely lucky to get the field to finish working over the past 2 months that I've been on AutoCAD, so I have no terrain modeling. Creating a surface is brand new to me.
Okay.
Yeah, I'd say I'm kind of in the same boat. I mean, back in the late 90s, I think I mentioned yesterday, I was using AutoCAD with Eagle Point.
Yeah.
Had some familiarity with tins and, surface models. My last career with floodplain management, we were on the receiving side of data using, the LiDAR data, but I didn't really work with it.
Okay. All right. So, well, that gives us a good starting point. We can sort of start to talk about this in general. So, Jim, I see you're back with us.
Yes. Yes.
Okay. So you should be able to just, come right along. Make sure you're running your version of Carlson on one screen and you're looking at my screen on the other.
All right.
So now I'm gonna. All right. So now, Jim, we just started our discussion about modeling surfaces and doing terrain modeling and things like that. And so we're sort of really starting at the fundamental basics here. And so I need to sort of ramp everybody up to speed, and it's going to be kind of fast. So, any kind of like major side trips and bog downs, we're going to have to just put a bookmark in it and come back to them later, I think. So,
Ken?
Yeah.
I'm sorry to interrupt there, but I want to get with you. Of course, I can see you on my on the big screen, and on my laptop screen, I haven't got my IntelliCAD up yet here.
All right.
There's still a Zoom dialog box here that
yeah, go ahead. Yeah, anything with Zoom in it, you can minimize. You don't need that anymore once you're in the meeting.
All right.
You don't want to exit them, just minimize them.
Okay, I'm coming here. I'm coming. Sorry for the holdup. Okay, I'm there on Carlson scribble.drawing or whatever, you know.
All right, good deal. All right, so so what we've got to talk about now is how do we do terrain modeling? What constitutes a terrain? And it's some very basic things. I'm not going to read you all of this stuff, but I'm going to point out some key areas. Basically, what we do is that we model the ground surface or terrain or any kind of surface, really. It can be a structure if we want. But we model it with a series of triangles.
Okay, I found this on the web for S of triangle.
I said series and Siri popped up. Sorry about that. Anyway, so we put together this set of triangles because it takes a minimum of 3 points to define a planar surface. If you know any 3 points, you can define that little patch of surface, that little patch of space, you can turn that into a plane. Okay. And the way you then model an entire surface is that you create these little triangles all over that ground with 3 points that are lying on that surface at all times. So all these 3 points, and then all of these triangles match up edge to edge to edge to edge to edge. So you wind up, with something like, something like this up here, where all these little triangles are all stuck together and each edge is a common edge. Okay. So that's what we're after. And those things are put together in this network. They are irregularly shaped, unlike a grid, which is another way of modeling a surface. But these triangles are put together into this loose network. They're all irregular shaped, so they're called a triangulated irregular network, or a TIN. And it's our job to figure out how to put those triangles together. We need to know the points that we need to observe and capture, but not just the points, but we're going to need to talk about things that make edges too. Okay, and those are going to be our break lines. So as this example that you're looking at on my screen right now, these triangles that are formed, I go out in the field and I shoot these 4 points and I bring them back in, and I've got a point in the northwest up there that's 100 elevation. I've got a point in the northeast that's 110. It comes back down in the southeast to 100, back up again in the southwest at 110. So what this thing represents, if you consider those 2 triangles edge to edge, is that I've got a ridge line running from southwest to northeast at elevation 110, and it falls off to the northwest and goes down to 100. It falls off to the southeast and goes down to 100. Okay, and that may well be what's out there on the ground. Therefore, I've modeled this correctly. Now, consider, however, this case. These are the exact same 4 points, 100, 110, 100, 110, northwest around clockwise. But if the triangles form in this fashion, it has formed a completely inverted type of ground. I now have a valley at elevation 100 that runs from the northwest down to the southeast, and it rises on the northeast up to 110, and it rises also on the southwest up to 110. If you could just pretend you're a little, ant walking down that valley line. So that is just as legitimate as the other shape we saw, where the triangle edge went from 110 to 110. Okay, so you'll never get a situation where this forms out of our data and that this also forms. They can't both exist, so only one will happen at a time. And one will form first, and once it does, once an edge gets drawn, let's say this is the edge, the triangle that forms first. So once this edge is created in the computer memory, it is now serving as a break line. Every little edge of every triangle also serves as a break line. And that keeps this point over here, 110, from looking across that line and seeing any other points on the other side of that line. Okay, so it can no longer, if this forms first, it cannot form another triangle from 110 across to 110 because this is in the way. Okay. Now, what makes this happen? Either like this or like this. One of those two things will happen. And in the computer, when you're modeling this, I don't know what algorithm is employed to make which one happen. Is it the order that the points were observed? Is it the proximity of the points to the last ones that were modeled? I have no idea. And maybe it's random. I don't know. So our job then, when we're out surveying, is to identify these features so that if we have a valley bottom or a ridge top, we need to draw those lines in our data first. We're going to draw them before the triangles even form so that we don't get any of these invalid triangles that jump across. And down here is a perfect example. I like to use a curb. So if we go out in the field and we shoot these points, okay, and this is what a lot of us do. If we're doing a curb, we'll go out there and we'll just spray in, a couple of hundred points. We'll get back a curb, top of curb, face of curb, edge of asphalt, and we'll get all those things. We'll get 1, 2, 3, 4, at least 4 shots across the curb valley. And then we'll move down the road about 25 feet, 50 feet, and we'll get another 4 shots, and we'll get another 50 feet, get another 4 shots. Okay, that's fine. We can do that. And what happens when we do that is those 4 shots that we've taken in one area tend to be so close together that they don't, they tend to form their edges kind of with themselves. And so that usually lucks out that we get them to form correctly. But here's what can happen. If we have these observations on the curb, now, if you look at them along the curb structure, I've got points A and B that are along the edge of asphalt. I've got points C and D that are along the face of the curb. I've got E and F along the top of the curb and G and H along the back of the curb. Okay, so that's the structure. And these are points that I've observed. Now, normally you would say, well, if you're over here at E and A, you should have gotten the back of the curb and the face of the curb here. Well, yeah, okay, maybe. But I wouldn't have to if I do this. Because here's what can happen if that's all I have. I've got this situation where these triangles can form. I can form to A and B. That's perfectly legitimate. That represents the constant change of elevation and direction along the ground between A and B. C is down here again. Remember, C and D are in the face of the curb. So it goes from A down to C. That's perfectly valid. B can go to C. That's perfectly valid. But A can also, with nothing in the way, it can see point E. So the computer doesn't know any different. It doesn't know that the ground goes down here and then up. It knows that, it can just assume that the ground is, maybe there's a wedge curb right there. And so it goes from out here at A up to E. Same thing, face of the curb. C can go all the way up to G and just cut right through the curb. B can go to F, just like A went to E. So what we have to do is we have to go in the computer and we draw these edges in, these lines, 3-dimensional lines through those points. And so now if I've drawn, let's say I've drawn this face of curb all the way down the curb structure, and now I go to triangulate it, So point A looks all around itself and tries to connect up to other points. So it sees C, there's nothing between A and C, and it forms that one. It sees B, it does the same thing. Now it could also, if B has not drawn to C, it could go from A and it could look all the way up here and draw up here to D. But that would be perfectly valid because that surface does change from A to D along that sloped line. Okay, so that would be valid. It's more likely that B would form to C first and keep that from happening. But if I've also drawn in these features like this face of curb, A can now no longer see E, B can no longer see F, and so you get your triangles to form like this. A, with all of these lines along this structure have now been pre-drawn. A now looks all around itself and tries to draw connecting lines to all of these other points. It finds point C, it draws that edge. It finds point B, it draws that edge. Okay, but it can't look past this line. Any kind of edge, any kind of line that encounters, it can't go beyond. That's called a break line because it breaks that triangulation, right? So A can no longer see point number E or point letter E. A is no longer aware of point E or G or F or H. The only thing that point A could possibly see would be point C, point B, and point D, okay? But if B was doing its triangle bit and it formed over here to C, once that's closed off, now A can no longer look over here and find point D. Likewise, point D can't find point A, okay? So then you've also got these points. Now you can have an edge along those lines that we've pre-drawn. So point letter C can look over here and find point letter D. So that's a triangle. BCD is a triangle. But so is CFD. Okay. And GFH and GEF, ECF. Okay, so that's how these triangles are going to form. And so that will force those triangles to lie in those planes because we're not allowing it to do things like this that are invalid. And so many times I see so many surveyors go out there in the field and they think they have to get 1 billion points. And the more points they get, the more accurate their surface is going to be. And that's sort of what these, when you start to map things with drones and you get all this LiDAR coverage, and that's really all that LiDAR stuff does is it just got billions and billions of points, and you just hope that on average everything's worked out okay because things are close enough together. Maybe they'll form triangles correctly first. Well, that's not as accurate as doing it this way by having break lines. In fact, even when you're doing drone surface mapping, there are ways in there that you can create these break lines and then let it triangulate out of that point cloud data. So, break lines are still legitimate even with drones. Most people don't do it. They just, shotgun blast approach. Okay, hold on a second, Jim. Yes, sir.
Ken,
Yeah.
how you doing? I just want to talk to you.
Oh, wait, Jim, quick. I'm sorry. I'm in the middle of class. I'm going to have to call you back. All right.
I'm sorry.
All right, no problem.
I just want to.
Sorry, Jim. I saw there was another guy I'm working with named James Ventura, and it came into my phone. And Jim, I looked at it, and all I saw was the James, and I thought it was you, Jim Hunter. So that's why I took the call. Very sorry about that. Anyway, so the point is that we need to create these break lines. Now, a lot of times people are saying, well, it's too hard to think about and try to remember it, but there's a little rule to keep in mind, and it's right here on page 20. And it says, you know, if it's a, well, if I can get my PDF file to highlight here, let me. Oh, bear with me. I'm gonna have to. I need to do something real quick here. So maybe. Ah, right back. Sorry, I messed up my book here. All right. Now, so right there's our rule. And that's all you need to remember about break lines, that if it's an edge on the ground, if it is the line that runs along a curb edge or along the edge of asphalt, or it's the top of a bank, or it's the bottom of a slope, any of those things that form edges, we need to form as edges in our data before we start to model the triangles. We can't just throw, thousands and thousands of points on this stuff and, hope that it models successfully. So there's ways of doing that. And if we look at some different data, here's some examples of some data that have been pre-done. This was done photogrammetrically. So all of these individual stick-looking lines, those are all break lines that were compiled from the photogrammetric stereo model, as well as the edges of these roads. Because if you think about a road edge, you've got points on this side of the road and you got points on the other side of the road. And so those points can look across the road and see these other points, but there's a crown of pavement in between the ones on the right side and the ones on the left side. And so that crown of pavement needs to be created as a 3D line between each of the points along the center line to keep the points from the right edge from looking across and seeing the points on the left edge. They're only going to be able to look as far as that edge, that crown of pavement. Okay. So here's an example. And what this book is talking about is, this little stuff over here, evaluate. And I'm saying, use your eyes, use your common sense, figure out what's going on with this data, because here is an example. If I'm looking at this on this left-hand side in plan view, it all looks fine. I've got these edges of this driveway and parking area. I've got the edges of the road, and I've got all of these brake lines, and I've got these spot elevations. Thank you very much. My savior just brought me a nice big cup of hot tea. Anyway, thank you. So, so as we're looking at this in plan view, it looks all perfectly fine. But if we turn our computer viewpoint up and look at it in 3 dimensions, a lot of times this kind of data that looks fine in plan view will look like this picture on the right over here on the other page, where sometimes, you get all the data up here in elevation, but you get all these road edges and maybe stream center lines are compiled down and at 0 elevation. Well, they don't do anybody any good down there. They have to be elevated up here along with all of these brake lines to be able to serve as brake lines in the data. Okay, so we're going to make sure that we evaluate the data that we might have and its suitability for making these triangle surfaces. Okay.
Ken,
Mm-hmm.
then do the brake lines or the barrier lines always have to be 3D?
Yes, sir. They can be planar. They can be the same elevation.
Oh, okay.
That's not what I mean by 3D. But being down at zero elevation doesn't help define your model if you're not at zero elevation.
Yeah.
Yeah.
Are break lines and barrier lines, the term, or is that interchangeable? I mean, you know.
It is. I think break line is probably the more common among people who model surfaces.
Okay.
That's the word, and that's their function, is they serve as barriers to keep points on one side of that line from seeing points on the other side of the line. Okay.
All right.
Now, there's nothing sacred about elevation zero other than we tend to not have our ground down at elevation zero. So the nice thing about Carlson's modeling algorithm is there's that switch that says ignore zero elevation. So we don't have to go around and turn off all of the data that lives down at zero, which there's a lot of data that lives at zero, you know, labels, and we draw road edges and parking lot edges and all that kind of stuff. We draw down at zero because, and then also draw them up at their proper elevations. But we draw them down at zero because the CAD systems cannot draw true circular arcs that have changing elevation. They can only be drawn that way in a single plane. So we do that for the ability to annotate our drawing. We can actually find out what the radius is of a curb return. We can't do that if that's a 3D line, because that curb that was an arc in 2 dimensions, if we stretch it up vertically in 3 dimensions and variably in 3 dimensions, it can't be shown as an arc. It has to be represented by a series of tiny line segments. So now there's no longer a radius to even think of. So that's why we have those, and quite often we have some of that data that is also drawn down at zero elevation. So now, but the only thing, and the nice thing about the Carlson software is we just hit that switch. It says ignore zero elevations, and we can leave all that stuff on. We can select it, and it's just effectively ignored. So we don't have to worry about isolating data on various layers and such. Okay. Now,
So Ken, if I'm hearing y'all correctly, this is all making sense, but the key thing with break lines is not only defining that barrier, but also having elevations on it.
yes, absolutely.
Okay.
And so where we get those elevations is if we look around here, as we're putting together now, if you look at this picture, just think of these pink lines. Those are the triangles that form. So sort of try to, I know it's hard, but sort of try to ignore them. And you see this little orange line, this skinny kind of vertical 2 lines down here. That's a driveway lane that comes up. And these heavier black lines down here, east to west, those are the edges of that road. Here's another driveway right in here. And you can see that, you know, the triangles, see there's a center line through there. And so that becomes a barrier from one edge over to the other edge. So these lines that are formed here, the edges of the pavement, the center line of the pavement, they are formed by, and again, all of this data was photogrammetrically compiled. So it's as if I'm out there on the ground and I'm just shooting points, and I just get a point. So every time it finds a point, and they draw that edge in there from point to point to point to point. So it's a 3-dimensional line that we're creating, that we're drawing. Okay. So that's what we're doing, is we're putting together all of that line work, and then we're saying, okay, now I want you to go here and model this and come up with a series of triangles that represent the surface. Now, while we're here and we're talking about triangles and how things are seen, again, you can see through this mess of pink triangles, you see those little gray sort of east-west lines here along this edge, and they're sort of, well, I don't know, whatever orientation they are down here, southwest to northeast. But a point that's out here on the end of this gray line, and this is a 3-dimensional polyline, these break lines are, each vertex has a different or potentially different elevation. And as the computer sits on the vertex of that line, it's looking all around itself in a complete circle and trying to form triangles to other points that it sees, any other three-dimensional point that it can find. And those include vertices in other three-dimensional lines. It includes point entities, which would be part of a Carlson point. So it doesn't have to, it doesn't necessarily have to be a point that somebody has observed in the field. It could just be a 3D point along a three-dimensional line. It can recognize those vertices out of those 3D points. So, but if I'm out here on the end of this one or this next one or this next one or this next one, and I start looking around myself in 360 degrees and I start connecting things up, these over here are, probably pretty valid. But I'm looking over here and I can see all the way up to here and see this point, and there goes that triangle. I want to make that triangle. Same thing, I come in a few and I'm sitting here, I can look all the way up here and I can see that point, and I'm going to make those triangles. But if you consider these gray lines and where they end, that's the end of my observed data, is along this line here that I'm tracing. So that should have been, the extent of what I see. Like all of these triangles in here are no good. Mathematically, they're okay because it does go from this point all the way up to this point, but we don't know anything about the grounding here. So I would have to do, and a lot of some software makes you do it this way. You go ahead and build this surface, but then you have to go through and strip out these triangles. You have to recognize the areas where these are no good. But we've got other tools that we're going to be able to pre-draw a boundary around the extent of our data that will serve as a break line, and it will prevent this from happening. Okay. So those are called boundaries, and they can be, you can have more than one, even in a given data set. You can have, like a little, you can model the surface up here, and then you can come down here. Maybe your main work is down here and you've got a borrow pit up here. You can model something and it can be non-contiguous with another part of the same surface. There's nothing that ties all that together. It just usually we have them in the same spot. So now let's consider a couple of things here and some tools that we have at our disposal. Sorry. So I'm going to load up my Carlson. I'm going to go back to my doodles drawing, and that had those points in there. And let me know if you've got your doodle drawing available, go ahead and load it back up. If not, I'll show you how to get what we're trying to do real quickly. Just let me know that you don't have it. I'm looking to have, all I really want in that drawing is I want all those points. I think it was 22 points. Points. Oh, scribbles or points or whatever. Points exercise. I think that's the one that I made yesterday. Okay. That's the one that I'm looking for, the ones with these 1 through 22 point numbers. Does everybody have that okay?
Yep.
Okay. Jim, did I hear from you, Jim, or one of you I didn't hear from?
Yeah, I'm looking.
I had
for
my mic off.
Oh, yeah.
I didn't find it yet. File, open.
Jim, if you're on that start page like this, you should be able to see it in this list of recent files. I don't know what you called it. Was that called scribble, or did you call it point exercise? I called mine point exercise. Did you save it? Maybe you didn't save it, and that's okay.
Okay, I'm on the page where I was doodling, so that's that scribble drawing.
You have points in it.
No.
All right. Let's do this. Go to, you can stay right there. go to any drawing that you may have. And I want everybody to type this at the command line, type erase, like the command ERASE, hit enter. When it asks you to select entities, type ALL, hit enter. Hit enter one more time to conclude, and that will erase everything in the drawing. That's the same thing as starting with a new drawing. Okay, so we're starting fresh. Okay, so now I want to go to the points menu. I want to say set coordinate file.
Uh,
Everybody get to this point, okay?
Now, I'm still on the scribble drawing and I'm trying to,
That's fine. Go down to the command line. Press escape a few times if you're in the middle of a command.
okay, I'm on the command line.
Type erase and hit enter. When it asks you to select objects, type the word all, ALL. Hit enter, and
Yeah.
it will ask you to keep selecting more entities. You're going to hit enter to finish that selection, so it erases everything.
Okay, nothing there.
Okay, that's good. Now go to the points menu and choose set coordinate file.
Go to the points menu. Uh,
Here, Jim, watch what I'm
Okay, I got points and then select what?
right here. See where my mouse is?
Yeah,
Set coordinate file.
okay. Set coordinate file, yeah.
Now, when that comes up, you've got two tabs.
Yep,
Make sure you're on existing.
existing,
And then in the list of current folder files, you're going to find exercise 1 coordinates.crd.
got it.
And say,
Open.
Yep.
Open.
and so now to verify, let's go to the points menu and list points. And when this comes up, I'm just going to say all. Hit OK. I'm going to verify that I have at least 22 points. Now I've got these other points that I created yesterday from those house corners and the property corners, and that's okay. You may or may not have those. It doesn't matter. All I want is some points. Okay, so I just want to make sure that you've got some points. Now, they're not in our drawing, but they are in that coordinate file. But I want to put them in the drawing. So this is if we have surveyed some points, and we are going to
Okay,
put these in. So I'm going to go to the points menu and I'm going to draw or locate points. And I'm going to go down to the bottom of this screen. Well, first of all, I'm going to make sure that I'm drawing the descriptions and the elevations and the locate on real Z axis. Those are all 3 checked. And those are these 3 check boxes right here in the middle. Okay, so just make sure that they're shown on. Then I'm going to go to the bottom button and I'm going to say draw all. And you're going to get some points. Now, those points happen to have elevation, some of which, you can scroll in here and see these points. They've all got different elevations, and these up here are at 0. So those are not going to make much sense to things. But now, here is an example of how you could recognize that even if there weren't points, you could look at this data to see if it's got elevation. If you hold first of all, assuming everybody has this little view cube up in the upper right corner,
I do not,
You do not,
Kevin, no.
Kevin, okay. What version of AutoCAD are you running?
It's the AutoCAD Map 3D 2023.
2023, huh? You should have that.
I might have turned it off, that it's like a zoom wheel or something.
Yeah, it's that. You can get by without it. But it just makes it an easier way. Like you could choose this upper corner to view some things, and then hit the top button to put things back. That's all it's there for, really. But so you can get by without it. But one of the things that I do quite often is I look at my data and try to make some sense out of it. So there's several ways of doing that. I can hold the shift key down, and I'm going to then press and hold the wheel and the mouse, and keeping all of those pressed down, I'm going to push it up, push the screen up, and you keep the shift key held, and you keep pressing the wheel and the mouse, and you see how I'm rolling this around? And I can eventually get up to where I'm looking edge on, and I see all those points that are at 0, the green looking ones, and all of the blue looking ones that are floating up there in 3-dimensional space. Okay. So I'm verifying that I've got these points. So that's another good way to verify data, because if I come up here and I notice something stuck way up here in the air, I know it's got a bad elevation, and I need to fix that before I can model it successfully. Okay. But now how do I get back to my plan view? And that's where this little cube comes in. If you can see part of that little face, there's one that says front, right, left, and this one says top. You could click on that, or you could simply type the word plan, because you're going back to plan view, and hit enter, and then answer the next question. You want a plan view of a particular user coordinate system, or the world coordinate system, or the current user coordinate system, which happens to be the world coordinate system. So we can just hit enter, and it comes back to plan view and does a zoom extents. Okay, so that's one way to check. There's another way, is you can look at all of this stuff in Carlson's 3-dimensional viewer. I'm going to show you where that is, and we're going to start to learn that just in some baby steps, okay? Because it's got a lot of stuff in it, but it's really, really handy. So on the view menu is a 3D view pull right. If you go up to the view menu, bring it down and go down 6 lines to 3D view, and you go across, you see there's some things there in the pull right. One of which is a drawing viewer, another which is the surface file viewer. They are presented as if they are 2 separate commands. They really are not. It's the exact same viewer. It just depends on whether you put in it things from your drawing, that's the drawing viewer, or you load up a surface file that has been saved out on the disk. That's the only difference between the two. And then whichever one you enter as, there are some tools that become active. Like the surface file viewer has some surface editing tools that don't make sense in the drawing viewer because you don't have a surface in there. You'll see all that a little bit later. But for now, we want the drawing viewer, because all we have are things that are drawn in the drawing, and they happen to just simply be points. So let's look at our drawing viewer. So I'm going to choose that. And it says select the entities for the scene. So I can zoom out and click and drag a crossing window. And if everybody's not familiar, when you click and drag to the right, everything has to fit entirely within it. That's called a window selection. If I click and drag to the left, and you see the colors are different, then that is a crossing selection. So even if I don't entirely surround something I'm looking for, if I just touch it somewhere, it will be selected. So that's pretty basic CAD stuff. But anyway, you can do that, or you could simply have typed the word ALL. That's a keyword for selecting. So you type, you go into this viewer, type, or it asks you to select the object. You're going to type ALL, hit enter, and now you notice it still asks you to select entities. because you can keep selecting or you could deselect certain ones, etc. But we're through selecting, so we hit enter one last time. And that's now going to pop up a 3D viewer. And to its own little window, it is resizable, repositionable. And I'm going to just make it full screen so you can get the benefit of what's going on here. Now, yours may or may not look exactly like mine. And I'll show you a couple of things here. As I spin this up, you see I've got this little yellow pizza box that's basically showing me everything that's there. I've got this button up here. This is ignore zero elevation entities. Now notice
Sorry,
these.
Ken, I zoned out there for a second. When I got the gray thing that came up before you went to your pizza box, what do I hit when I get there? I got view control settings, model. Do I just click the closed box?
Yeah. No, I'm sorry. No, the view, go to the view control tab if you want to do
Right.
these
Yeah,
things
I'm
here.
there.
And you may or may not see this box on yours. But go to the view control tab and you want to grab this icon that looks like that 3-colored cube.
Oh, okay.
And then that puts your icon over here. Now we haven't talked about how to navigate through here yet, but that's where we're going to go to next. So if you go to, we got 3 tabs here in our viewer. There's the view control, settings, and model.
Okay.
So go to the settings tab in the middle. All of these things on the left are things that you can turn on and off. You can, hide the backs of triangles. We don't have any triangles, so none of that stuff matters for right now. You can display triangle edges. Again, we don't have triangle edges. We don't have surfaces loaded. None of that matters, but this one underneath all of these check boxes says bounding box. And it says box only. You could say box with labels, and you'll then get the coordinates and the
okay. It came up in my screen. Yeah, I see it.
or you could say none. So in which case that's off. I like it in the particular sense because if I've got some data and I can't figure out, I've got some kind of stray piece of data that is like causing my surface modeling to not work correctly, and I can't see it. But if I turn this bounding box off and it goes like everything's clustered up here, like say at this top level, but the box goes way down here to the bottom, then I know that I've got something somewhere down there. It sort of helps me visualize where to go find it. And if I have it on also to where I say with labels, then I would look at this lowest level of elevation label. In fact, let me go back to the view control and uncheck ignore zero so I can see, well, here I start up there at about 117 or so. 117, 132, 148, 163, but I've got some other things that are showing up down here on the bottom decks, you see, and those are my zero elevations. Those are the ones that shouldn't be part of my model. Okay, but I'm looking at it in 3D and I can choose with this view control. I'm on the view control tab now over on the right. I can choose to ignore the zeros or turn them on and see them. So that helps you to be able to see things that are at zero and know what the difference is. Okay.
Yeah.
So now,
Thank you.
so here's the gist of and how to use this viewer. Also on the view control, by the way, you've got this color by elevation, and you'll see when you see any YouTube videos that Carlson produces and things like that, almost all the time, almost universally, they will show, this color by elevation. They like to show these, and if you're looking in the book, it would look like this right here. See, you get this spectrum on the left-hand side with a range of elevations, and you get the colors that show up. Well, that's okay, but sometimes you don't, that gets in your way. If you like it, leave it on, that's fine. But, sometimes you want to see the colors as they're meant, because especially if you have the civil modules and you're doing road design, you can assign colors to different things, like colors to the pavement, colors to the concrete, colors to the sidewalk, to the grass, to the ditch, to the bank. So that, you don't necessarily always want to have that on. So just keep that in mind. If you like it, certainly use it. And it gives you an idea of the range of elevations of what you're looking at. So if I ignore 0 elevations, I see I've got some things down here. You can see on the left, I go from 0 all the way up here to, 160 something. Or if I ignore them, then I go from like 101 up to 160 something. So it's all kinds of ways to visualize your data. So I tend to not use that color by, but sometimes I use it for a check. But now here's what you need to know. When you come into the viewer, you go over here on these row buttons and hit the lower right one where it says to go back to a plan view. When you come into the viewer, whether you see the box or not, if the box is not there, it's going to look like that. I'll turn it back on just for reference sake, okay? And on the view control now, you have a couple of things. You can set up the lighting based on your latitude and longitude, all that kind of crap. But these controls right here, the little blue circle, the yellow square, the slide bars underneath and to the right. Now, they won't have much effect in what you're looking at now because we're only looking at points. You'll see this when we start to look at surfaces. But think of this as the sky or even as maybe the earth. And this little yellow square is the sun. And you can click on that and hold it with the mouse and you can drag it around. And for most of our perceptions and our preferences or our perception biases, we want that to be in the sort of the northwest position. If you take it all the way to the edge, it's as if it's lighting it down right on the equator. If you put it dead center, it's like it's directly overhead. So we want it slightly up and to the left so that it casts shadows down and to the right. And that's the way we've sort of been conditioned with 3D art we see all the time and advertising and that kind of thing. All right, so, and then this slider down below, you've got contrast, you've got brightness, and you can adjust those for a better view. The plus and minus, that's to zoom in, to zoom out. Your wheel on the mouse works fine. You don't need those at all. Same thing with this hand down here. There's a pan mode. So you can go, left and right. Also, though, you can just press and hold the wheel on the mouse. So the panning and the zooming works just like it does in the main drawing. Same thing with these two magnifying glasses, which are zoom previous and zoom dynamic and all that. You don't really need those because of what I'm going to show you next on how to make this stuff.
Yeah.
Yeah.
How do I get to view control? The pizza box. I see what you got and I've seen what you've been doing, but
Yeah. Pizza box is on the settings tab.
Settings?
Yeah. You see that?
Yep.
Okay, down below the checkbox on the left, there's a bounding box. And it has a pull down choice between none, box only, and box with labels.
What's it entitled? Because these icons are pretty small. 3D viewer model light? No.
What? Are you looking at this view control and settings and model tabs?
No. I've got my points up there. I don't have the pizza box. I don't have any of that.
Well, I'm not in the drawing, Jim. I'm in this viewer. See, that's what I'm in. Did you get to the viewer?
How do I get to the viewer is what question.
So go back to the view menu.
Okay.
3D view.
3D view.
And drawing viewer.
Drawing viewer. Okay.
Now type ALL when it asks for objects to select entities. Type all, hit enter.
All.
Hit enter one more time. So now this will come up and I'm going to double click the title bar to make it full screen.
Okay. I've finally got that the dialogue that you have over to the right there, and it shows all my points in red. I don't
All
know.
right, good, good. Now go to the settings tab. And down underneath all of these check boxes, pull that bounding box down. And if you want to see it, turn it on as box only. If you don't, turn it off with none. Okay, so that'll bring up that box.
My my menu there is a little different than yours, I believe.
Should be. What does it say? If you go click on the settings tab up here at the top.
My box with
Okay,
labels is
okay,
above
okay,
all the check
okay.
boxes as opposed to
Yeah.
his below. Is yours above?
Yeah, the older versions have up here display bounding box as a checkbox.
Yeah.
They've turned it into a choice as to how you want to display that box. Now you've got a pull down.
Okay, I got that pulled down there. It's checked on display non-surface entities. See above there?
Yeah, right here.
That's where the check is on mine.
Okay, well, that doesn't matter. That's go look at underneath every one of those check boxes is a line that says bounding box.
Yeah.
That's where you choose here.
Bounding box.
You see the words that say,
Mine's
Box
above
only.
all those. Is
Yeah.
I got it. I got it.
all right, now back on the view control tab. So up here at the top of the right set of controls, click the view control tab. Now this is how to navigate around in this viewer. And this is sort of crucial information. Now guys, you know, I'm not going to be able to spend a whole lot of time going through this stuff because we've got so much to cover. And this is things that we typically get in the fundamentals class. So, you know, I'm sorry, but you're going to probably have to do some practice on this stuff. I will reassure you that it will soon become second nature. You'll soon know to do it. And it's very, very quick and easy. And I do this all the time when I'm modeling stuff. I am in and out of this viewer probably 500 times to verify this stuff. So it will come easy to you. And it's going to look like I'm really zooming through and running off and leaving everybody. And I've not intended to do that. But we've got, you know, less than we've got less in this class to try to get the rest of this stuff, the material covered. So in any case, and I'm not trying to discourage you from asking questions. Please ask the question if you get to, but I'm not going to be able to go through a lot of the nuances in very much depth, just because we don't have the time. So now here's how to navigate though through all of these controls. In this view control tab, which does exactly that, it controls the view. There's this top checkbox that says ignore zero elevations. And when you have it checked on, it doesn't look at or display things with zero elevations. If you uncheck it, it lets those show up, in which case now you can see the ones that are down there at zero. In my case, you may not have any. Okay, so don't worry if you don't see them. And usually we want to ignore those because we're just checking that stuff, but sometimes you need to see them just to verify some things. Okay. Now, how do we navigate in this view? There's a couple of things over here. We talked about these view controls, these magnifying glasses you can pretty much ignore. That's everything that you can do with the wheel and the mouse. And the hand is also the pan mode, which you can pan just like in the drawing. But the one that's really now the crucial control is the second icon from the left. And it could look differently. In the new IntelliCAD versions, it's now this tricolored cube. It used to be the old AutoCAD UCS icon. They had the big fat arrow pointing up with a Y on it and the fat arrow pointing to the right. It had the X on it and it had the little circular arrow around it. In any case, they're just showing you a representation of something that controls your ability to spin it around these axes. Okay, so that's the one we're going to want to be using most of the time. So we select that second from the left top row icon. And now if you put the mouse, if you just hover it, bring it in from the right edge and cross over into the data, and you're going to see when you get off the edges, it's a Z with a little round arc, a little quarter circle arc icon. But as you keep moving inward and you get into generally the area that's over top of the data, it's going to switch to an X and Y representation. You go up to the top, once you go off the edge of the data, you're going to see it switch to the Z. Come back, go to the left, you see the same thing, go to the bottom. So that's two different modes, depending on where you are in relation to the data. And it's not exact, okay, but it's just in general, when you're over the data, it's XY. When you're outside it, it's Z. And that's going to be how we navigate our way around this stuff in space. Now, there are also sliders down here on the bottom. And if you look at those, or down, you know, underneath, over here on the right-hand edge, but under the buttons. So if you look at those sliders, you see how you can drag these back and forth. That was my X-axis. Here's my Z-axis. But notice my Y-axis is locked. And there's a reason for that. And I'll show you here in just a second. I'm going to go back now to my buttons, and I'm going to hit the one of these lower two on the right. I can either go to plan view with where I'm sitting or the plan view zoom extents. So now I'm back into looking at it in plan view, although there is some perspective. So it does sort of a vanishing point to the bottom level. Now, there's all kinds of controls down at the bottom. You can get to those later. Those are clipping sliders that you can clip from the top down, from the left in and the right in, that kind of stuff. But if I go back and grab that second icon now, and I'm going to do this, I'm going to uncheck this Y-axis right over here on the controls. It normally is checked. I'm going to uncheck it just in a minute to show you why I'm going to leave it checked all the time, because it helps me to control my view. I'm going to make sure I get that second from the left icon. So it's this X, Y, and Z. And I'm going to go over here and I'm going to get into the over the data part where it's X and Y. I'm going to press and hold the mouse down, and I'm going to push up, keep it held down, and pull it back down. Okay, and keeping it held down, I'm now going to roll it left, or I'm going to go push to the left and push to the right. So you see, I've got independent control on those X and Y axes. Okay, so now get it sort of back to being close to, it doesn't matter, whatever orientation you want. Let the mouse button up, go to the bottom, and click and drag, click and drag left and right. And you see what you're doing is you're actually just spinning it around the Z axis, okay? You can do that from any edge where you got a Z axis. It doesn't have to be the bottom, okay? So, but the X and Y has been set. When you're in XY mode, the Z gets set in Z mode, okay? Now I'm going to go back over here to my control and hit the zoom extents or the plan view button. So go back to plan view. I'm going to go back down there. I'm now going to click and lock this Y axis, and that's going to help us to visualize how to view things. So if I go here in the XY mode now over top of my data, and if I click and hold the button and I push up and pull down, that's just like it was before on my X direction. But if I push to the left and push to the right, notice nothing happens because I have locked that Y axis. That's going to be very helpful in our little mental picture that we get and how to set our views. And again, that stuff will become second nature to you later on. You won't even be thinking about that, but if you leave that little lock in place, that's going to help us to learn how to manipulate our view. Okay, so leaving it in place and knowing that we can only go spinning around the X axis, and then in Z mode we can spin around the Z axis, but I can't spin around the Y axis. Okay, so that's going to be how we learn to navigate here, and you're going to remember it this way. If you take the cursor, once you're making sure you've got that second from the left control, and you put it over the data to where you get the X and Y shape, not the Z shape, but you want it to be over top of the data, sort of on the bottom edge of where that becomes X and Y. Now you're going to visualize yourself standing in your driveway looking at your garage door. And that garage door needs to be raised so that you can get in there and get your nice Corvette out and go for a spin down the highway. So to do that, though, your garage door might be one of those solid garage doors. It's not jointed, it's solid, but it rolls up into the roof, into the ceiling of the garage. So we're going to picture that we're standing in front of our garage door, and we're going to take our mouse, making sure it stays X, Y, and we're going to click and hold the button, and then we're going to raise the garage door up, and we're going to raise it up as far as the mouse will go. We'll let the button go down and grab another bite and keep raising it up. And we want to get to where we're laid back at about this level that you're seeing on my screen right now of obliqueness. You don't want to go all the way up and look underneath your skirt. You want to just lay it back almost up flat, okay? Once you're to that point, let the mouse button up and then put the mouse down in the bottom to where it's a Z, and then just go left and right. And you're going to spin it around to where you're going to get lined up with what it is you want to look at. And once you do, then you're going to point at it and you're going to roll the wheel in and out to set your viewpoint, okay? And then if you need to change what you're looking at, just zoom back out, spin it back around, you know, and like I said, all of this stuff will become very second nature, okay? So that's what we're going to get to. Once we got looking at surfaces, we're going to look at this stuff over on the model tab. Okay, so there's, I mean, I could spend 3 days, 4 days showing you all of the little nuances of this, but that's just stuff that you'll have to trust me, it will become second nature. So go ahead and exit that. The viewer is actually 2 ways you can exit. You can close the little red X in the upper right corner, or you can choose this little go out the door icon at the bottom. Okay. So go ahead and exit the viewer and come back into the drawing. And now we want to talk about these break lines again and how to best do those. So I've got, again, some things that are down here at 0 elevation. So if I've got, and you may not have those points, and that's perfectly fine. And I'm going to go to 23, 24, 25, 26. I can't. All right, so 23 through 26, 23 through 26, 28, 27. Okay, good. Now, so there's my little house, and you know it's a 2-dimensional thing, but it is at elevation 0. Okay. I could have that at some other elevation. And it can be, like I said, it can be planar. So if I take this guy, and if I copy that, and I'm just going to put it right here beside it, and I'm going to select it, and I'm going to go over to its properties now, and I'm going to give that an elevation. I scroll down, I see an elevation, I'm going to give that an elevation of 100. So now I've got 2 things there, and in plain view, they look like 2 houses side by side, right? But I'm going to have those in different, you'll see them when we get into our viewer and why it's vital to learn that viewer. So now what I want you to do, you've got, everybody got your points out there in your screen. You've got like 22 points at least. I want you to go to the draw menu and choose draw 2D polyline. Okay. Now, there's a couple things I want you to set here. I want you to make sure that you do not have this checked autocorrect for 90 degrees. Okay. I want you to make sure up here at the top, the elevation is set to 0. And then down below where it says polyline properties, make sure this use current drawing properties is unchecked. And then where it says layer, I want you to just highlight that and just type my drawn line work or something like that. Just some name that you know is not in the drawing. And then I want you to hit the set color button underneath there and make this one red. Okay. And we'll say okay. And now it's going to prompt us to pick a point or a point number. So we're going to pick some points here. I'm going to zoom around and I'm going to say I want to draw from 15 to 17 to 19, 20, 21. That's going to represent like the edge of a ditch or something. So I'm going to go from 15. Now you can either, point to it, and you notice it's finally working today. Where I have this settings, point object snap is on and off. So if I hover just over any part of those attributes, you see the little snap feature comes up. So you can do it that way. You can just click, 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 or you can type the numbers 15, enter, 17, enter, 19-21, enter, and then enter to finish. Okay, so you've just drawn a 2D polyline that is through these points. Okay, now this is getting to that question earlier about, do these break lines need to be 3D? And so here's what's going to happen. And this is how you prepare those. So the next line I want to draw is I'm going to go 14 to 16 to 18 to 22. But this time I'm going to change something. I'm going to go back to draw 2D polyline. And again, it's 2D. I'm going to leave it set to red. I'm going to leave the 2D options, but up here where it says elevation, where it says 0, I'm going to go to the right of there. I'm going to say set the elevation by the first point. And you're going to see what happens next. I'll say okay, and I'm going to go from 14. Now you have to make sure you use the point. So type the number 14 so that it reads that elevation, or snap to the node or something. And so we're going to go from 14 to 16 to 18 to 22. Okay. I now have 2D polylines drawn at that location. Now, if we want to verify this stuff in our viewer, I'm going to go back to my view, 3D viewer, drawing viewer. It asked me to select the entities. And again, you could get all and look at them here, but I'm just going to select the few that I want to see. I'm going to say, take these. You may or may not have the houses, don't worry. When I do have the house selected, remember I raised that house up to be 100. Okay. Now my box shows, and there's let's put my box on. I'll go to settings. I'm going to make that box with labels. So you see, it's the label. So there's 116, 131, 147. So down here is about elevation 100. And that's, you see that building? That's that building that was set at elevation 100. But look at this. What's going on with this line here? This red line. And it looks bent. It's bent horizontally, but it starts at that elevation where that point is. You see, I'm going to go right and look at it edge on. So it started, it started at the elevation of the first point I picked, and it stayed 2D, all the way. And so it didn't change elevations to come up to it, but it started at that same elevation as that first point. Those other items aren't even on there unless I go back to my view control and uncheck, ignore 0 elevations. And now you can see but I do see them. Now they don't line up exactly with these points over here because there's some perspective going on. You see there's a vanishing point to the bottom. So, but those are the things that are down at 0 elevation, and here are the things that are not. So you see the floating building, you see the one that's down at 0 along with its points. You see my polyline that went through these points, but at 0 elevation. So if I then check on to ignore the 0, I'm back to where I was. Put that back without the labels. Okay, now I'm going to exit the viewer and we're going to draw the way that we need to draw this. And that's as 3D polylines. Now, one of the things is too, is that if I draw these as 2D polylines, I can convert those to 3D by telling it to read the elevation of these points and assign the elevation to those polylines. I can do that, but I don't think I can do that. I know I can do that from I can't really do that with the survey tools. In the civil tools, I've got tools to say, hey, create this as 3D by reading these points. Okay, there's other techniques I can do that with in survey, or just draw it again. So we're going to draw this again. We're going to go to the draw menu. And this time, instead of drawing a 2D polyline, we're going to draw a 3D polyline. And we're going to make sure that we uncheck the current drawing properties. And we're going to now put this on a layer called My Drawn Line Work 3D. And we're going to set that color to be green, just so we can see it differently. Okay. Now, before we hit OK, up here in our options box, and if you don't see the options box, type O down at the command line to bring the options up. And you want to make sure that this does not say that the second checkbox, prompt for elevation, make sure it is not checked. If it is checked, then every time you snap to a point, it's going to stop and ask you to verify that elevation. Or if you snap into empty space, it's going to assume you need to put an elevation manually. So make sure it's not checked. And we're going to say, okay, and now we're going to just draw the lines, and we're going to do the same thing. I'm going to go 15, enter, 17, enter, 19-21, enter, and then finally enter to conclude. I'm going to repeat the command just by hitting enter. I'll hit enter again. And I'm going to go 14, enter, 16, enter, 18, enter, 22, enter, enter. And now you should have something that looks like that. Now notice it looks exactly the same as it did a minute ago with the red lines. But what's going on, and what is going on, is this. If I just show you a little peek here, I'm going to press and hold the shift key, and I'm going to spin this thing up with my mouse. You see what's going on? But this is why I like this, the Carlson 3D viewer, is because if I do this, press and spin up with the mouse wheel, now I've got to go through the effort to get back to plan view, and it's going to reset me back to zoom extents and all that kind of stuff. And it's a bit of a pain when I want to lead my view just like I have it. So I'm just going to go to my view 3D viewer, So view 3D view drawing viewer. Now notice that icon, the tricolored cube, is also on this toolbar right here, which is called the surface toolbar. There's my viewer, because that's where I use it a lot from. So I'm going to click that tool. It asks me to select the entities. I'm just going to grab these right here, finish my selection, go into my viewer, and now I can see. All right, so now you see the nature of what's been happening. I've got one of these edges, these 3D, or two of the three are 3D, and they're going right through those points at those points elevations. This red line started at the right elevation, but it stayed planar. It's still two-dimensional, but it has elevation. So if I were to try to use it to model in my surface building, it would actually be red at that elevation, and it would assume that there are points along this line with that same elevation. That's why if you're going, you can actually make a surface out of a contour map. If somebody gives you the drawn contours and the contours are drawn at the right elevation, so you can make a surface out of that. It's not a very accurate surface. Okay, it's nowhere near as accurate as the information that went into making it in the first place. It's like taking a photocopy of a bad photocopy, and every generation of doing that, you get worse and worse because you keep losing information. But in any case, this is what we're after, is we want these three-dimensional edges to be part of our data, because remember, I can do this. If I draw a 3D polyline, again, this time I will prompt for elevation, and I'm going to go from right here at, say, 150, and I'll go over to here at 152. And I'm going to come back over to here to 148. And maybe I'll even cross over to here to 155. And then I'm going to go to 19. And I'm going to go to 18. And then I'm going to type C to close. And let's just change that from green to be blue. I'm going to now put that in my viewer. And so what I'm trying to illustrate with this fact is these other green lines got their elevations from reading points, because I drew them from point to point to point to point to point. And that's the way most of our edge work, most of our break lines are going to be done that way as surveyors, because we're going to survey the points. We're going to bring them back in the office. They don't have to be done from points. So as you can see, that blue line that I drew, even though it does go through two of those points, but they were just points out in space, and I typed in the elevation for them. So you see that they're there. And those points will also be used in the triangulation. And they serve two different functions. One is if I were to do this, now I can't cross these. So that would not be something that I would normally be doing. So I'm gonna keep these from crossing over those other lines. Because I don't want to cross them, because if I do that and try to make a terrain model out of it, it doesn't know what elevation to assign to the point where those two intersect. Okay. So in any case, so here's a situation where I've got these different elevations, and I verified that with my viewer. So what will happen is when I go to triangulate this, the computer is going to sit on every point it can find. Let's say it sits on point 21, and it starts looking all around itself to try to find other points to connect to. So it would be able to connect down here to 22, because it can see it. There's nothing in the way there. It can also connect up here to point 20, even though it's along that line, but that line is not keeping it from seeing it, okay? And it can, I guess that's about all it can find. It can also find this point up here because see, it doesn't have to be a Carlson point. It's any kind of three-dimensional corner. So a vertex of a three-dimensional line will serve as the corner of a triangle. But this green line down here is going to keep 21 from looking across it to see this corner and this corner. Okay, now it could, I guess it could, yeah, I could come down here and see this. Okay, down to this corner, unless 22 has already done its triangles and it's drawn up here to this corner. And now there's a barrier across that keeps 21 from looking down here to see that. Okay, so that's the nature of how these work. This bottom edge down here, for instance, if you can visualize the shorter green line up here being the one edge of pavement, and maybe this longer green line is the crown of the pavement, and this bottom blue line down here might be the other edge of the pavement. That's what keeps the triangles from going from the left edge straight across to the right edge. Because if we don't have this center line crown formed in between, it lets those triangles form all the way across edge to edge without climbing up to the crown of the pavement. But if we do have it there, it's going to force all of the triangles to go up to and only up to that edge. And that's where it's going to break that triangulation, hence the term break line. And then points from the other side can only go up to there and it can't see across it. So that's what you need to visualize when you're doing this kind of work and this kind of data. When you're building break lines, you are putting little walls up that prevent points on one side of that wall from seeing things on the other side of that wall. Otherwise, you're going to get things like right in here. Now we saw this over here. We saw these points along this edge can look up here and see these points and all these triangles form. But if we put in our boundaries all along this outside edge, then that's going to keep these points down here from looking up to here and seeing these points because they've got this boundary around it now as that outside break line. And that's going to keep those invalid triangles from forming in there. Right. Everybody got that? Any questions on that part so far? Everybody good?
We're good.
Okay. So let's take a look at a file that's got a lot of data in it and see if we can, glean some insights here. If you can either save or close this file or whatever. So the file we're going to open next, we're going to go to File, Open, and we're going to make sure we are in our working folder, which mine is this one called Data Sets. Make sure you're there. Look in your current folder files, and you want to find Sample from T3 Global. And it looks like this little preview picture, which is open, and it's going to come up and look like this. And give me a thumbs up or unmute and say, I got it whenever you got this loaded.
Got it.
Okay, good. Tim? Kevin's good?
Yeah.
Gives me an error.
Okay. I'm sorry, somebody talked over this. That
No,
was
sorry.
a
I was
yes?
saying it's fine. It's just I get an error message that it's missing an SHX file. It's not a big deal.
Oh, yeah, that you can ignore. Sorry about that. I'm not even sure which one that it's missing, but it doesn't matter. This file, by the way, is actual live photogrammetric data. Came from a company here in the Pittsburgh area. It's actually owned by one of my very best friends, the guy that I moved to Pittsburgh to work with back in 1993. I came up here for a temporary job, and you can see how temporary that became. So in other words, And he now has wound up owning this company that he was working for at the time. He was head of the edit department. So anyway, what we have is what looks like a bit of a mess. Okay, and so we've got, if you zoom in and sort of pan around, you can recognize some things that look like a road intersection, which indeed is what it is. You see some contours, and there's some contour labels, and there's, you know, parking areas, and you can see building outlines and what looks like curbs, that sort of thing. Okay. So, and this, like I said, is just, it's real data that was really observed in a photogrammetric stereo compiler. And if you see these little pink dots, let me turn this on so you can see them better here. I'm going to change my point style to be these little X's. And let me make them a little bigger here. There you go. So you see, I've got all these little points all over the ground. And you can see, so all of those points were things that were observed. Now, if this were not photogrammetric and it were done by field survey, that means somebody went out there with a level rod and somebody shot those, every single one of those points. Okay, they just walked a grid here. You see they're fairly evenly spaced. And so what these guys in the photogrammetry company do is they put that little floating dot on, they drop it on the ground, record the elevation, drop it in. So, you know, they can see that as a three-dimensional object. And so they just put all those down there. And then they also, if you look over here and you see this, this is a break line edge, and they've done the same thing. They've clicked that little floating dot on the ground, and they've got it right where it's supposed to be. They went zap, recorded that elevation. They came down the edge, zap, recorded the elevation. So they're doing exactly what we would do in our drawing by drawing three-dimensional edges. They're doing it in a specialized machine. Okay, so that's all of this kind of good data. Now, let's get those points back to my default condition here. So now there are also these contour lines. Right? So those contour lines, and you might be tempted when you get a deliverable. Now, you as surveyors are really going to be the ones that are preparing this stuff that goes to other people. You're not going to be getting a contour map from somebody else that you're going to then model from. But if you're an engineer, you might be, because you're going to hire a surveyor separately, or maybe your surveying department hands you something separately, and you now have to use it to do your design work. So the temptation has always been, and a lot of Carlson users, particularly engineers, they'll do this, and it just infuriates me, because there's some trainers out there that are training people to do this. They say, oh, you got a contour map, great, we can just build a surface, boom, bing, bing, bang, boom, you're done. Yeah, but there's a lot of errors that come about doing that. And just because they don't pop up as a computer error, it makes a terrible model. And they don't know how to check it, and they're using bad information. So here's what we normally have delivered. If you go to the view menu, I'll show you what's normally delivered. So you go to a view menu, and let's go down here where it says freeze layer by pick. Okay. You can also find that on the layers toolbar. You see what the icon looks like. So I'm going to choose that. I'm going to go up here in this upper right hand, or upper left, I'm sorry, the northwest corner where that little squarish looking white line is. And I'm going to pick that white line, and then I'm going to hit enter. Now what I did was I froze off a layer that was on there that were all of those break lines. And so this is what's normally delivered. In fact, I'm going to go and freeze. Sorry, I'm going to freeze one more too. I'm going to go down here and pick one of the pink points. Okay, so that's usually what's delivered, is just a contour map and some spot elevations. And if I were to view all of this in my 3D viewer, which I always do, I would look at this stuff and I would see, okay, well, there's my There's all my contours, and I see some spot elevations. Okay, so I got a few of those points that the photogrammetry firm made for me. And I've got some contours of some differing colors that they use. And this is why I like to use this without this, like all the Carlson people love this thing for whatever reason. I like to have them to say none, because I can tell, I know that those are different contours, they're different colors. And those are representing obscured areas where they're not really guaranteeing the accuracy that are in that, you know, it's under brush or some kind of tree cover. So, so that looks pretty good, right? And so a lot of times we'll go down here and we'll start to make the surface that we need from these drawn contours. Now, here's the danger with that. You see this contour that I'm pointing at right here on the screen. It goes up and comes down. That's the crown of that road. We obviously know how, you know, what that shape is, just from our experience. But here's what happens. If I were to look at that contour line, if I select it, it's got vertices all along the way here. Okay, where every little bend point, there's a vertex. Same thing with this contour line. Same thing with this contour line. Same thing with this contour line. In fact, let me get out of this so you can see those vertices. If I go to my settings menu, I'm going to set my CAD viewer. Say, okay, I'm going to exit. Now here I'm back in the CAD program, but I'm not in plan view. So I'm going to select this and this and this and this. Now, if I were to tell it, okay, use all this data and start building your triangles, here's what's going to happen. It's going to come in here and sit, say, right down here on this point of this, and this is a contour line here. Keep in mind, these are contours, so they are at the same elevation all along that contour, okay? So it's going to sit down here at this point, and it's going to look all around itself to find other points. So it's going to look over here. It'll see this point, and that's valid. Okay, so it goes from whatever this is, 101 down to, you know, or down to 100, or, you know, 114 down to 112, whatever it is. That's a legitimate assumption that it goes from this point to this point. It also goes from this point to this point. So those triangles are fine. Okay, so it'll go to the next one, look all around itself and start forming triangles. So this one maybe got drawn over here first. You know, from the first point drawn over here. So now that's in the way. So the second point now can't look back and cross it over to here, but it can go on down the line. So everything looks good to go there. So it works its way around. Now it gets up in here is where it starts to get interesting. So I get onto this point and I start looking across. I'm still making legitimate triangles, but if I get up in here now, I'm going to have to look so far away to draw these triangles. I get up to this point now, and I'm going to look down here and draw these triangles, and those are fine. But I'm also going to be able to look across the way here and see this point, and I start to draw triangles horizontally across this way. If I so, you know, maybe my computer has, you know, drawn something like this, whereas so it's coming along this line and it's drawing across to this edge and forming triangles there. And those triangles now are flat. They are the exact same elevation because they go from a point with this elevation to the other edge to that same elevation. And so that's going to make a flat triangle. But really, what this ought to be doing is this. Sorry, I should have drawn those as 3D. But it should have drawn. Should have gone from there to there. And from there to there. From there to there. From there to there. And maybe from there to there. And of course, from there to there is perfectly fine. That's that's do. Yeah, so these other ones are the ones that should have been formed. But instead, I'm going for these. Maybe if I don't have those break lines, I'm going to draw these across this little gap and make flat triangles. Like, let me make those 3D. Okay, now, so here's what can happen is how it can become a problem if we're trying to build something from contours and we don't have break lines. And that's what we call these little, these flat triangles. And you can see if I look at that in my 3D viewer now, you see the yellow ones? Let's see, I can't really tell. Let me do a vertical exaggeration here. All right, so those yellow ones are fine. See, it's going from these all the way down to those. Those are correct. But it's these red ones underneath that are invalid. You see how they're going from this edge all the way across to this other edge. Oh crap, I did this wrong. Sorry. One quick. Got ahead of myself. All right, so now we're going to go 2D to 3D. And we're just going to use those. There we go. That's what I meant to do. Now, let's go back and grab these and put them in our viewer. And you can see the yellow triangles would be correct. Those would be functionally correct. So they come down here and they go down from one contour line to the other contour line as a nice, even and consistent change in elevation. But the red lines that are going underneath there, you see, they're pulling that down and making that resulting surface. If I were to model this surface, it's going to make this triangle, those red triangles would be flat, whereas these yellow ones are inclined going up to the higher contour. So these flat triangles would say, hey, your ground is flat down there, whereas it's really going up at a slant. Okay, and that's the yellow ones would be correct. The red ones would not. So how do I fix that? And I would do that by something like this. Let me clear out some of this information. So instead of having instead of letting the triangles form haphazardly because they are just, forming from point to point along each of these lines, I need something that keeps the computer from sitting at this point and looking across and finding itself and putting a triangle edge there. So, let's say, what is this elevation? If I select that, that's elevation 1300. This is elevation 1299. So what's the elevation right here in the middle? If that's 1300, that's 1299. That should be 1299 and a half. Okay, right? From this to this. If, however, I have created, and I've allowed my computer to start building triangles along here, then this is 1299, 1299, 1299, and it's 1299 right here as well. And it needs to be 1299 and a half. So I need something to keep those points from looking across and seeing themselves. And that would be the red one here to represent. I would need something like this. I need to sort of let me draw. Okay, so I need this, and that's going to represent, so that's a road crown. So that's a ridge line. Now that's in 3D. I'm going to make that, that's in 2D. I'm going to make it 3D by elevating it. Across there. Now, if I look at that in my 3D viewer, you can see that I've now draped that along that road, like the road crown. And so that is going to be what I'm going to use to prevent, because that's now going to be a break line. That's going to prevent points from over here looking across and finding points on the other side. So now the only points that they can find are right here along this red line. So those triangles now are going to go from here up to this red line and then back down on the other side. So that's going to force that. That's going to be that ridge line that we originally met over here in our little concept discussion. Right here, we've got this ridge from 110 to 110, and if 100 can't look across it to see 100, it can only go up to these 110s. Okay, so that's exactly the same thing we do. So we would have to go through and draw this between all of those edges down these little nose-shaped contours. We do them also down these on the edges as well. This is the edge of the pavement. There's the top of a curb. Over here, might be a ditch line. There might be a retaining wall kind of thing that, all of these different things have to be done to be able to model this correctly from these contours. So the good news is, though, when it's done photogrammetrically, somebody else has already done that work to produce these contours. So what I want you to start to think about and to realize, contours are your absolute worst source of information to give you a model. So if you have a contour map from somebody, and if you can get more data than just the contours, don't use the contours. The contours only show you the truth of that surface along the path of the contour. They don't show you anything in between. We don't have any controls for there. Now, we do have some spot elevations here and there, and that's okay. But if you're just using contours, it's absolute the worst that you can do. So we go back to view, menu, and I'm going to go down to the bottom, toward the bottom. I'm going to say thaw on all layers and put everything back on. And now I'm going to go to my view menu, and I'm going to choose freeze layer by pick, and I'm going to zoom in down here. I'm going to pick on one of the contour lines, and I'm going to pick on one of the index contours, and I'm going to also pick on the text that had the label for the contours. So now this is what would normally be looked at. Ooh, I also got to get these obscured ones. So I'm going to turn off all of the contour information. I've left with what looks sort of strange in plan view, but these are just all of the break lines. Now, these would be the lines that we would have to go through and create as surveyors. And you can see there's some down the center of the road. There's some down this there's a sidewalk that runs on this side. And you see the traffic islands up here, and you see the curbs for the parking lot. You know, everything is there. In fact, if I look at that in 3D, let's just look at those two bits of line work in my 3D viewer. I'm going to now put my exaggeration back to 1. But if I, spin that up, you can clearly see that one is, sitting above the other. So that's a wedge curb. They've got the face of the curb down here, and they're leaning back to get the top, the top of the curb here. So now if that were a rectangular curb, they got one more line they need to get in there, and that's the top of the curb. So you got the face down at the pavement. It comes up nearly vertically to the face and then goes back to the back, and it would be a 3-line structure. But you see, those are all of those things we have to do. Now we're gonna create those by, we could go here and just shoot the point in the corner. Come over here and shoot that corner point, get that tangent point there, and say, hey, it's a curve. It goes around, hits that tangent point, the point, all the way in the back. If I get that and I tell it, okay, it's a 6-inch curve, so it goes up 6 inches in the air, it goes back 6 inches horizontally, and then I can recreate this entire structure from just getting pavement shots. Now there's a bit of an assumption, because I'm assuming that curb structure is exactly consistent. It's always 6 inches high and 6 inches deep. So if it's important to get it exact, you can't do that. You'd have to observe each of those points. But if it is fairly consistent, and really what you're after might just be the gutter flow elevations, you don't really care necessarily about that backline other than the fact that you need to model it, then you can create this 3-dimensional edge from these very scarce points. And then there's commands to offset that line. You can create a point that goes up 6 inches and back 6 inches. And so you can do those offsets all the way around, make it around the curves and everything else. Okay. So you don't have to kill yourself by getting millions and millions of points, but you do need to get the points everywhere things change. And then we would create all of these other things. Now, again, this looks like looks like a nice circular arc, but it's really not. It has to be done with these individual line segments because they have changing elevations. So I couldn't tell you what that radius is unless I drew a circle in there and but it's not really a circle. Right. All right, so they've gone through here photogrammetrically and compiled all of those edges, as well as some other things like these edges. These are just break lines in an open area. Same thing along their banks. And they use that to generate their contours. Now let's look at this whole thing in 3 dimensions. And it looks like this. And there you can see the points, and that's another reason I like Carlson's viewer, because it sort of magnifies the points, even though I can barely see them in my other view. And I'm going to go now and turn this box off. But I can see there's a whole bunch of points, and there's all these lines that sort of didn't make a lot of sense when I was looking at them in plan view. But I can clearly see what they are now when I can sort of spin this around. I see my curb islands up there. I've got some retaining walls over here across the street. They're there. And you know, I can clearly see, I can get a better picture of what this ground looks like now than I did when I was looking at the contours. Okay. There was actually a, you know, a loading dock right in here. And so that's the data that I want to use. I want to be able to make sure that when I do this survey work that I get these edges so that I don't wind up making the part of my surface, say from this point down here at the face of this curve, it doesn't jump up here and go across to the other side and try to form a triangle. See, I need to get those lines drawn in there so that they become proper break lines to keep points from, you know, one side of the parking lot from jumping across to the other. You know, so that's really the function, and that is the fundamental stuff that we need to know about, are how to, you know, how to gather those points and how to create break lines when we need them, whether we're drawing them in the office or whether we're determining them out in the field. And that's part of what field to finish does too, is it gives us by point code. We're going to say every time we shoot a code that says EOP for edge of pavement, we're going to say it's going to look for other edge of pavement points, and it's going to draw three-dimensional lines between those points, and it will build those 3D break lines for us automatically when we process it. It just runs down the point list. Okay. And that's the gist of field to finish. And there's a lot of stuff we can do with it. Right?
Yeah, real quick, Ken, I'm sorry. How did you adjust the size and style of each individual spot elevation again under points, and or is it edit points just so they're crosses instead of dots?
Oh, okay. That is a should be, well, I did mine here with settings, IntelliCAD settings, and this thing called point style. Now,
IntelliCAD. So I was doing
yeah,
it.
that's what I'm saying. So you don't have that. So you're going to type PD mode. That's point display mode.
It's not under just points. Under
I,
my pull down.
I wouldn't think so. It's a setting. You can right click and choose options. It's under there somewhere too.
Okay.
But if you type PD mode, that's your point display mode, and you're going to see basically this little chart that I've got showing here on my screen.
Yep, PD mode.
Yeah. And so that lets you choose. So I had these X's, and I chose to be 5% of the screen size instead of an absolute size or a percentage size. You can
Yeah, if I type PD mode, I get the prompt for a 2 or a number or something like that.
Oh, okay. You're not getting the dialog box. Okay, let me see.
Dialog box is what I'm looking for.
Yeah.
Settings.
Hang on, I think it's just easier to load this up.
I know in AutoCAD and Civil 3D it's under tool space somewhere, but that's a whole different.
Yeah.
Edit points maybe. No, I keep hitting that same.
No, it's a setting, and it's a setting, not a command as much. I mean, it is a command, but it's let's just go to this one here.
Because I switched them when you were first doing it. I switched them over to crosses instead of dots, and then I lost track of you when you were.
Well, you could type PD mode and then answer 1, I think it is. Might be 0.
Oh, that's going to give you the different survey point numbers, 1, 2, 10, whatever survey point styles.
No, that's the different thing. This is those numbers you see with PD mode or with these, there's point numbers here, but they're not, it's not 1, 2, 3, 4, 5. They're hex, I don't know if they're hexadecimal or something, but there's some kind of mathematical formula that determines the number of these, because you can see you look at all of the columns.
Okay, well, yeah, if you don't know right off the top of your head, that's fine.
Yeah,
Thank you.
no. Yeah, look at them
Right,
across
exactly
the
what you were talking
rows.
about.
The first row in that grid, there's nothing. The second row is a dot.
Yep,
The third row is a plus. The fourth row is an X, and the fifth row is a T shape. And then the columns, the first column is nothing. The second column is put a circle around it, then put a square around it, then put a circle and a square around it. So those are all things, and it uses that code to determine what that's going to do. Now, and when it creates that, those are still just single individual points. They're not drawn shapes with corners and things on that you can accidentally snap to. They're still just a single point. But anyway, where that is, and if you type PD mode, so yeah, it's just asking you for that. If you type point display, let me see if I can find set var. We're gonna do that, but
I guess I'm, that's fine. I'm good.
oh, here it is. It's the very same. It's in the very same place. Sorry.
Setting.
Settings, AutoCAD settings, point style.
Yeah, so simple. Thank
Yeah.
you.
Sorry, I just assumed that, okay, you don't have it, so it's gonna be different. No, there it is. All right.
Okay, so I can go back to my, and then,
Yeah.
that's the point style, so it's under settings.
Yeah, and the one that we normally use,
Size from there too, the
settings, AutoCAD settings, point style. And the ones that we normally use are this one, right? I'm sorry, it's this one right here, the dot. This one is nothing, so it doesn't actually create the dot. We want the dot so that we actually also get the point object when we create our points.
there you go. That's awesome.
All right.
Thank
You
you. Settings,
bet. Good question. I like that one. It was,
simple ones. Simple's
yeah.
good.
well, no, I mean, it should have been. So I've learned, I hope I'll remember that for the next time somebody asks me that. So there it is.
It's all right there, point size and style.
Yes, yes, indeed. All right. So anyway, that's there. We're running long again for the break, but that's what we're going to use to model the surface with. We're not even going to use those contours. So let's assume that we've created this data and we're going to use that to build our surface. Okay. So what we're going to do is let's take us a little break here. Let's come back at say 11. I'll give you till, let's go to 11:20. So 20 after. And then we'll model the surface and see the results, and we'll come back. And then we're going to need to spend the afternoon on the survey topics. So to put this one aside. But the exercises are there in the book to go through to really dig into that. And really to also let you know, the fundamentals class that we teach spends 2 days on this kind of stuff. Because we don't really have, we're not going into the specific civil design or survey, deed processing, all of that stuff. So, but really what we do is the first half of the manual, which is, let me get all the way up here to the table of contents. The first half of the manual, which goes through these exercises on points and point groups, and then sorry. Yeah, points and point groups, and then surfaces and contours, adding break lines, surface evaluation tools, and putting it all together. Now, that's a pretty intense little thing, but that's the fundamentals class. It basically goes through all this same stuff, and it goes through these, points and surface modeling, and goes through putting it all together, and that's the end of it. So then it starts into the survey module exercises on, say, page 58. If I can. It's funny. Yesterday I couldn't get the point snaps to work in AutoCAD or in IntelliCAD, and now I can't get the hot links to work in PDF or PDF view. All right. So, oh boy. Let me try this. There we go. So then once you get past that, putting it all together, which again, you'll have all of this information to be able to do this on your own. And it works with those files that are included that you've gotten in the data sets. Then it goes into the survey module. This is what we'll pick up after lunch. Is going to start this part off, say down here 64. So take these upper things, and what we're going to finish up here after our break up to lunchtime, we're going to basically hit this stuff pretty lightly. Okay, I'm building those surfaces, and then we're going to just sort of keep that. But I want to give you guys sort of a taste of that so you can start doing that kind of work. Know that you've got that power because you're collecting elevations on these points, whether you know it or not. It's just, we tend to say, well, I don't do contours, I don't do elevation, so I just throw them all away. Well, you're welcome to do that, but you have the information anyway, and this is how you're going to be able to use it. Okay, so that's really why we sort of focus on that as well. So, okay, so let's come back at 20 after, and we'll take it from there. All right. Any questions before we take off? Okay, I'll see you guys back here then. So we've seen all this data that's coming at us in 3 dimensions. We're going to use that to model our surface. It's going to put together all of these triangles. And here's the gist of how this works. We're going to let's build a surface a couple of times and see what some of these little tools are, and then we'll need to move on to other topics. But so let's go to the surface menu, which is going to be out to the right past annotate and before GIS. And we're going to choose triangulate and contour. Now it's called that because it's both of the commands all put together, because it will do it all at the same time. I personally am not like to triangulate it first, view it in a 3D viewer, look at it, evaluate it, make sure it looks good before I generate the contours, because all I need to create the contours, the TIN file. As long as I'm happy with the TIN file, I can draw contours anywhere, anytime from that file. That's just me. A lot of people like to have it all done in one spot. So no big deal either way. But let's run this command, triangulate and contour. And 10, here's another little thing about learning the software. If you look down at your command line, after you have run that command, you'll see that it'll show you on the line above, it will tell you what the typed command is. and that was TRI. Okay. And that would be true even if I'm just doing a plain old AutoCAD command. Let's just, if I type copy, of course, you're going to see it there. But if I say right click, copy, you see right up here, it's showing me the actual command that got run. So if you get tired of going to the survey or the surface menu, triangulate and contour to run a command that is just as easily done by typing TRI for triangulate, brings the same command up, then that helps you to learn the software and what the commands are. So not only do you see that when you run the command, but you also see it most of the time when you hover the mouse. I say most of the time because it's not showing. Well, yeah, some of those others, they really left a bunch of them out. I don't see why, but you see, if you hover the mouse over a particular command, at least most of them, it's going to give you a little bit of information about what the command does. In this case, remove polyline vertexes, removes the removes the user specified vertex from a polyline. And then it gives you the name of the command if you were to type it. RMVERTEX. Well, that's not very efficient. You might set up a quick keys called RV to substitute for that. You can do that under your settings menu. But anyway, it's just a little thing to sort of keep your eye on the command line and the lines above it so you can see what those commands are. So in any case, back to triangulate and contour. TRI. So now what we've got here are 4 tabs across the top, and they control this process and what happens. And there's huge, we could spend days going through this. We don't have that time. So what we're going to do is this. I'll show you some of the things to leave on, and we'll talk about the ones that are important to understand about. The others you'll need to dig out on your own discovery. But for now, somebody have a question, or was that a question, or I just heard something, but maybe somebody's got a mic and muted. Anyway, so now we've got these 4 things to do, and I'm going to skip you all the way over to the selection tab on the far right. I'm going to say, whenever you run this command for the first time during a session, I'm going to suggest you get in the habit of looking at this tab, making sure that none of these are set. Okay, because this selection, these are filters. And I had this set once where I looked at only, like I didn't have these CAD points, and Carlson points were not on. It was just the polylines. And I was missing the top of this little stockpile that I was trying to model. I couldn't figure out why. And I had this set from a previous session, several weeks ago, where I took the points out of consideration. So this is a filter, and it stayed active. So make sure you uncheck that you don't want to use any particular filtering on this. Now you can do that. You can also build, a lot of people get like these massive ASCII text files that have coordinate information in them, like thousands and thousands and thousands of points. And the tendency is to draw, locate points, and dump all of those points into the drawing file, and then do this and select the points graphically. You don't have to do that. You can read a coordinate file or an ASCII file directly without putting them into the drawing, and that keeps your drawing much leaner and more responsive. And so you can set up a particular format and all of that. So anyway, for now and for what you're going to start to be doing as you do this work, go to that tab, make sure there's nothing specified. So these top 2 boxes are not checked. Okay. Then we're going to go to the triangulate tab. And we're going to, instead of all of these other things, we're not going to draw the triangles. We're not going to draw the faces of the triangles. We're not even going to draw the slope errors, but we will write the triangulation file. Once we have that file written, we can see all of this other stuff at any point. So I'm not going to hog up my drawing with it. I'm just going to write this triangulation file, and I'm going to hit the select button. I'm going to look at my data sets, make sure I'm where I need to be, and I'm just going to type EG for existing ground, save. Okay, so now I've specified the file. Now, these next bits are some controls as to what gets triangulated and how it's looked at. One is to use inclusion and exclusion areas. And that means the inclusion areas are where we create boundaries around the data, and that keeps those long, skinny edge triangles from forming. Exclusion areas are places where you don't know anything about the surface underneath that area, like perhaps a building footprint or a pond or something like that, if you wanted to model that as an exclusion. Now, what happens mathematically is that it is non-defined in terms of that surface. So if you were to try to compute earthwork volumes and all of that, it's just not defined in that area. It just wouldn't compute things. So, so for right now, I want you to uncheck that box. And the next line down says shrink wrap the perimeter reduction. Leave that set to none. Erase previous contour entities. Leave that as off at the moment. Now, ignore zero elevations. You do want that checked on. And I would set your maximum and minimum, or your maximum edge length for the interior set to 2000, for the exterior set to 2000. Now, that's another way that some software, and you're welcome to do that, can control those long, skinny triangles on the edges, is you can set a maximum length of something like, I don't know, 100 feet, 500 feet, something, so that it throws away those long, skinny ones, right? And it will only do it on the exterior. So, but that's also controllable with some other things. And again, you're going to see that discussion. Let me find it over here, Porker. You're going to see all of that discussion with those boundaries, and it's to put these boundaries so that these long skinny triangles don't form. And then you're going to see that with part of this exercise is to do these shrink wraps, where you can shrink wrap the data, or you can just simply draw a boundary just freehand. You do the same thing. But this is all pretty thoroughly gone over in these exercises, and we don't really have the time today to delve into them. They're usually part of that fundamentals class as well. All right, so we're going to leave this off. We're going to generate these triangles. I want to show you where they are and a couple of ways to deal with those. So if you'll match everything like this, and I'm going to uncheck this densify break lines, and everything should be set the way I want it here. So now before you hit OK, let's look at the contour and labels tab. Go to the contour tab, and we're not going to draw contours. So I'm going to uncheck. If this is checked, I'm going to uncheck it. Okay. And again, I'm doing that because I want to look at the surface and evaluate it before I commit to drawing the contours, because I can draw those contours at any time as long as I have that file saved. And so if you've unchecked draw contours, if you look on the labels tab, the entire thing is grayed out because we're not going to label any contours. We haven't drawn any. Okay. So now this is it. I'll say OK. And read your prompts carefully. It says select entities. Well, make sure you read the line above. Anytime you see select entities, read the line above, because some commands have to ask for different things And and this command, depending on what you set for the exterior boundary, the inclusion and exclusion polylines, if you turn those on, it's going to prompt you for those. If you don't, it doesn't. And all it says is you look at that, it says select entities. So a lot of people, when they then turn it on, and it's really asking you for the inclusion polylines, but it says select entities, we get all excited. We just start typing all, or we select a window around everything, and it's trying to set this data now as the boundary polylines, which it clearly is not. So make sure you read the line and just make that a habit. If you see select entities, read the line above it. Right. So it wants us to select the points and the break lines to triangulate. Now remember, in Carlson software, when you select data and we're going to use a break line, there's no particular thing that you have to go through to tell the computer that, hey, this line is a break line. It's just a break line by virtue of the fact that it exists. Okay, and it would be at elevation. It can be at 0. You know, you could consider those at 0, but we typically don't. They're just means of letting us draw things at 0 and then ignore them. But again, if it's just simply selectable and selected, it becomes a break line based on that algorithm of the Delaunay criteria that is used to create the triangles. Okay. Other software, you have to specially designate them. You have to put them on a different layer, or you have to tell it, hey, these are break lines. But here we do not. If it's there, it's a break line. All right, so it wants us to select all of the break lines and all the points. So I'm going to go up here and just grab my data. I could have typed the word all, hit enter. It says I've selected 2,487, select entities. So I could at this point type R to remove if I wanted to take any out, or I could type A to add more. I just hit enter to finish. Now this is going to come up and it's going to bring a little error box over on the left that we're going to sort of ignore. I'll show you what it does. It points out where it finds errors, and there are 3 different kinds of errors. There are crossing break lines. There are T intersections, which is really just a special case of a crossing break line, except one of the lines does not go all the way across. It runs up to and stops. And the other is a vertical edge. And those are, if you consider what's going on, the computer needs to know, hey, I am at this particular XY location and I've got 2 elevations. Which one do I use? And that can happen when break lines cross or when they meet at a T. So each one of those can have 2 different elevations, or you could have a break line that is bebopping along and then it gets to a point and then it drops or raises to another point with a differing elevation, but exactly the same X and Y coordinates. That becomes a vertical edge, and they're not allowed in our surface modeling for triangulation simply because they are ambiguous. Now, if we were to just say exit, it would go on and process because the algorithm is going to use one of those elevations, and I don't have any idea which one it decides to use. But at some point, like at this number 1 right here, that's 0.321 feet difference. And I see it's pointed at right in there. I'm going to zoom into it here. You see it's where a head wall is modeled. There's another illustration of the 2D, 3D. So this is where this head wall is modeled. You know, say the top of the wall and the bottom of the wall, and one crosses over the other one. So the guys at the photogrammetry firm got in a hurry. You see, well, that shouldn't be crossing. One of those should be inside the other. All right, but I'm not going to take the time to fix all that right now. I don't, you know, but you would normally do so. And I'm going to zoom to this one. There's also a place where this little line comes down and it hits in a T intersection, and it's 0.08 feet difference. So, they compiled this edge and then they compiled this edge. And then when they trimmed it back, and there's sort of a difference there. So it's not really much, but it is, in fact, where there's a difference. All right. I'm just going to say exit and let it go ahead and build the surface that it builds. Now, let's take a look at it. I didn't draw anything, but let's look at where it is. And I'm going to go to the view menu, my 3D view. And this time, instead of using the drawing viewer, I'm going to choose the surface file viewer. And I'm going to be in my folder, and I'm going to find that file. It's also down here in this bottom where it says recent files. You'll see a picture of the outline of it over on the preview. And then I'm going to say open. And it's going to load up in this viewer. It can take many different forms. Its basic form is like this, is that it normally will load it because it's reading this triangulation and it's reading all of those triangles. So it's going to load into this viewer all of the triangles that got created. And that's all it's going to load. We don't see those lines. We don't see the contours and all that kind of stuff that are in here necessarily, but you see all of these nice triangles. And if I remember my garage door analogy and I start pushing it up and leaning it back and pulling it around, I can see all of these different triangles that got formed that become part of my surface. Now you can quite clearly see, in this case, over here on this left-hand edge, those long skinny triangles, and down here on the bottom edge, there's another set of long skinny triangles that are not valid. We should have had a boundary around that. That would be one way to take care of that. But here's the other thing to consider. You could go ahead and just leave the surface defined out there, draw your contours, and they'll draw out there, even including going across those long, skinny, invalid triangles. And then you could trim those contours back and deliver that to your client. And that's, he's got a contour map where your contours only go out to as far as you've got meaningful data and you've trimmed it back from those edges. That's also a valid approach. Okay. Well, let's see what our viewer can do for us now, because we're in a slightly different command mode. We said, look at a surface file viewer instead of the data or the drawing viewer. And so there's one big difference here, and that is the arrow selector in the drawing file viewer, when we're only looking at things that from the drawing, it lets us, pick on things in the drawing. It would tell us what layer it's on and what elevations it is and stuff. But when we use the point or the arrow icon in the surface file viewer, it becomes down here this 10 edits where you can do things like swap an edge, add a break line, remove a point, remove a triangle. And that's another thing we can do. If I remove a triangle, and say, and it wants me to go over here now and pick it, I'm just going to double click. So you might see I'm getting rid of these edge triangles. Now there's too many of them for me to really make this an efficient workflow. But you can certainly do it that way. And you could get rid of those invalid triangles. And once you're happy, when you exit the viewer, it's going to prompt you if you want to save the edits. Okay, so that's something that you can do with this if you go into it through the view triangulation surface or view a surface file viewer. When you go into it from the drawing viewer where you select elements in the drawing, that is not one of the options. Okay. So on the settings tab, also when you're looking at the surface file, you can choose to display contours, yes or no. And you can establish a contour interval. And it's just, you know, it's whatever number you want to use. I'm going to use 1/10 of a foot. Oh, see, it's going to actually try to draw those contours at every 1/10 of a foot. It's a little ridiculous because it's not very accurate there. And I think we had 1 foot intervals, up to 11. The 1 foot intervals, I think, is what our mapping has us, and that's what it would look like. And when you say this display contours, you give an interval. There's also a set colors button where you can tell it what the contour color is going to be. But notice my triangles here are still sort of, you know, they look like they're open triangles. Looks like it's only drawn the edges. If you go back to the view control tab, that's what this other button is on the bottom row that says toggle the shading of surfaces. And so when you toggle that, it turns it on, turns it off. And that helps to see this thing in a little better perspective. And now I can control the lighting. I'm over here on this blue ball now, the contrast, the brightness, and I can even control, you know, the direction that the shadows fall. So if I'm over here lower right, this area here that I know is a pond, it looks to me like it's sticking up in the air. I look over here on the left and what I know to be a little rise, it looks to me like it's sunken in. And that's just because of that perception bias that we've got baked in based on what Madison Avenue has shoved down our throats all our lives. So try to keep that light up there in the upper, you know, the northwest part of the sky, and it will cast our shadows down to the right. But also use it for things like, let's say we get down and I want to look at those. Okay, so I'm seeing that, you know, there's a little bit of a little sidewalk here at the bottom of this little hill before it gets to the road. Well, if I want to see, you know, maybe I want to see how the shadows cast, you know, I can drag it around to different sides. Or if I want to see, you know, one side illuminated and the other one in shadow. You know, so use it. Don't be afraid to move it, but just realize something might look a little goofy. Now there's a case of there's that loading dock, and you see over here across the street those retaining walls. I look down here at the little parking lot. I see those curbs. Okay. And now you see my contours, and they happen to, oops. If I go back, viewer, sorry, I didn't mean to exit this. So these contours that I'm displaying here are, again, on the settings tab, and I just choose to display the contours, yes or no. I can look at the triangle edges over top of the shaded triangles. I don't generally do that, but if I do this display contours, I can choose the interval I want. Like maybe I only need them every 5 feet. So a bigger contour interval. So these are computed on the fly in memory, and that's where they're displayed, and then they throw them away. Now, if we look at this in our plan view, I see that I get contours out here as part of these long skinny triangles. So the ones I would believe are the ones that come up to, you know, what's visibly this top of the bank. But all of these others, those long skinny triangles that you can see here, let's even do it like this. See those long skinny triangles, they're not very valid. Okay, so I need to either get rid of them or successfully ignore them when I get done. All right. So those triangles, or I'm sorry, the contours that you see If I were to just go out into my drawing and draw the contour lines and hand that into a client, well, that's going to make me look foolish because these contours over here do not do this. That's strictly a result of those long and skinny triangles. And I need to be aware of that. I need to know how to deal with it. So I'm going to exit the viewer and let's talk about how to deal with that. Let's go to the surface menu and choose contour from tin file. It's the third command down. Let's select our file, choose open. And now you're going to see a dialog box that says triangulate contour labels. It does not say selection, but it's essentially the very same command as that triangulate and contour. I said this time it's just to contour, but we still have these controls on the triangulation side, except for writing the file, where we can restrict it to only certain polygons, polylines that we say, or don't triangulate, don't draw the triangles here, but draw them out there. So that's one thing that we could do, is we could say use an inclusion exclusion area, and we can have it basically trim out. But if we do none of that right now, let's say ignore 0, everything's off, that looks good. Let's draw our contours. We're going to go to the contour tab and say draw contours. And we're going to give this a layer. Now mine says V-surf-cont-int. That's for my intermediate. I'm going to set my contour interval to be 1 foot. And then I've got a checkbox that I need to turn on to draw index contours, which means put them on a different layer. There's my layer name, V-surf-cont-idx. You're welcome to call them IT and index, or min and max, or min and main, anything you want. It doesn't matter. Just make sure that you've got the contour interval set to 1 and 5 for the index. Everything else unchecked, no smoothing. And then we go to the labels tab, and we will label the contours. Again, put whatever layer you want, or just take the default. And we want to not break the contour at label, although that's an option, because that's going to physically cut a hole, a gap in the contour line. We're going to simulate that with this checkbox on the right-hand side that says hide the drawing under labels. So if you turn that on, it's going to just draw a wipeout under the label and make it look like it has broken the contour. And then of the other checkboxes, we're going to put on label index contours only, align with the contours, draw on the real Z axis, and then the internal label intervals. We're going to choose a distance interval of every, say, let's go every 400 feet. Okay. So if you'll match that and then say, okay, it's going to read some stuff. It's going to give you some warnings. It's going to do blah, blah, blah. And it's going to then draw your contours. And by default, when it first comes up, they're going to be red and white. But we're going to fix that in just a second. So let's go to our layer manager, layer control. From the view menu, layer control, or it's the layer manager, however you want to get to it. Let's find those layers that we were just using. And mine are called V-surf index and intermediate. And I'm going to set these to a little bit different colors. I'm going to make my index contours color 254. And my intermediate contours, I'm going to make 252. I think this will work. And I could even change the contour line type. And see, I don't have any particular ones. I'm going to wish there's a problem with that particular file. All right, so I'm going to come down here. I'm going to scroll this down, and I'm going to find this one called, where's my one called contour? Let me Sort. I'm missing. Line 1 to a 2. I know I need that one anyway. Let me change this to a different file. Okay, resources. Let's go to. Doesn't matter. Let me see. If I go to. The problem is that I've got to drill down so deep. I think it's under users. Maybe it's under program data. Well, it doesn't matter. I'm not going to track it down right now. Anyway, you can have those to be dashed and dashed to and all that. Let's just use those. My index, no, that's what I want for my. And I'm going to use dashed for the other. All right. So let's try that and see what that looks like. I'm going to say an LT scale, make sure my LT scale is 1. IP engine is set to on. I'm going to now scroll in here, select this one and this one, and right click and choose select symbol. Set my line type generation. Yes, I'm going to set my line type scale to 2, maybe 5. Try that one more time. Set that to maybe good. Or let me do this. So this is all just here we go. This is all just cosmetic stuff that I'm doing here. I wouldn't don't worry about grabbing this at all. So I'm going to select this and this. Select similar. Select the line type scale. That's 0.5. Okay, so they're going to look a little bit more like contours, but no big deal. Now, what we have drawn here are some contour lines, and we still have all these other 3D lines. If I select that, I see it's on a layer called V-Topo break line. That was those original break lines that photogrammetrists gave us that we used to build our surface with. And here we can see them. And our 3D viewer, as well as seeing our contours. But you see how there's a line that runs down the center line of that ditch. There's a line that runs across the edge of that little pad. There's a line that runs down the face of that sidewalk out in the street. And the crown of the road, there's a little bit of a broken part. There's a lane that's actually up here separated. The exit lane as it starts to divide the highway. Okay. These. So that's all of those break lines. Now I don't need them anymore. I've made the surface. So I'm going to go to view, freeze layer by pick, and I'm going to go up here in this upper left-hand corner and just pick one of those lines. So now that would be, this would be what my contour map would look like. Okay, and these contours over here on these little long skinny triangle edges are no good, but I have to know how to deal with that. If I were to deliver this to my client, I would be a little remiss. Okay, so there's a couple of things we can do there. One is this. Let's isolate some things and use them to trim some data. Now I'm going to draw a 2D polyline. So I'm gonna go to my draw menu, draw 2D polyline. I'll make it red so I can see it. I'm gonna put it on a layer called BDY, just boundary. It's my surface boundary. And I'm just gonna draw this polyline. I'm going to, because I'm drawing, I don't want to snap to everything and have to turn it off. I'm going to turn off my snapping. And I'm just going to arbitrarily draw from, this corner up to here, over to here, up. And I'm just sort of drawing. Where my data is. I'll type C to close. Now let me put this on a little thicker line type so you can see. All right, so there it is. And I might even say, okay, well, I want to sort of match this. I'm going to select it. I'm going to hover over that middle grip, convert to an arc, and I'm going to, shape it like so. Because that's going to be the extent of what I turn in. So that's going to clip off these bad contours out here, same thing out here on this end. But I'm going to use that in a couple of ways. One of them is just simply graphics. So I'm going to now isolate. I'm going to go to view. I'm going to isolate layers. And I'm going to pick one of the intermediates, one of the index, one of the labels, and this red boundary. I'm going to hit enter. So now the only thing showing are the contours, the labels, and the boundary. Okay. Well, I've generated this. I've got these other things, and my surface still exists out there, but these contours are going to get fixed here in just a second. I'm going to do that by going to the edit menu, and I'm going to erase. And I'm going to erase by closed polyline. Reading your prompts, select the perimeter polyline. So I'm going to pick that. And once you pick it, it then asks you, okay, what do you want to clip? Anything that you're going to use that line to cut away with, what do you want to cut? And you check on all the ones you want to be effective. You can have them all on if you want, that's fine. And next, you want to erase on the inside or erase on the outside. I'm going to go to the outside. I'm going to say, okay. Voila, it's done. I can now restore my layers from my view menu. View, restore layers. It puts back what I had before. And I could then freeze my boundary if I want. And that now, you see, would be what I would deliver my client. And I no longer have those invalid areas. And if I look at this in my standard viewer, see, I no longer have those goofy looking things out there in those corner areas. So I'm in decent shape with what I'm going to deliver. Now, I see there's some straight points out here that I probably would not consider. Right, so that's one way. After you create the drawings, oh, by the way, I'm going to go here and go to my model tab, and I'm going to add a surface just so you can see it. I'm going to just basically superimpose the surface to these drawn entities, and you can see the results now of me clipping. Now, all of this stuff out here was invalid, although I really could have come up a little further up this hill to get a little bit more information out there, maybe down here as well, and come back. Or I probably clipped it a little too close, a little too far. But In any case, you see the surface file is still there. We still have the contours. Now, all we did was we drew the contours, we drew a boundary, and then we clipped it by that erase command, okay? I'm going to go to my surface manager. I'm going to find that BDY and I'm going to thaw him back on. And I'm also going to show you another way of doing this. It's sort of doing it beforehand instead of after the fact. So I'm going to, I need to erase all of these contour lines and labels that I've drawn before. So I've got those 3 layers. Those are the ones I want to erase. Now you can isolate those 3 layers and then select everything and delete it. Or let's go to the edit menu and choose erase and choose erase by layer. One of the choices is to select the layers from the screen. I will do that. And I'm just going to select one each of the label, the contour, the index contour, and the intermediate contour. And say, okay, boom, they're done. Now, I'm only left with the planimetric stuff that I drew, that they drew on level 0. We've hidden the break lines. We still have a surface and we still have a border boundary. So just like we did before when we drew the contours, let's go back to the surface menu and choose contour from tin file, 3rd guy down. We find the tin file and we say open. This comes up, and before we drew all that, and then we use this to erase on the outside, but we can do this as part of this. Is we're going to say on the triangulate tab, this first tab at the top, these 4 check boxes at the top, go down past them to the one that says use inclusion exclusion areas. Check that on. And now I'm going to say okay. And it says select entities. Well, make sure you read what it's asking for above. It says select the inclusion parameter polylines, and it could be more than one, but we have just one. So I'm going to select that one. And then it says, I've got one entity in my set, select more entities. No, I'm done with it. I just hit enter to finish. And now it says again, select entities, but look at the line above. It's changed. It wants to know the exclusion perimeter. So maybe now at this point, I'm going to go over and get these building outlines, because I don't want to contour through my buildings. This ruins, I might let it contour through that, because that might just be you know, a little concrete pad or something. Now, I've got canopies, so I assume that the ground is visible into there, but these buildings would not make it visible. All right, so there I go, and I hit enter to finish that selection, and now the contours are going to draw, and they're only going to draw up to the edges of those things I selected. Okay, so now the contours don't go through the buildings. They do go underneath the canopies. They do go across the ruins, but they stop at a nice, neat edge. And if I were to go back and look at the surface file in my surface file viewer, my 3D viewer, I'd see I've still got surface out here, and I've still got surface under these buildings. Okay, so that's another technique of doing it. Now, here's yet another option. Let's go back and choose edit, erase, erase by layer. And let's just go ahead and leave the layers that it's already found in there and just hit OK. And it's just going to clean out those contours. I'm going to also go back to my layer control manager, and I'm going to find that layer that I had, and it's frozen, called V Topo break line. And I'm going to turn those 3D lines back on. Okay, but I'm going to keep frozen all of those pre-drawn contours and obscured contours. So now, everywhere you see those white 3D lines, that's the data that I have. And you see when I drew my little boundary on the inside, it restricted the drawing of the contour to my boundary. So I could have gone out a little bit further to incorporate up on the north and on the west. But in any case, it's just a polyline. So there is another command. Again, you can draw that yourself, or if you were to select that drawn boundary and get rid of it, there's a command that you used to use out here on the draw menu that's called shrink wrap entities that would create that for us. I'm going to choose that command. I'm going to allow it to go across gaps because I want it to jump across those little gaps. And I'm going to set my perimeter reduction here to low. And I'm going to just draw a 2D polyline. I'm going to say, okay. I'm going to grab all my data out here and let it go. And I forgot to tell it the layer name. So, or I did, but I gave it the wrong layer name. All right, so that's where it finds the edges. So it gets a little more of this data. It's also sort of chippy choppy around the edges. And again, it's just a polyline. So you can change this all you want, just like making edits to a regular old polyline. I can make that curve. I can take out let's see here. Come on, trying to get my mouse to come back. I can, take out these little inflection points to sort of straighten it out a little bit better. You can do things like that. Now notice I'm just doing the old grip hovering edit technique, standard AutoCAD technique. There's a Carlson command up here where we'd say remove polyline vertex, which is even quicker. So if I click on that, I see where those vertices are. I'm just going to click near where these are. I don't even have to be all that precise. And so that would then define a new shape as I go through this. Now, all I really do want to do is just to show you that that tool is there and where it is. It doesn't really matter for this. Okay, so I just want you to know that when you shrink wrap that boundary, it is just it's just a polyline. That's all you're left with once you're done. Now that boundary is now usable not only to draw the contours from the first surface, but we can also use it to make a second surface, which we're going to do. We're going to go to the surface menu, triangulate and contour. And we're going to say, this time on the triangulate tab, we will, so I'm going to come down here in the middle, we will use the inclusion exclusion areas, but we're also going to jump back up here and make sure we check back on to write the triangulation file. And I'm going to hit select, and I'm going to call this a new file name. I'm going to call this EG-2. So we'll have both these files. We have the first one and then this one. And they'll be stored out there on their disk for us. So I will now use these inclusion and exclusion areas, and I'm going to set the control is to trim the edges instead of removing the edges. So that basically is like pulling teeth out on the edge, and we've got a lot of possible gaps. That should be all I need. I'll say, okay. Select, now read your prompt, select entities. Remember the last time I told you it was asking for you to select the points and break lines to triangulate, but now it wants to know the inclusion perimeter polylines. I select it. I'm finished selecting those. I hit enter. Select entities again, but it's asking for exclusion. So at this point, I could go here and select these building footprints. Just like I did before after I was drawing the contour. So Even it doesn't make any difference in terms of excluding the drawn contours, but it does make a difference with what we're doing now. So I'm finished with those because now, sorry, just did the wrong thing. Pick my exclusions. I was trying to talk and do the same thing at the same time, and that was my problem. So, but now what we're doing when we're using these inclusions and exclusion is not about simply trimming out the contours. It's actually going to trim out and not define the surface file itself. Okay, so now I'll get all my data. And I'm going to ignore these break line crossings again. And so now, same contours, I'm going to freeze these little 3D lines. So I got the contours, but I'm outside a little bit further. In fact, I'll even freeze that. So that would be a more valid contour file to give to somebody. And come here. Set my dash pattern down a little bit further. So now, so that would be a bit more of a realistic contour file to deliver because it comes down here and I can see that when I view this in 3D, right, sorry. So now you see over here on this left-hand edge, I get a little bit more of the hillside, but I also don't have those long skinny triangles. And you notice too, let's do the actual surface file, EV2, that produced those contours. You see where I had the inclusion has trimmed off the edge on the outside, and the exclusion has actually made non-defined areas or those holes in my surface. Okay. So instead of having the surface be intact there and just trim out the contours, this actually trims off the surface. So there's nothing invalid about that surface now. There's none of these areas out here are being used. The one final thing is when you're doing that command, you can triangulate and contour. Instead of having to draw that boundary polyline first and then run the command, which is what I did, you could choose right here to this use inclusion exclusion areas. If you uncheck that, it now gives you the option to shrink wrap a perimeter reduction, and that was the same thing. So I could set that to a low, medium, or high reduction of those exterior contours. Hit my setup, I would put it on, say, BDY layer, make it a 2D, draw the boundary, say okay, then, you know, when it runs and it asks you to do that, it will draw that for you automatically. The reason I did it first is because I like to verify it and make edits to it if I need, like that little arc and those points that I took out of it. So anyway, all of that's there for you to try out. The one other option that also controls that is surface, triangulate, and contour. If we're not using these inclusion and exclusion areas, we can rely on this maximum edge length, things for the interior. And so that would take care of things like these building footprints or maybe ponds that you make long triangles across the bottom, or, you know, edge to edge of those. And exterior would be those long skinny triangles that form down here on the south and on the west edge. So you could set those numbers to, in fact, let me cancel this and let's go back. Erase the contours. And I'm gonna put those break lines back on. I'll show you the results of that real quick. I'm going to annotate or surface, triangulate contour. I'll change the name of my file with the select. I'm going to call it EG3. Let's say save. And now I'm going to uncheck use the inclusion exclusion areas, but I'm going to change these numbers here. So my maximum edge length on interior, I'm not going to do that one, so the building footprints would still be defined. But my exterior, I'm going to say, maybe 100 foot. And I'm now going to grab this, that, go, let it build. It said it skipped 97 edges that exceeded the maximum edge length. Okay. So I know something was working. So now it is, there's that. I'm going to exit that. And if I view my, let's get my, so now if I can see those, I'm going to freeze the break lines. So now the contours are a lot closer. You see that it's stripped out those areas where those long skinny triangles were, because I gave it a maximum length for that. So if I look at that in my viewer, and then load up the surface, see some of these things, and there's that little squared off edge that, when I drew the boundary, I had that in there. So I've got a few triangles in there that might, like see these long skinny triangles here probably should not have been included, but they were shorter than 100 feet, but all these others would have been longer than, so they got thrown away. It's just sort of, an alternate means of being able to throw that kind of information away that's not valid. And we need to get those tips and tricks on. Okay. All right. So we're into lunch. We're going to go, we're going to let you have your full hour here. In fact, come back at 1:30, and then we're going to push through the survey side. So all of this stuff in this 3D world, go through these exercises, get comfortable with that viewer, and, start to take advantage of what that can do for you as you, survey your information. If all you're doing are mortgage surveys and you never need to do that, that's fine. You don't need to worry about those, but also understand that when you're out there surveying, you're getting elevations on those points anyway. And it could be some additional value you can add to what you're doing for your clients. Maybe you start showing them elevations on your map, and hey, charge them a little more money, or hey, get more clients that like what you're doing. So anyway, that's what we're going to do. So we're going to come back at 1:30 Eastern time. So take your full hour. That'll give you an hour and 6 minutes. Any questions? Anybody have any questions to this point? All good? Okay. If anybody had any questions, you're muted. So
Good here.
yep, good there. All right. So I'll see everybody there at 1:30. When we come back, I will stop or pause rather our recording. So anyway, so when we talk about this now, ServNet, are you talking about the least squares adjustments?
Right.
Right, yeah, so yeah, probably not a whole lot because we don't have the setups done, but we'll run through it as we go through this real quickly. Okay, so
Maybe at least we could, you could show us how to access it so we could study
Yeah.
it on our own, huh?
oh yeah, sure. Yeah, we'll get that part. So so we're gonna make a new file for whatever name you want and whatever coordinate file you want. And then we're gonna go to this raw file processing. Okay. So with that, I'm going to save and close these files here, close this draw points exercise, and I'm going to make a new file. So a new drawing, and I'm going to switch to my National CAD Standard Survey. I'll finish. And this comes up and asks me for a file name. I'm going to hit set. I'm going to make sure I go to my folder that I'm working in, and I'm going to type raw file processing. All right. I'm going to set my scale to 40. And say next. And data path is the same. I'm going to make a new coordinate file. I'll let it keep the same name. I'll have no import. I'll say next. And off we go. By the way, I want to show you something real quick here too. That file that we were just in before, I'm going to go back and open it with one of my recent files, which was this sample from T3 Global. This file happens to be actually right on the Pennsylvania Turnpike. If I look at my settings and go to my set project data folders, I'm not sorry, not that one. I go to settings and choose drawing setup. I need to make sure that I'm pointing, my projection is state plane 83. If I want to make that 140. So I'm going to state plane Nat 83 PA South, Pennsylvania South. So if I have that set and defined, I'll show you what you can do with this that you might not be aware of. You can, if you're working in state plane and you have to have that system, you have to, in your drawing setup, you have to have it defined as to, what coordinate system you're working in. And then you can go over here to your GIS tab. Let me see, am I correct here? Well, that's where you can import all this GIS data, but what I want to do is to attach. Oh crap, they don't have it in here, sorry. If you have the GIS module, if you had, you can do it if you get the world files from some of these GIS modules, but this requires, so if you have the civil suite, you've got this, and some people get it just for this one thing under the image menu. It says place Google Earth image. I think what's that command? That is Google_image. All right, so if I thought there was something under survey that we could still do that. Imports. Oh, there it is. No, that's a Google Earth, that's a KZM file. KML, KMZ file. Do it from image. Let's see what it should be. These are all you can place this image, but you have to already have the world file and the image already done. That's not what I'm trying to. get done, I want to. Let's look into draw image. And, all right, well, so it does require this. I'm sorry. It's usually if I'm teaching a civil class, I always want to point this out. So if I go to the GIS module and then go to images and I can place a Google Earth image. Now that's different than a Google Earth file. So this is the actual, I'm going to select an output file. So I'm going to be in my folder and I'm just going to call it site image. Once they save, and now it wants me to choose it for either from the screen or from a map that they pop up. So I'll choose it from the screen. I'm going to go from here up to here. And it's going to go out and find for me imagery that might be available. I've got low resolution, medium resolution, high resolution. And if for some reason you're zoomed in so tight or whatever that you can't, maybe it's not in that part of the country that has high resolution imagery, it will say not available. And you can choose to step that down a little bit. I'm going to make an aerial image. You can get a terrain image, a road map, a hybrid aerial and road map. So the terrain, I think, will just be like the USGS maps. But what I did when I clicked the lower left and upper right is I set these bounded corners, which I could go back and re-choose reset. And I'm going to say, okay, and you're going to watch it go off here in the and it's going to bring in the actual aerial imagery from Google Earth and put it right into your drawing space. Okay.
Ken, I'm having a hard time trying to find that in AutoCAD.
You wouldn't have that unless you do you have the GIS module?
I have a GIS drop down, but I don't see.
No. Yeah, it won't be under there. You need the actual GIS software itself.
Okay.
The actual GIS module, which you go to settings, Carlson menus, and then choose GIS menu. If you run that, does it switch menus or does it tell you module not installed?
Let's see. Well, it seemed like it went through. I just need to find it. Didn't give me an error.
If you type.
Oh, I see it. Never mind. In the command, it does say GIS modules not installed.
Oh, okay.
All right.
All right. So anyway, if you have that, it's on the images and it's place Google Earth image.
Got you.
Command called Google underbar image. So you could try that at your command line and see if maybe they forgot to take it out. I can't test it because I have those modules installed, but if you type Google underline IMAGE, see if that comes up and says anything.
Let's see here. Nope. Won't let me do it.
All right. So that, a lot of people, like I said, there's some people that buy that module just singly to get that particular.
Yeah, it's a nice feature.
Yeah. So, and there's another one too, is if we zoom in here, for instance, you see how those parking lot edges don't exactly match up? Can you see that right there?
Yeah.
Yep, sure can.
So, and that's characteristic of Google Earth images. They're sort of, done from the 35,000 foot perspective. It all looks great, when you're down here, but you can't really use that for stuff. Now, there's another module, and I'm not trying to sell you guys modules, but I do want you to see that this capability is here. And it is this module called CADNet. And it is this little guy here, and it's part of the construction package, but you can buy it individually, and it's pretty inexpensive. Certainly less than survey and the basic ones. Now, when you get that module, there is there's a menu for raster, and it's got this command here called rubber sheet. So what this is going to do, it's going to ask me to choose a methodology. I can do all kinds of transformation stuff here. I'm just going to take that default inverse distance, say, okay. Now it wants me to pick the origin of a control point number 1, and I do this for as many points as I care to do. So I'm going to zoom down here and I'm going to click. It's hard to see my mouse, but I'm going to, let me see. Maybe I can. There you can see my mouse a little better. So I'm going to click right here on the back corner of that parking lot. And then I'm going to put it over here to that back corner. That's what that should be. Okay. I'm going to go over here and do the same thing for the next one. I'm going to pick this back corner and I'm going to snap it to that corner. Let's find something else that might be a little better defined. I don't want to necessarily use buildings because I'm looking at building lean up at the top, but let's find a couple of other spots. There are some, there's the this inlet. So I'm going to get right here on the face of this inlet, or the face of the curb on that back corner of that inlet, and that's going to be right there on the drawing. So I'm basically saying, use this point from the image and put it at this point in my drawing stuff. Okay. I'm going to find one more corner here. And the more you do this, the more it's going to tighten it up. And it does these multi-point transformations. So I'm going to go from here to there, all across the entire drawing. Here's another case of right there to there. Curb islands and corners of parking lots are really good spots. So I'm going to go from say there to there. And let's go one more. That was sort of rounded off. So I'm going to go from say there to there. Let's try this. Here, that one. I see that one. Right there, I think. I see this pole, so I'm going to go from the middle of that black smudge to right there. All right, so we're going to call those good. So I don't know, I've got 8 points in there. It says enter to quit or enter to end. I'm going to hit enter. And it's going to go through and now and warp this image to make it fit those control points. And it's going to basically transform all of those pixels and you might have seen when it came back, it shifted back into place. So now there you can see that that shadow, which is that inlet, is lying right there on the ground. If I look up here at these parking lot corners, you see I got them right where they go. Or some of the other ones that I checked on, these down here. You see, you know, and they were, excuse me, they were, you know, 2 or 3 feet out, just in the raw image. So that's a nice little feature. If you wind up doing a lot of this type of work, some of us don't, but if we are doing things like, you know, flood studies and we're needing to document a lot of things and we use all of this imagery, it's a nice little addition. And that is this module called CADNet. So there's CADNet and there's GIS. And CADNet, I don't think by itself has that, excuse me, has that same, excuse me, I don't think CADNet has that same place that Google Earth image. I think that's only available in the GIS. We do have other things here. You've got raster to vector, raster to text. So you can take a PDF and have it generate vector imagery. That's also available just in general on the file, import, standard import. And when you choose a PDF file, it will offer to convert it into the vectors for you, or you can just bring it in as a raster image and trace on the top of it. All right. So anyway, so much for this. And again, that requires you to know the state plane coordinate system you're working in, choose it, and then you get that Google Earth image. And it comes in and goes to the background, and it's a nice, really nice little set of tools that can help. You know, this could be an ideal tool, in even with or without, even if you don't have the other, the CADNet to do the rubber sheeting. If you can get these images in their proper coordinates, then you can go out on the ground with your GPS rover and start tracking around. You can see where you're walking around here to maybe try to find property corners. It's just another way of using some of this available technology. So, don't lose sight of it. All right. All right, so I'll save that. Now we're going to close that and we'll go back with raw file stuff. All right. So the next thing we're going to do is we're going to go over to our, we're going to look at two traditional raw files. We've got this first file here. Let me get this out of the way. That is, let me find where it says raw file 1, RW5. So RW5 is the file format that that Carlson uses for raw files. It came out of the old TDS tripod data systems, the old TDS survey format years ago. So I'm going to go to the survey menu and I'm going to choose edit process raw data. And I'm going to get this little box up and I'm going to open it up a little bit bigger. And I'm going to choose from inside of this, like it's another little computer program running. I'm going to pull down the file menu and choose open raw file. I'm going to look in my folder. I'm going to find raw file 1. I'll open that. And there it is. It comes up with a little drawing area. Maybe if you have that set to draw in yours, you may not have it. And here's how you turn that on is you just look under display and you look under graphics and you make sure it says on. Okay. Alternately, you could go to this little row of icons and it's the pencil icon next to the circle with the 4 X's. And it's next to the undo button. Okay. So that will draw the raw file. And if you look in our raw file up here, you can see I've got here's a point record. So that's basically where I told it use point 1 is 5,000, 5,000. Take a backsite occupying point 1, no backsite point number, just he's basically setting the circles. Maybe I'm looking at the church steeple in the distance, whatever. And then I'm going to start running. Here's a traverse, 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 closing shot, angle balance. And if you notice, as I click on each of these records in this list down here in my graphics part, you see that lights up as yellow. Now you can also, even though you're choosing that, let's say I wanted to see where this line was in my data. So I can pick, if I go to the this graphics pick cursor toolbar, one between the hand and the survey instrument. If I choose that as my icon, and now if I pick a given line, it jumps to the place up here in our raw file. So you can have this to draw only traverse stations. Now I don't have any side shots in here, just got traverse, so that's what this is. And I go from point 1 to looking at the backside, which was this 0.99 down here. And I'm sitting here, so I store point 1. I sit on point 1 and I take a backside reading, and that's this 0.99, which hasn't been computed yet. And I tell it that azimuth is 270 degrees, but I on my circle, I dial in 0 degrees on the gun. So that's zeroing my plates. Then I'm going to turn a traverse record by sitting at 1. I've already got my backside up here, and I'm going to turn to 2. So I'm turning 180 degrees angle right. I'm going 100 feet at 90 degree zenith angle, and I'm going to set point number 2, which I call trab-2. I'm now going to move up to the next record. If I'm ready to do that, I could take any number of side shots. And I'm going to say, now I'm sitting on point number 2, and because I'm in traversing mode, it already knows that my backside is point number 1, and my foresight will be point number 3. And that's where I can do, and these are all angle rights, bearing codes, angle left, deflection right, deflection right. So this is an angle right code, and I'm going to, at this time, 270 degrees, 100 feet. Then I move up, I'm sitting on 3, I'm setting point 4. So I'm going to look at 2 and turn 200, it should be 270 degrees, but I see it's 269, 59, 58. Well, so there's actually the only error in this whole little traverse. And then when I sit at 4 and I'm backsiding 3 and I'm going to set 5, and that's this record, I'm back to 270 and 100. And then I go move up to 5 and backsiding 4, and I close the horizon back around to my initial backside, which was this church steeple. I call it 0.99, and there it goes. My closing angle. So that's basically what it does. You could put all of these things in, you could transcribe a set of paper field notes and do this, but these are records that are typically collected and saved by your data collector. Okay. So that when you bring that into the office, then you can take care of any adjustments or any changes to anything. Let's say you've got a bad HI that you wrote down for one of your setups, then it keeps a record of all that, and you can just reprocess the data. Okay, but once this is in, you would go to things like your tools here, give your process points, and here's the general stepwise approach. You're going to do no adjust first, just to get a raw amount of closure, and our reference closing point is, we're actually coming back to point 1. So I'll say, okay. So parting 1 down to 5, automatic, choose to traversing nodes because it's pretty straightforward. And I see that, okay, here I've got, when I start at 1 and I go to 5, and 5 is supposed to be the same as 1, it comes up with these numbers. And it says, you missed it north-south by 0.001, essentially, and you missed it east-west by 0.02. A much bigger direction there. But, and it gives us all that. It comes up with, based on how long we've traversed, a precision of 1 part in 20,990 feet, or 1 part in 20,991 parts, rather, not feet. So, so those are the computations. Now, obviously, the numbers should be 5,000, 5,000, then 5,100, then 4,900, 5,100, then 4,900, 5,100. But you see right here, this is how those numbers compute. That's the raw computational stuff. My side shots, it considered that closing angle as a side shot, which should have been 5,000 and 4,500, but you see it's also slightly off because I made that blunder in there. So I missed it total by 0.02, 0.0191 was my total horizontal distance. Most of that west, but there we go. So all that is was the raw computation, whatever it is. I could go back then and say process, and I'm going to do, a compass rule, Crandall or transit rules, those different kinds of things. Least squares adjustment. This is Carlson's least squares adjustment. And there's yet another processing called SURVEY. I'm going to close that off. Say no there. I'm going to go to survey, and this is called SURVEY least squares. Now, this SURVEY, so I've got to get a project and do all of these kind of things with it. But this is, and I'm going to go back now, I'm just going to show you where that was. But so survey raw file, I'm going to open that same file. Okay, so I have the option here under my process compute to actually do a least squares adjustment. This is Carlson's, but it is single network only. SURVEY, in contrast, is a multi-network adjustment. It lets you do least squares adjustment on these interconnected networks, and it's really, really good, good adjustment math and good adjustment tools. It was first marketed and sold by Dean Goodman was the programmer. He was part of Cowherd and Goodman, Ed Cowherd and Dean Goodman, which were the old C&G software. And that is why Carlson bought C&G software entirely, lock, stock, and barrel, just to get that bit of code, that multi-network least squares adjustment code. And so it's still in there. And that's why it's still sort of, the interface is different from the Carlson code, the way it looks. But it's there. So we'll take a look at that here in a quick second. But so anyway, you would go through all of these little adjustments. Let's just stick to a compass rule adjustment, whether we do an angle balance or not. We have a reference closing point of 1. Multiple measures. I think we'll just leave these as is and see if we can get the adjustment to work.
Ken, how'd you get the picture to pop up in the bottom there? I missed that part.
Go to the display menu, go to graphics, and make sure it says on.
Thank you.
Yep. Or you can use this little button, the pencil in this, and the.
Hey, look at that. Thank you.
Okay. Yep.
Compass 1.
Let's see. Sorry, I'm having to type a quick text to my son. He tried to call in, so I'm texting. Tell him I'll tell him back later. All right. So now we can go to this. We saw the no adjustment. We had a raw closure of 20,000. Not very good because we had that bus in that angle. So now if we do a compass rule adjustment, now remember, here's a case where all of the errors in one particular measurement, not very realistic, but we're going to have this distribute the error throughout all the measurements. So I'm going to go to my closure options. I've got one closing point. I think that's all I'm going to need. 1, it ends with 5, specify the points automatic, say okay, and now it says the measured closing points 5 to 99, measured bearing, measured closing azimuth, the reference closing angle should have been, I think, 90. No, maybe 270. Yeah, there it is. So that's 2 seconds of error in the angular error, you see, because that was 269, 59, 58. So we did determine that correctly. So that's what it should have been. And so I'll just say, okay. And now the report's going to read slightly differently. We still have the misclosure ending 0.5, which is 49,99,999 and 5,00190 should have been 5,000. 5,000. It noticed it missed it this much in the northing, this much in the easting, this much vertically, which is no error built into that. We have 1 part in 21,000. Okay, so it's going to now take these angle right 180, 27, 269, 59, 58. Those are the actual observations. And then it's going to check against those points and find the difference, 1 to 5. So those are the deltas. And then it's going to find this angular difference, and there's that 2 seconds right here. So it computes an azimuth of the error, because that little bitty distance misclosure, and what azimuth does it lie at? And it will compute that right here. So it's finding an error azimuth. The azimuth, the misclosure itself missed it mostly east and west, not north and south. So you see the direction of that line is 91 degrees. And you also saw in those numbers, it was like 0.00001 north and south, and it was 0.02 east and west. Okay. And I'll show you what knowing those numbers can be helpful for in just a minute. So, and there's again your precision, 1 part in 21,000. It did an angle balance and it cut down a little bit better. And then it applies the correction to these, so it can recomputes the coordinates. Now here are our adjusted points: 5,051, 4951, 48, 99,999, 5,000.02. So you can, those are the original coordinates, but look compared to these adjusted coordinates. So it goes 5,000 to just under 51, 4,900, 4,900, 5,000. So the northings were all basically right smack on the money. And the eastings were the ones that had a bit of a tweak, and it's mostly point number, well, really not much, you know, 10 thousandths for 5 thousandths on point number 2, 100th and a half, 200ths on point number 5. So at these bands. So then it recomputes and it sets set those up to those adjusted values, and it comes up with what these angles should have been and the distances should have been to have computed those. That was that splitting that 2 seconds among all those observations. Okay, and so that then would tweak those results, and you would then save those points. And if you said, all right, you know, save the results or whatever, or you just exit, save the coordinate file changes, I'll say yes this time. And now I'm going to look at my points, list my points, all points. And now you should see, instead of 5,000, 5,000, 5,051, you see how these got all of those northings. You see it's applied the corrected coordinate value, and it's distributed that error throughout each of those points. Now, going back to that raw file, just to show you something graphically, it's a little trick one my professors taught me. When you are trying to find, if you're trying to find, this is what they call blunder detection. You're trying to find if the error in your traversing is focused at one particular, either a particular leg or a one of the angles itself. So one setup may have had all the error in it. Now we see up here that our setup, which is 3, backsliding 2, but setting 4. So that's the leg of, that's the observation that has all of the error in it in my original data. And remember, we had basically 0.02, 200ths in an east-west direction. Well, you can see the distance there came up 200 short. And remember that computed azimuth for that misclosure, and that's the misclosure that's up here, by the way. If I can. Zoom in quite enough. Well, I wish they would. Get consistent on the tools here, but anyway, I'm trying to there you go. All right, so see, point number 1 is there on the left, point number 5 is on the right. So as I went around there, I started at 1, I went around and I set number 0.4, I set it a little too short. And then when it's set 0.5, it's now too short. So my misclosure is along that line from 5 to 1. It's almost all that distance east and west at that angle of 91 some odd degree, 91 degrees and some odd minutes and seconds. Okay, so, and that makes sense if we consider, hey, we measured this line short, so I pulled it up short. But we also, with this angle, we didn't turn as far around the corner as we needed to. We missed it by 2 seconds. So it's going to be sort of pointing out down this way instead of directly east-west like it should have been. So that's going to tend to pull that final point down below. So you can take a look at the misclosure line as a distance, and then you're going to, and that also has a direction, that's that azimuth. So if the error is in one particular observation, that azimuth of that error is going to be real close to being the same as one of those traverse legs, which makes sense. Just like we saw, we measured the distance short, and so the point falls short of where it should be. But the azimuth is also going to be, if the error is mostly an angular error, because we didn't turn the gun as far as we should have, and therefore we're now off on a little slightly different error condition, or a little slightly different area on the ground where the point, we spread it either too little or too far. So that angular, the azimuth will point to the angle if the error is mostly with the angle. That azimuth is going to point right to that angle and split that interior angle. So if we had like down here, we know that this was our error that's set up, and most of our distance is right here along that line. But if the azimuth of that were this was oriented in this direction, then we would see that, oh, hey, that indicates, because we take that azimuth, we just pick it up and we stick it at every point along a traverse. And when you get one where it sort of, or not sort of, but almost exactly bisects that angle, then that tells you that's where that error happened. And it only works if it's in a single observation, and you can tell it's, you look at the distance and you look at the direction of the misclosure line, and if it's parallel to one of the lines, that's an indication there. So it could have been in, whenever this point number 4 got set, or when point number 2 got set, because if we didn't have this one correct, this, and there's your parallel line, so it's parallel to that, it's also parallel to this. But we then also look at the azimuth of that misclosure, and we would see, but it's not bisecting any particular angle. So what it tells us is that error is mostly in distance. Okay. So anyway, well, let's let me close this. And I want you to just take a look at, from now, I'm going to open a raw file. I'm going to open this raw file too. And I'm going to show you, see, this is completely different. And it's a small traverse, and it has this little fly leg off to the side. So, this is going to be, these are some of the recorded notes in the data collector. There's point number 5,000, which was stored as 5,000, 5,000. There's another point 5,001, which is stored at those, and I don't see it being plotted. Then there's a height of an instrument is recorded. The backside is taken, 5,001 to 5,000. Another, an HI record. This first one was instrument height. This is rod height. And then I've got these side shots. Now you don't see them showing up in the graphics, but when I click here, there's my 0.5001. So if I click here, it's going to highlight that shot. So it's going to go 5,001, looking at 5,000, turns the angle to 5,002. 5,002, new setup now. You're going to read a new backside, a new HI. Then it's going to set 3,001 as a side shot. This, here's an HI. This other HI was the rod height. This is now the instrument height. And so it's going to set all of these individual points, 3,002. See, I'm in the foresight point. So that's the occupied point. Foresight point, 3,002, 3, 4, 5, 6, 7, and 8 are all done from that one setup. And then it's going to go eventually to the next traverse point. Okay. So it's recording all of this, and it can record multiple angle sets, all of the things that we used to do in real, traditional traversing to help us balance our angles. And we record all that, and we can deal with them individually. If we look at this little SS icon that says show the side shots, well, there are the side shots, and you can see, any particular given one. See, that's where that one got set from. So it's, it's again much, it's kind of a tiny little traverse, but set it, and there's a lot of points collected. So all of those, and what we generally do when we compute and balance these traverses, these side shots don't share in a distribution of that error. Only the traverse stations get the errors basically averaged throughout them. And then the side shots are computed raw from the adjusted traverse station. Now that's true with their traverse balancing. And it's pretty, it's a decent enough kind of balance. If, however, we do a least squares adjustment, then it's going to take those side shots into effect with that same mathematical treatment. So it's just, it has less tie-in and cross connection to be able to help refine those numbers. Yeah. So there is, and again, we have this least squares, prepare the least squares data, edit the data, and then process it. So if I look at this, I don't have any error there. Let me least squares prepare the data. Its closing point is 1. Least squares, vertical. So, okay. Yeah, so I had to put in things like my reading error, my pointing error, target centering, all of these things, and they're going to be some things that are equipment specific, and they come with your calibration report. Others are going to be, personality, or not personality, but individual sensitivities is how closely you can mimic those. I'm starting at 5001. See, I think I did this backwards here. I meant to. Yeah, I did. So the reference closing point is, not 5. Yeah, it's 5001. There it is. So, there we go. And the reference closing angle, I'm not real familiar here. Let's see, it's from point to point. The reference should be 5001 to 5006, I do believe. But really it's 5,000. Let's see, 1, 2, 3, 4, 5. Whatever that is. Here's 6. So I think it's 5007. I'm not sure exactly, but anyway, so here's here's how that one goes. It had a little bit better misclosure, 5 thousandths. There's my adjusted elevations. Original versus adjusted. You can see those differentials, different observations and different adjustments accordingly. And that would be it. That's all you would need to do when you exit. You say yes, save the results, and then that would be in your coordinate file. Now, what Jim was asking about was this one called SURVENet least squares, and that's the multi-network least squares adjustment. And it was even, that whole same algorithm was used in a product called SURVENet that was sold years ago that all the surveyors had as well as the C&G stuff. So if I look at select a SURVENet project, I'm going to look at this one called Northline 6. Oops, sorry. I'm going to say no to that. It's existing, not new. So I was in the wrong tab. So existing Northline 6. And I forgot. We're just going to do a little chewing around on this data.
So those RW5 files, are they pretty standard?
Yeah. They can be in different formats. I'll show you that in a minute. If you're still in that edit process raw file, if you pull down that little file menu, you can see there's an import function, and you can see when you pull it right, you can see all the different formats that it supports. There's like TopCon, Leica, all kinds of different things, and they're just different forms that other manufacturers use. But the RW5 again was a pretty pretty far-reaching industry standard. It was used first by TDS, the Tripod Data Systems. All right, so warning, unable to find data file Northline 6. RW5. Huh?
That's what mine said too.
select new folder. If I say no, then I'll need to edit this. All right. So Northline has a file somewhere in here. I've pointed it to a file that is looking for the RW5 file. And that RW5 file is going to be, so this input 5, it doesn't have to be the same. Have a control file. GPS files, level files, raw files right here, Northline 6. Oh, come on. Well, anyway, Jim, I may have to. Oh, not that. Okay, I understand that. The raw files, I would have to add. There's my North line 6.
Yeah.
Take both of these out and add North line 6. And then save, and then at some point process. Pre-processing. Now, there's all kinds of setups in here, and that's the part that is so time consuming, is you getting all of those setups. So if I look at this report, let's look at the main report. So there's my least squares. That's the same thing you see down here in the bottom. I've got results report. So here's my main point report, horizontal adjustments, holding these 2 points fixed. And here's all my observations, and you can see this standard error. Those are the numbers that are all computed from where we put in the input. We're telling it we've got this much pointing error, this much positional error, all that. Anyway, so these are the main reports here. If I look at my results, report, my output, my results, my output, unadjusted coordinates, and then if I scroll that down, I get a bunch of nothing. I'm just on a pre-process at this point. Error adjustment, squares adjustment error report. So 1896 is the same as 95, 97 is the same as 95, 98 is the same as 95, 99 is the same as 95. And that came from basically shooting to this particular point that's all the same point, and we're doing all these different observations, and we just give it a different number for each one of those things. It knows that it's the same point. It holds the 1895 and uses those observations to help come up with these. Now here's where it tells you if you've got a horizontal angle of a spread of a horizontal angle that exceeds the tolerance, and you put in a tolerance value and say, hey, this is my allowable. And here it says, okay, well, you went 11 seconds. Maybe the allowable was 5 seconds. And so it's just telling you that you've exceeded your tolerance value. Same
Yeah.
thing. Yeah.
Yeah, just a quick question. This is for a traverse, is it not, rather than for GPS files?
No, this is GPS on this one. See this GPS? Well, I don't have any GPS files added, so this one might actually be. If I look at, I'm going to edit this raw file. Let me take a look at it and see. But it can be either, it can be any one of those.
Yeah.
It can be. There's not really a difference in the raw file. Raw data files hold data. That's all they're doing. So here, yeah, this is a case of I've got looks like a 1, 2, 3 loop interconnecting traverse. Once this comes up here. Actually, it's more than 3. So I got the 1 loop, 2, little small 3, 4, 5, 6. Looks like there's 6 interconnected loops plus a couple of flies. And you can see with the side shots, there's even thousands of those points, from each of those setups. Okay, or not thousands from each, but there's thousands of total points. So yeah, that was this particular one does happen to be traversing data, traversing and side shots. Okay.
The reason that I ask, and I know we can't get into it this afternoon, is I've got it's a control survey that I do on a seasonal basis,
Yeah.
a couple of times a year. It has like 32 points around a large bowl. And the bowl is 2,800 feet in diameter. It's a reservoir.
Yeah.
And it's done for FERC, the Regulatory Commission. And what they're looking for is it's an earthen impoundment, really. And they're looking for any kind of push out. It's 75 feet deep. They're looking for the walls to push out,
Yep.
a tenth of a foot, that's
Sure.
significant. And so I've done a base survey with the RTK, and I've got a basis that I'm comparing it to every season that I do it. See what I'm saying?
Yeah.
And I think when I could use the this least squares would to qualify the amount of variance at each of those 32 points. You know what I'm saying?
Yeah, you can't, but if you're observing those points with GPS vectors, there's not a lot of correction that this least squares will do with those. With GPS observations, because those are, by the time you get them in your data collector, and particularly, I don't know how you're doing your GPS observation. Are you, like, if you're subscribing to the broadcast corrections, or if you're sending them off for post processing?
I sent them out for Opus correction.
Yeah, so using Opus, so that's already being corrected at that stage.
Uh-huh.
And even if you're using the broadcast, if you subscribe to the broadcast correction, you're still getting all of those corrections being made to that data. So there's no need to adjust those. The data itself is adjusted by the time it lands in your data collector.
Yeah, I guess I'm not expecting that it would be adjusted. What I'm expecting that I could see, like I said, if I had developed a baseline from a previous year, that I'd be able to say, well, on point number 30, I was out this much X, Y. Okay, probably not Z isn't all that important, but whether.
Yeah, the only real thing that you can do there, and even at that, this doesn't even really I guess you can give those, this point equals that point. You can give those equivalence flags. But, you know, you can do that. You could do that manually even really. But you're going to basically have, you know, 1 point number from one job in the past to the same point number to the same job now.
Yeah, you'd be comparing an XYZ from season 1 to XYZ season 2. And
Yeah.
then another column would be the change in X, the change in Y, the change in Z.
Oh, I get what you're saying, but that won't even come out of this result either. Okay, that's not what this is for. This is to actually change the observations so that it minimizes it gives the least square, the minimized square of the residual of the, hey, here's what you computed based on your observations, but here's what they should be based on correcting any of that drift that's through this whole system. And that's the point of the least squares processing, is to adjust the data and share you're sharing the missing totality across all of the points, all of the observations in the system. You're just wanting to do a comparison, and that would be done through this tool. You would have a coordinate file and you would save it from one season, and then you would have one from this season. Then you're going to go to your points menu and you're going to run this point utilities, and you're going to do a comparison. And there's several of these tools that you can use. One is to compare points right here. Okay.
Yeah.
And so I'm going to give a source for, now I'll show you what you're going to get. I'm going to say another coordinate file. That'll be my last year's. And my output is, I want to look at delta X and delta Y.
Yeah.
So I have now a raw file processing CRD file. That's fine. Report the coordinates, report points missing. Drawing. Let's see. I may have to have these points. Let me draw these points. All right, so there's my points. Now, if I go to points, compare points, I'm going to compare with another, let's use the current coordinate file. No, let's use another coordinate file. And I'm going to say now, instead of what I was just doing is this raw file processing coordinate file, I'm going to compare those against, I've got one here called, I've got 356 points in this one called man. Now, these are going to be wildly different, okay? But when I do that, report missing points from, so yeah, let's see. So I'll say, okay, now, so it gives me coordinate file number 1 is this raw file processing coordinate. Coordinate file number 2. So that would be last year's file, and this would be this year's file. And I've got point number 10, 11, 12. These are all missing from the first file. Okay, so you're going to see that. Well, all right, so apparently point number 99 is only point. So raw file processing and man topo. Here's what I need to do. Raw file processing is my current coordinate file, and those start with 1, 2, 3, 4, 5, 99, and then start with 3000 and go up from 3000. Okay, so that tells me now I'm going to go to my other one. Set my coordinate file to be man topo. I'm going to look at those points, and I see that I've got 10, 11, 12, blah, 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 up to 300. So what I want to do is I want to get those to be the same numbers. That way you're going to see some things show up better. So I'm going to go to points, point utilities. I'm going to renumber my points. So I'm going to do all, and I'm going to begin from 10, and I'm going to go up by 1. And let's see, begin renumber, sorry, not 10, but 3,000. Let's say 3,010. So I'm basically adding 3,000 to all of these points. So I'm gonna say, okay, boom, 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 boom. And so now when I look at my points in here, I've got 3,010, 11, blah, blah, blah. All right, so I've got the 3,000 series. I'm going to go back now and set my coordinate file back to what I had before, the raw file processing. And I'm now going to point utilities, compare points, my comparison, my source of comparison, and that's comparing to the points that I have in my currently set coordinate file. I'm going to choose that from another coordinate file. That's what I'm telling it here. I'll say, okay. I choose the other file. There's at Mantopo. I choose open and say, okay. All right. So there, 0.3010 in one file is this. That's my current file. In my outside file, it's this. So there's my delta Y, my delta X, and my delta Z. The two.
I see it. I see the format. Yeah.
The two
Like
lines
you said, they're wildly different, but they're not the same point, really.
Right. So it's delta 7 in the northing, 1775 and 700 and something here in the Z. So that tells us that. Now, it also, if I do that as well, I think I've got a choice. Yeah, if I use the report formatter, compare all coordinate pairs, I'm not reporting any missings. Then say, oh, so we try this one more time. Bink, boom. I won't report the coordinates. I'm just going to report the delta. So now I'm going to use a report formatter. And here comes station offset, report missing points from survey. Now, all right, there we go. I say, okay, now this is a report formatter. Instead of just that one that you saw, I'm going to say there's the first northern eastern elevation description, the second northern eastern elevation description, delta north, delta east, delta elevation. Oh, I need the point number. So that's going to be a column that looks like this. There's a point number, the delta, the delta, the delta. Okay, maybe that's all.
Yeah, yeah.
Now I can export that. I can look at it in Excel. I can send it out to all these different reports. So if I export to Excel, so see, here's my Excel spreadsheet. And I would want to put that as, line the coordinates up. So, and I would use that to be the report that I turned in.
Yeah.
And do it any of those ways that you choose. I'll say that. All right. So yeah, there's a lot of tools there, but the least squares adjustment is not to compare one of those to the other, because it's going to try to adjust that error. It's not going to try to simply report it. So
okay.
Is that comparison? All right.
Yeah.
So that is point menu, point utilities, compare points. And it's also available up here under your coordinate file utilities, that little Swiss Army knife. And it's over here on the file utility side. It should be, well, no, it's actually on the point utility side, the compare points. And that's basically just the very same thing that we just went through.
Okay.
It's not basically, it's exactly the same. It's just a different place to choose the command. Okay.
Right. Okay.
All right.
Well, thank you.
Yes, sir. All right. Moving ahead. Let's see, what did I want to go to? So let's go past this. I'm gonna let you sort of dive through that and see this business here. Those are all the error ellipses, and that's just in that little
area.
that little traverse. And but these are all the side shots. And so now over here, we're going to talk about some field to finish a little bit. I just want to show you something really quick. We're not going to get bogged down in this because we do need to get to the deed processing stuff, because those things are some tools that you're going to be using more than anything else. I would encourage you greatly to learn about your field to finish. And here's a great little resource that's included with your data sets. And let me pop this up here. We have, you know what, let me, Carlson projects. And it's this last one. And it's this F2F quick start guide. That's field to finish quick start guide. And there is a PDF here called Advanced Guide. There's another one called Easy Start. And then there's all these different, there's a coordinate file, there's a tree setup, there's a drawing template, there is a CFG, a configuration file, and there's a field code file, a library of field codes that's set up to create these. And if you look at these two PDFs, here's your Easy Start field to finish. Now, this is going to tell you all about, setting things up, and it includes the data that you're going to need, includes all of that. So it's written by a friend of mine, Doug Auberg, works for Carlson. And, he's saying this is not a complete tutorial, blah, blah, blah. Well, yeah, it's pretty complete, more complete than most that you'll get. But using templates. And so he steps you through this one stage after another. Here's an example of, you've got a code. Let's say you've got a code that you use when you find a brass disc, you type it into your data collector as BD. Well, you know that is a brass disc found, and it's going to go on a layer called existing monuments, and et cetera, et cetera, et cetera. So, that's the whole point behind these code tables and the settings and how they process things. Okay. Here's this tree setup where you're going to tell it to, if you see something that says a tree, it's going to then split off to the side and start processing those tree observations slightly differently. It's going to look for things like diameter of the leaf canopy, or maybe even trunk diameter. And it shows you all those different things. And then at the end of all of that, it's going to generate all the points in the coordinate file that you have loaded in. It's going to read all of those, and it's going to generate all of these graphics. Now, it's a little chunky because it's out of a PDF, but you see it's got the edges of the road, it's got the center line, it's got the driveway turn-ins, it's got buildings, it's got trees, and it even, when you went through that exercise, it even creates, these are all as 3D break lines, and it generates the surface. And you'll see a complete and total three-dimensional picture of that site just based on those codes. Okay. And then it's then once you have it in there, this shows you how to edit, it steps you through how to edit the resulting drawing. Here's an example of a catch basin, and he shows you how to get those to line up to be parallel to the edges of the curb. Same thing with signs, and you can do that from field to finish. How to modify the code table, all of that. So we would normally, let's see, here's another Yeah, he talks about using text instead of the point attributes. Okay, so it's a little bit deeper than most of these. Here's your special codes, things like, closing a figure or shooting the start of a curve. Here's PC to start a curve, point a curve, PT to end the curve. So those are basically you're drawing in the field as you are working, and you're drawing as you go, as you're recording things in the field. But this gives you a really, really good sense of how field to finish is intended to work and how it can really save a lot of time when you come back into the office. Now that was the first one. And then there is this advanced guide, which is repeating a lot of the same things, but not everything. General setup, companion codes, symbols, how to, like, here's an example of how to use, basically you shoot 3 points, the back corner, the 2 back corners, and then this front corner. Now that shows a police car on here. But maybe if you're doing an accident scene, obviously, that's not necessarily what we always do. But, it's all of these different, and some people do, by the way, those accident scenes, there's the forensic stuff. There's a program called, we have Serve CE and Serve PC, and there's also that Serve PC /CSI, and they sell it to a lot of police departments, and they go out and survey these accident scenes. All right, so here's an example. They shot a point of edge of pavement, begin, and make an offset horizontal and offset vertical line. So when I shoot this point, it's going to be right on the ground on the edge of pavement. And as you go, I want you to offset that line horizontally 1/2 foot and offset it vertically 1/2 foot. So that's a wedge curve right along the road here. EP, edge of pavement, and I'm going to begin. And then I'm going, and I can shoot these other points. It doesn't matter the order. But I don't want to go to begin this EP here, go down here, shoot this EP, and then back up. I want to make sure I get them in sequence along any given feature. So then I would come here and call that one EP, and I would say PC because that's the start of a curve. And I'll come here and I could say EP, and it is also EOG because it's the edge of the gravel, and it's EOG1 because I've got another EOG over here. And if I didn't put the 1 and 2 on there, it would have connected those 2 points. I didn't want those connected with the gravel line. So 1 goes to 1 that I'm going to shoot later, 2 goes to 2 that I'm going to shoot later. But that's an EP point, an EP point. It's also an EOG point. It's also an EOG point here. And notice the offset vertical now is 0.8 instead of 0.5. So it's gone up a little bit. And then I come down here in EP and I finish the curve. And I could keep going EP, all those different things. I've got the same thing. I've shot these 2 edges of gravel. I've got another EOG right in here, another EOG right in here that ends that EOG. It ends the DRV end because DRV started here and came over there. DRV started here, came over there, got the shed. The shed was shot by this code where I saw a point here that has shed in the code. I went up here and said shed rect 8, which means it was creating a rectangle going 8 feet to the right from this last one. This shed comes up to this shed, then create a rectangle 8 units to the right, and you're done. So I shot 2 points. I drew my 4-sided figure. So that's the sort of quick and dirty essence on field to finish, just as an explanation and to show you how that works real quickly. Let's go to a new drawing. I'm going to close this. Oh, and by the way, that whole set of resources in that field to finish startup guide as part of your data set. That is something for you to, dig into on your own. So as you can get to learn that, but also watch it in comparison with some of the YouTube videos as well. Okay. So I'm going to make a new drawing. And we'll say next. And I'll just take the Carlson DWT as the drawing template, doesn't matter. And I'm going to choose my set button for my new file. I'm going to go into my datasets folder, and I'm going to call this one sample plat. Okay. And let's make that a 20 scale drawing. I'll say next. And I'll make a new coordinate file. I'll let it keep the same name as sample plat. I'll say next, and I'll be done. Now, so, so now what we have is nothing in our file, but we're going to bring in some coordinates and see how field to finish works. If we go to the points menu and we import a text or ASCII file, this is one of those things that you could do with the startup menu if you knew ahead of time that you're going to do it anyway. But we don't. So now we're going to import this text file that we get. And this is what a lot of people can give you as the output of a data collector. If you're using Carlson software in the field to get your data collected points, you can use the CRD file directly. You don't have to go to an export from the data collector and then an import in here. You can just transfer the file. All right, so now I'm going to, starting at the top, I'm going to select files to import, and we're going to look in our datasets folder, and we're going to find this thing called plat.txt. I see a little preview of my data set over here, and I know that that's it, 1 through 54. I'm going to say open. And then I'm going to come down here and I'm going to make sure I'm in the right format, which the format that I'm going to use is this P, Y, X, Z, D. And that stands for, these letters are defined to the left of there. So it's point name, northing, easting, elevation, and description. Now, that's one of the common things. All of these are different. There's your TDS data format again, the tripod data systems. You got all these different pre-made things depending on what software you use in the field, or you can just leave it as common format and define the format. You can either pick it from this list of previously defined, or you can type your own in here. You can tell it the number of header lines to skip, what wildcard descriptions to match, all of those different things. So we're going to leave these just like they show here. We're not adding any value to the names or the point numbers rather. No prefixes, no suffixes. We're not skipping any header lines. We'll take all the points. And now it says draw points off a point group. Remember we talked about making groups yesterday. This is a nice way to make a group. And you might say a group would be, imported date, 2023-08-25. So that gives you an idea of looking at your list of thousands and thousands of points. Excuse me, you now have these points belonging to that group. So you can do all that if you'd like. So now, we're going to say, okay. And it reads in 54 points. I don't see anything in the drawing, so I didn't have it draw. You could have had, I'm going to look under points, list points, making sure I've got all 54 points. And I see, yes, indeed, there they are. And I see some codes over there. I'm going to now points, draw locate points, and I'm going to draw all. Okay, and then there they are. This is the way a lot of us work. We just bring our points in and then we sit down with our memory or our field book, or we go back and look at their sketches or whatever. And we say, Oh, yeah, okay, well, these are, I called these PV, that's my, my pavement. So I went from like 30, maybe I started up here at point number 28, right here, I went 28 and I shot around this figure 28, 29, 30, 31, 32, 33, 34. And so I drew this little pavement area, that's my little driveway, okay? And I said I did at least also put my PC there because that's where I'm going to start my curve. And I came around here and I'm going to start this curve. Okay. So, but I have to go back and draw all that stuff in after the fact. Now, if I wanted to draw this in as a three-dimensional line, I can do that. I'm going to draw 3D polygon. Excuse me, and I'm going to draw this in on a layer called because I want that as a three-dimensional line. I want to make sure that's on my layer that I'm going to call breakline. BRKLN. Breakline 3D. I'll make it. All right, so I'm going to say okay. There we go. And it wants me now, all right, give it some point numbers or pick a point or whatever. I'm going to use my point numbers. I'm going to say, if I just said 28 through 44, it'll look like that. Oh, I should have said 27 through 44 and then close. But see, this is supposed to be a curve. Right now, it's not. So I could do this instead. I'm going to draw that three-dimensional polyline, keeping it there. And I'm going to start at point number 27. So 27, I'm going to start. I'm going to go to 28. Okay. Now I'm going to go to 29, then 30, but I see from my coding that my point number 28 is the start of a curve, and I need 3 points to define that curve. So one of my options down below is A for arc. So I'm going to say A, or choose that. And it wants me to now either show it a radius point or a radius length or an arc length or a chord or a second point. So I'm going to put a second point. So I'm going to choose this second point, and now what's a second point or point number? So that second point's 29. Okay, so it's now going through point number 29, and now the end point is going to be point number 30. So I can look at it there and it snaps there. Okay, so I've done that. I've made that an arc. And so now I'm going to go to 31. And it is also an arc, so I'm going to say arc. And I'm going to say second point, which is 32. And the end point was 33. And that's that. I don't need to go across here like this because I'm going to have the edge of pavement out here defined, but we'll just continue. So I'm going to say 34, A for arc, S for second point, 35, 36 is my end point, 37, A for arc, S for second point, 38, 39 is my end point, going to 40 through 44 because there's no more arcs. And now C to close. All right, so that's what I can do. And I can do all this stuff all day long and have to stop and manually interpret all this stuff and maybe make some things on, but that's okay. Now, so I put this in as an arc, but you see, in truth, those are those little bitty line segments, a grand. So it's going to look like this in my 3D viewer. With all those points, and you can see, yes, indeed, I've got some elevations on those points, and that's going to serve very nicely as a break line to help me generate the topographic map that I'm going to do. Now, the other thing, if I also wanted to, let's draw a 2D polyline. Let's make that one red, and we're going to call this one plan dash FTRS, plan features. Well, heck, let's just call it plan DW for driveway. And this time I'm going to start with 27. Go to 28. And 2 has an arc. And 2 has a second point, which was 29, 30, 31, arc, S for second point, 32, 33, 34, A, S, 35, 36, 37, A, S, 38, 39, and then 40, oops, through 44, and C to close. Now, what do we have? I've drawn that as a 2D line, and here's why. And you can see right here, I've got this one is 2D, but it started it started way up. It started way up in the air because I still had this one checked to set by first point. That's was my mistake. All right, so now let's go back to plan view. So I've actually created 2, one of which is a circle, or is a true arc. So this yellow line is the actual arc, and this red line is the little individual line segments that are separated. Or I'm sorry, the red is the circle, the yellow is the line segments. Okay. So that's what it has to do to make that 3-dimensional, because it's not mathematically a circular arc anymore. Now, one thing while I've got this drawn here to show you, when you convert, if you were to convert this red line, which is part of a circular arc there, into the corresponding segments, those little line segments, this is going to represent something right here that you've already been very familiar with, or not very familiar with, but you've run across it. And here's what it is. You notice that where these little points are exactly on that red line, and it deviates here in the middle. Okay, because one's circular, one's straight. That's what you would expect. So what we have here, and let's look at a few more of those, is exactly this. We look at my Carlson configure general settings, and it says over here, remove arcs, which method, the maximum offset or the chord length. And here's that maximum offset number. Here's a chord length number. Okay, so what that is then is there's your chord length, 1 dot to 1 dot to 1 dot. That's a chord length in between each of those dots. And right in here is that maximum offset, that horizontal deviation that segment takes away from that circle. Now, note is if you select those 2 lines, and let's give them a line type. Let's give them a line type of, say, dashed. Okay. that was also. If I want to take a look at these, if I give these both have the same line type, it's a pattern line type of dashed. So I'm going to isolate this red one. And I see, okay, that's what I expected, it's dashed. I'll restore those. I'm now going to isolate the yellow one. It also is set to be dashed, but notice that it doesn't visualize as dashed. And that's because it's a 3D line and AutoCAD can't display pattern lines in 3D. MicroStation can and always has been able to. AutoCAD never could. So that's one reason why, one of the two main reasons why we always draw these lines that we might want to show in our finished map with pattern lines. We always have to draw them as 2D lines so that we can see the pattern. We then also draw right over top of it a 3D line so that we can use it to model our terrain. Okay. So again, if we go back to isolate that red line, now there it is. That can be what we show on our finished map, maybe the edge of the gravel or whatever it is that is surveyed. But there's another reason too. When I select this, remember when I selected the 3D and you saw all those little segments around the arc? Now it's no longer segmented. These are true arcs. So if I wanted to draw something, say from the center of this arc, let's just draw a 2D polygon again. I'm going to draw from the center of, say, this arc, and I'm going to draw perpendicular to that edge right there. Perpendicular to. Where is it now? Here's 0 is 2D. Yep. Center of. So, we don't have a center of that other yellow 3D line work because it's not an arc. So I've now told it to go from that center well, my perpendicular snap's not working. It worked perpendicular to that. It should also find perpendicular to this line that I'm just going to be. Oh, no. If I draw something from arbitrary space, not from the center, I'm going to go perpendicular to, yeah, it'll draw there. So these things are, let's just start here. I'm going to go perpendicular to the arc. So these are all, if I were to extend them, they would meet right there at the end of that line in the center. Okay, so those are true radius lines. And I get a true circle there. And I can also do things like draw my dimensions. Let's do a radius. I do something here. So if I'm drawing, in my parking lot, and I need to put in the radius value, the curb returns or what have you. My scale and units are all goofy with that, but you get the idea. So it reads that and it finds out that, hey, that's an actual 25-foot radius curve. This is an actual 10-foot radius curve. But if you try to do that with that yellow segmented line, it won't find that. It's not a curve. Those are individual straight line segments. Okay. So that's the other reason we also sometimes draw 2D and 3D lines. We need the 3D to model the surface. We need the 2D to get patterns and to also recognize arcs as arcs. So that's the two main reasons that we do those two things. If we don't need one or the other, we don't worry about it. If we don't care, if we're not annotating any of that, we don't have to worry about drawing it. Now, again, that's a lot of work to sit down and recreate all of this information from the field that we bring in. So now if you're getting paid by the hour, maybe that's okay. But if you're getting paid by the job, and if you can do this job in an hour instead of 2 days, then you can do the math on that. So let's go to the survey menu and let's choose draw field to finish. I'm not going to really get into, and there's a nice little exercise in the book, by the way, that uses this same example of points and code that's small. It doesn't bog you down in a lot of stuff. So it'll really help you be a good first starting point. And that is the actual that's this actual exercise right here. You can see in the pictures down here, there's that pavement. And it goes to, hang on, get my fingers to work. Yeah, so you see it can actually generate this from field to finish. It comes into creating this. There's your concrete driveway, there's your pavement, the crown, there's a sewer line, a manhole, electric pole, electric power line, contour map, buildings, sheds, pine trees, oak trees, fences, concrete monument. You know, all of that stuff can be done from that field to finish file. Once you have the code file done correctly, it can do all of this in about, I'm going to say two clicks of the mouse will get the drawing made, not the contours yet. But then you would triangulate and contour after you had all the drawing stuff in, and say, call that another 5 clicks of the mouse. And it's created the contours for you based on all of that. Then, hey, throw it in the title block and you're done. You know, label a couple of things if you need to. Well, it's not something that you want to, dismiss. A lot of people say, oh, I don't really, I don't really want to spend a lot of time trying to do field to finish. It's too, well, once you learn and see how it works, I think you'll find that it's well worth the effort to get started with it. But you got to get to that point. But in any case, here's what we're going to do. We're going to draw a field to finish those same points, and I'm going to I'm going to show you a couple of things to set. I'll let you dig out the reasons behind another day. So we're going to check on these 2 boxes, and we're going to choose this additional draw options button in the middle of the dialog. And if you will set yours to look like mine. No point. Okay. So allow or set your dialog box to look like this. I'll leave it up for a few seconds. So, okay. Now, these buttons down below, I've got set, and edit codes and report codes and all of that. So my TS field codes is the field code library, the code table that I'm using right now. That's not the one I want. I'm going to change that from set. I hit the set button. And I'm going to, this time, instead of working here, whatever whatever folder it puts you out, I'm gonna make sure I go to my folder called Carlson Projects / Settings. And I'm going to find all right, and I need to look in my, I need to go up one more to Carlson Projects. I don't think. Yeah. Do you all have this FLD file called survey.fld in your folder Carlson Projects? I can't remember if that was provided by Carlson when you installed the software, or did I stick it there years ago?
I don't have it.
Okay. All right. So what we're going to do, let's look in the folder that our stuff is in our class folder. I don't see them. All right. If you go back up to just plain old Carlson Projects, go up a level. Do you have anything in that current folder file? So you have one called Carlson. Carlson.fld or anything like that.
Once I'm in Carlson Projects, I have mining case studies, settings, ServNet examples. I mean, it's a whole long tree.
No, yeah, but I'm looking specific for an FLD file.
Like I said, there's 15 folders inside of each of the folders. Carlson Projects has 3 folders. And then there's 15 folders inside of each of those. So
Yeah, but here's what I mean is you're looking at it from your Windows file manager. I want you to look at it through Carlson where it says draw field to finish, and you choose this set for this FLD file. So that's going to limit the extension that you're going to see. So I want to look for
settings is a good spot.
Yeah, it's possibly so. So I'm going to look for, say, I see this one called Carlson NCS, but that's not got the codes that I need, I don't think. It's got iron pins, IPF, IPF norms. It's got hub. Hub is there. What else do you? I'm looking for one that just says Carlson.
Yeah, I have the same screen as you now. It's once you back up from settings that I get different options.
So if you go up to Carlson Projects, do you have anything in this list right here? If you just go up one level?
No, I do not.
Okay, so now go back over to your right-hand side where it says subfolders and go ahead and find your settings.
Okay.
So let's look at that one. See, I've got also this one called Carlson FLD. That's the one I really wanted.
That's one I have.
You do have that one. You not Carlson NCS, but you've got Carlson FLD.
I have both, yes.
Okay, let's use Carlson FLD. Let me make sure. Settings 2022. Let's see, I don't have anything in that one. All right, let's take a look. So Carlson FLD. And the coordinate file should be sitting on the one that you've used to bring all this data. That's okay. We don't need to change it. And let's go to edit codes and take a look at it. And now you may or may not have this one already.
At that point, I get the error kind of thing of split multiple code found.
Yes, and you're going to say split all codes.
Okay.
All right. And so you may or may not have yours already split into categories. And we're not going to worry about trying to get a perfect little plat done here. I'll let you go through the example on your own, but don't worry about that as categories. But just let's go to say set. Let's go to one called monuments, or go down here. Go ahead and put it on all. And then I'm going to come over into this list and I'm going to click on this button here, this heading that says code, so that they sort alphabetically. And I'm going to scroll this down and I'm going to find a code called The concrete monument, it's right here, it's concrete pad. CM, concrete monument. Okay. So it's a concrete monument and it's going to be a symbol and it's going to go draw content line types perhaps. And so we need to see what's in it. So I'm going to hit this edit button to the left of that and it pops up this. And so what this does, it says, when I see a code on a point with CM, I want you to use this. You're going to put in a description of, I'm going to change this to CONC space MON. Just come on. That's going to be the description that it writes into the drawing file next to that point. Whereas CM is the code, the description that's on the actual point. Right? It's going to go on a layer called monument. And what's it going to draw? Down here in the lower left corner. Points only. Lines, 2D polylines, 3D and 2D polylines, or just 3D polylines. Those are our choices. Remember, I did the driveway as a 2D and a 3D. So we're going to look at concrete monument. That's okay. I'm going to say, okay. And I want to look at fence. That's my FNC, I think is what it's called. FL, fence line. I'm going to choose that, edit that one. And I'm going to see, okay, that's a fence line, but it's not going to draw a description. It's just going to draw some line work. And the line work it's going to draw is a 2D polyline down here. And there's also this symbol and this line type. So I'm going to put in, if you only shot fence posts, you could say choose the symbol as this little round circle. But if you're sometimes just shooting points along the fence line, you don't want to indicate that there's a post at every time you get a point. So you might say, let's clear this off. We're going to say none. So no symbol. And it's going to put my points on this separate layer, but the line work and stuff is going to go on a layer called fence. It's going to be a 2D polyline only because I'm not using it for a break line. It's just to establish that. And I'm going to look at my line type and I see it's set to what looks like a fence line and all kinds of different options in here. I'll say, okay, save. And oh, I wanted to look at that PV. Remember the pavement, which was the driveway. So I'll scroll this down and find PV. If I can not go past it. PV, edit that. So it's going to draw this time. I'm going to put 3D and 2D. It's going to go on a layer called pavement. It's going to be no description. It's going to have no symbol. Line type will be just a continuous line. Everything's good to go here. And I can also do hatch these closed areas. We're going to hatch it with concrete. So it looks like CRE or conc. I think this one is just hatch closed areas with a hatch called conc. Hatch scale, I think I'll leave for one right now. And a layer name hatch, that's fine. So okay. So that'll be good. I think that's all we need to take a look at for now. I'll save that, I'll exit that, I'll hit OK. And off it's going to go because it had some code already done. And then you can see some of them were drawn as trees. Some of them, here's a shed. Here's a building. Here's my driveway now. That driveway, I wanted to have my hatches in there. I can also see I've got this as a sewer line that's drawn. Wrong scale and all that. I would change my MH. Code. I'll fix that in a minute. Same thing with this electric code. So with the exception of being the wrong line, and I also want to put a code on this 0.44 that says close, so it closes back and makes a closed figure. And I'll show you why. And that is sometimes I'm just going to change this right here. I'm just going to double click this 0.44. And I'm going to come down here in the CRD file description. I'm going to say it's PV, but I'm going to type CL for close. And that's a special code. And now when I process field to finish, draw field to finish, all I do is hit OK, and you're going to see all this stuff go away, and then it's going to redraw itself. And voila, there's your driveway closed with the shading on the driveway. Okay, so I'm going to do this one more time, draw field to finish. I will edit my codes. And here's, I'm gonna look at my code table settings, and I would say split multiple codes all. This is where you can either be prompted or none at all. And that is a case where, let's say it hit the code. I'll show you the example in a minute. How does it behave when it uses multiple codes? Because it needs to either read one of them and ignore the other one, or process both. So I'm going to go to my PV, which should be road features. There is a place to find PV. I'll go to my symbol, my line type, my hatching. I'm gonna make that a 10 hatch scale. We'll call that a layer name called hatch PV. That'll be fine. That'll be fine. Okay. And I also noticed when I had up here this shed formed 3 points. So I'm going to edit. I'll show you how to fix this as part of field to finish. I could do those points. I'm going to now open up my point editor. I'm going to scroll this down. I see those points, sheds 5, 6, and 7. Well, one of the things at 7 is the last code. I've got a code called shed. It goes to 6 is shed. It goes to 7. It's going to say shed. Now I could put CLO to close, but that would close it along that diagonal. I don't want to do it there. I want to make sure that that says RECT, rectangle. Okay. So it's going to close over, but it's also, it's going to close over parallel to that front and parallel to the side points. Now I've got another code down here that says HSE, or I'm sorry, BLDG, building. And so I'm going to find those, and those are points number 17 and 18. All I shot were the first 2 edges. But if I say on that one, building RECT, if I go with a positive number, it's going to go to the right of line 17 to 18. If I go with negative, it's going to go to the left. So I'll just leave it positive, and I'm going to set that to be, say, 15 feet. And I'm now going to save and exit. And I'll say, save the code table. I'll exit, hit OK. It's going to redraw based on these new settings. So there you see my concrete driveway hatch I fixed up to be not so dense. There's the 2 sheds. It went 5, 6, 7 shed. So it, or 5 shed, 6 shed, 7 shed RECT. building went 18 to 19, and then it said shed. Or then I'm sorry, then it said rectangle, REC 15, so it went 15 feet off to the side. Okay. There's some other codes too, like it doesn't have to be just a rectangle. You can give it like, turn left, go 10 feet, turn right and go 15 feet, turn right again, go 20 feet. You can basically put in little etch-a-sketch commands all the way through all of those. You could, there's an iron pin here, an iron pin there. This is my edge of pavement going around a curve. You could then, after the fact, if that were a 2D, which it's not, it's 3. But if it were a 2D, let's see, that's an iron pin. Is that IP? Yeah, so here's another reason why, now that's a property line. There's no reason it's 3-dimensional. Let's take a look and see what is 3-dimensional. So really only that building, this power line, and sewer line and the driveway. But I've also got the driveway and the sewer line are also 3D as well. But the property line, the boundary line, I can't do anything with it other than 3D line. I want that 2D stuff to go. So I need to fix the code manhole, the code, what is this one? This is called UP, utility pole. MH, UP, and IP. So I'm going to go to survey, and I'm going to draw a field to finish and edit the codes. So I'm going to edit my IP. And see, it's set to draw a 3D poly. I don't want to. I want to draw a 2D poly. And I'm going to go to my line type, and I'm going to choose something a little more appropriate to be a property line. I don't think there's phantom up here, but I'm looking for if there is anything. They might have a little PL symbol or something. There's a slash L, a slash DC. Oh, there it is, PLC. All right, so property line. I'm going to put my spacing at every 2 inch. I'm going to say 1 3/4 inches. And my symbol size scalar, I'm going to put at 0.125 of an inch. That'll be working fine. Just say okay. Did I get the right one? I've got my codes here. Ding, 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 ding. Right there. Okay, there we go. So I've taken care of IP. Let's go next to MH for manhole. It's drawing, it says a 3D. Let me go into 2D. Again, every, let's say 1. So there's one sand. S, there's sanitary, SS for sanitary sewer, or the sewer, sewer. All right, good for that one. And then we had UP for our utility pole. We need to change that one as well, because it was still just that little teeny tiny one. 2D poly line type. it's gonna be electric, so I'm gonna keep that at every, this time I looked at it, 5, 10. And I'm going to choose this E for electric. Okay. I've got an edge of pavement out here, which is going to be an interesting one. I'll show you that one to see the difference. Is this EOP code in the it's edge of right there. So exit that down to 45. There is. EP, not EOP. Okay, so now I find EP. And I'll show you something really cool. EP. All right, so EP is going to draw 2D and 3D lines, perhaps. I made pavement. I don't really necessarily need a 2D on the pavement, but I'm going to go to my line type. And instead of just being a particular type of line, I'm going to choose down here as a template, and I'm going to select a template file, and I'm going to call that one curb dash left. So I guess we have to edit it first. New, there we go, curb dash left. All right, so I'm going to say from here in the center, I'm going to add a an offset. I'm going to add zero slope at 1/2 foot, and that's going to be, I'm going to be shooting the back of curb, so I'm going to say 1/2 foot away. That ID goes to the top of curb. Let me uncheck that. There we go. Let's remove this. It's on the right. And 0.5. Now I'm going to add a vertical drop of minus 0.5. And that's going to also be at very slight 0.05, so 1/10 away, just to get it away from it just a little bit. I can't have a vertical face, remember. And that's going to be my FC, my face of curb. And I'm going to move that. Yeah, so there we go. And now I'm going to add say a slope of be a positive 4% for a 2 feet. And that's going to be my EOP, or my edge of gutter. Well, it must have 24. I went 2. Okay, so now I'm going to do that, and I can carry this on into infinity. I'm going to add. I'll show you how. If I added a 2% now, let's go 12 feet. Maybe center line. I'm now going to add one more of minus 2% for 12 feet. And that's going to be back to. And I could build the other curve up there, but I'm not going to. I'm just going to say save that. Exit. Okay. Save. Exit. And okay. Now, My sanitary is okay. These electric lines and sewer lines didn't necessarily do what I wanted to based on the code. So let's see if I did. What is my scheduling setup? Should still be 30, 20. Okay. So what is this distance? Six and a half feet. Edit the codes by line type. Got line type. Yeah, here it is. Line type spacing then should be 2 point. Let's see, 125. And so okay. The MH is going to be 1.75, 0.9. Now, the UP is going to be one, but there's something on like this. Um,
Hey, Ken, I was wondering if we could do a time check here. I got about 4 p.m. Eastern time, and I don't mind going till 5, but I'm
All
really
right.
hoping to see the deed processing. Are we gonna be
Yep.
able to get to that today?
Okay. Good call. We'll do that. And it's okay. Save and exit that and let this go. Yeah, glad you caught that. So it'll be good to go. There we go. That's what I was looking for. So it's still, I still miss it on the electric, but you get the idea. So I've got a property line, and I can even, once that's done, I can just simply do, these little things like this. That template that I did there for that, I've got one point here that I shoot at the edge of that roadway and goes around to here, and it reads those curves and comes around. That concrete monument is up here, and it's also that fence line. Again, I would fix that code by scaling correctly. And if I look at all this stuff now in 3D, you can see by using, I shot one point back here, but remember that template? It shot the back of curb, it went out and set the face of curb, or the top of curb, it dropped down to the face of curb, came up the gutter pan to the edge of pavement. There's the center line, there's the other side of the pavement. Now, we obviously wouldn't shoot the road that way because you know, we want to be able to shoot it what, you know, the way it really is, because nobody builds a road exactly to those dimensions. But you see what you can do. You could even shoot the top of a set of steps and have it throw out the other parallel sets of steps. Now I've got see that right there? That's a concrete Jersey barrier. That is one of the codes. So obviously whatever that, and that's probably a traverse point, and it's obviously not coded correctly. So anyway, but you get the idea, and that can be something that can help you get, you know, a lot of this stuff done, that you don't have to go back and start playing. Once you get the codes developed, you test it like this, get everything right. And then when you're out in the field, you just code into your data collector exactly those commands and codes that are going to be put on the right layer, drawn the right way, can create all kinds of additional geometry for you. So you don't do all this when you come back into the office. So that's what that thing is for, okay? So now let's do some deed work. Here's another really good example of doing this with building a terrain model. And there's just two different codes in this file, 17 and 18. And you can look at that and just build one on the fly to take it from where it builds these, if you don't have the codes done correctly, to, you see how that it looks like now a lot smoother contour lines that show ditches and things, because otherwise it doesn't connect those codes together correctly. When we apply field to finish and rerun it, it connects the codes so that those create break lines as they go back. So now let's do a quick look. So we're going to start a new drawing file, new coordinate file, you choose the name, and then we're going to choose survey deed reader, and we're going to read in deed text.txt, and we're going to use a settings file called deed reader settings.drs, and this is on page 71 of your book. Now this is the reader part that's a little bit tough to do these, but you know, it can be what you want. So I'm going to close this. I'm going to make a new file. I'll just take the defaults here. And I'm going to set the name, go to my folder, and I'm going to call this one deed. We'll make this say folder. I'll take it as a new coordinate file, keep the same. No. Okay. Now we're going to go to the survey menu, and we're going to choose deed reader. It's down about the middle of the menu. And we're now going to load. We'll go down at the bottom and choose load, and we're going to find in our data sets this file called deed text.txt. And you can see it there, beginning at a pipe on the westerly side of the state route 702, blah, 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 blah. And so it's going to do this. Now, it's telling me that from these settings, it says, here's my warnings in my box here. And unfortunately, it's not a resizable window. I can't fix that. I can stretch it a little bit top to bottom, but I can't fix this individual. But it's telling me I've got a warning, found an unrecognized entry called beginning at a blah, 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 while reading line 1 at position line 2, column 1. So it found a line prefix with the value of thence and line bearing and line suffix with the value of a semicolon missing the distance. Check that the text contains distance. So it couldn't process it. It found those errors, and it's telling you these red things are the ones that it recognized, but it didn't find anything else because I've got something wrong with the codes. Now down here are the codes. I look at my settings. I've got distances where I put in units and colors, warning colors. I've got sections for lines. It's going to look for a prefix called thence, a suffix called semicolon, same thing for arcs. I've got one thence with a curve. So you set all this stuff up that's going to match the D. Now, we're going to now go back, instead of those settings, we're going to say, we'll click our settings again, and we're going to choose the load button there. This is going to load the settings. What we did at the first load is we loaded the text file. So I'm going to now load the settings, and I'm going to, instead of looking in settings where it puts me, I'm going to pull this down and choose my data sets, and I'm going to find deed reader settings and open that. And now I'm going to have some different things that might not violate those problems. If I choose that, I see, well, hey, I've got some results anyway. So it tells me up here, found an unrecognized entry beginning at a pipe on the westerly side of Raymond Lovenshiner while reading. So it didn't like that. I would have to put a code to handle that. So this is really just a statement of a POB. So I could go to my settings, different directions, my quick settings. Fine. Got an unrecognized entry beginning and a pipe. Okay. That's fine. See, there's something oh, I know why. You see right here? See that south 64 degrees, 19 minutes. No, sorry, I thought I knew why. That's nuts. There's one where it writes the word F-E-E-T instead of a foot symbol. All right, so that's just a warning. And then while reading line 2, it found the line prefix with thence, searched for a distance and bearing, found an unexpected S with the value of S. So that would be, while reading line, position on 2, column 37. So there's line 2. This number up here is supposed to be changing. It used to. Looks like they broke that again. Let's see here. Anyway, somewhere it finds an S that it didn't like. Surely it's not that. Oh, there we go. Line 2, column 94. Line 2, column 37. Apparently it's not liking that one. Well, that was it.
Yeah, I wasn't able to get to the reader warnings, so I'm not sure how you got that part.
All right. Whoops. There we go. So these reader warnings, you didn't get any of these?
No, I loaded in the file. I got the text that you have up above, but it didn't call any
Go down
warnings.
and hit process text and see if that gives you that.
Okay. No.
You don't have anything? Do you have an empty window that says reader warnings or do you?
Yeah, empty window. Mm-hmm.
And did you load these settings? If you go to settings files, see, I'm telling it to match case. Let me,
I loaded that deed reader settings.drs file.
yeah.
I don't have any warnings either.
Well, not sure what to tell you. But I can tell you this though, you see, it's going to take us a little while to pick this apart. And as soon as we did, see, you're just looking for these unexpected things. So
Mm-hmm.
what do I have? Prefix, suffix, nothing. Feet says the word FEET. This is meters, bearings. Let's look at bearings. I've got N and S, E and N and S, E and W. Let's see, bearings. I'm saying space in space. There's no space there. Let's just see if we put a space there. There's an E. Let's put a space in front of each one of those if that's going to work. Now, here's why I didn't find the south. It didn't like the south because I didn't have it in there. So if I say okay and okay, and now process the text, that first error should have gone away. Now we'll see 237 then says I still found an unexpected S with the value of space S. Well, all right, back to this, back to bearings. Let's take those preceding spaces out. That and process text. Now 2 and 15, it found thence and found an unexpected value E. All right, so maybe we need to take the trailing spaces out. I'll read it to A did found thence unexpected value of W. Oh, I don't understand why. That should be in bearings. So angles, we're looking at degrees, minutes, seconds. Bearings, we're looking at no prefix, suffix, no prefix and suffix. See, they've changed the code here. And that may be why we got different results, because one version of these used to recognize and honor those spaces. That's why I had these things in here. And then they've changed them to where they have to be in prefix and suffix. And I don't know when they've done what, but all right, so that's that. Due north, due south, due. Okay, that's good color. All right, that's fine for bearings. No azimuths, anchors. Distances, I want to, as a prefix. That's. I start thence. No, that's not a prefix for a distance. That's a prefix for a bearing.
Well, I can see what you were saying yesterday. This could really make you pull your hair out trying to tweak this thing and get it exactly right. They'll read it. You're better off just drawing it.
Like I said, you could have been done by now. So let's see, that was distances, angles, bearings. Let's see, is there a prefix for angles? Thence, let's try bearings, prefix. And the distance should have a suffix code of that, I think. Cross 6. So now see how that line changed shape? Yeah, because now, so I've still got, it said while reading 2 days, it found, and then it found searching for line distance and line bearing, found an unexpected W. Well, I don't understand why. It's, but the W is exactly what it's supposed to be. North, south, east, and west. These spaces back in, put the spaces after the N and S and before the E and W. Let's see if that does it. Process that text. No. 2 and 7 still finds this W.
It does look like it has some leading space in front of the W or something.
Yeah, it did, because when I put the, because I was just trying to see if I get this darn thing to work. So
Yeah, well, I think
yeah.
you convinced me not to use it.
Yeah, so well, it's really cool when it does work. The odd thing is that this particular deed is just a little rectangle, so it's not all
Right.
that cool. But what's really good is that if it does work, it works nicely, and it has these, you know, you fix all this stuff based on these warnings. There's 100 errors and warnings, it quit reporting. You know, so I would have to go through and find all this kind of stuff. It found this and says it was unrecognized. Well, okay. I guess we'd have to go back and edit the text file and just take that line out.
Yeah, this also assumes that you can actually grab the text too, right? I mean, because a lot of times we'll get deeds that are real old or
Yeah,
PDFs that you can't copy the text out of.
yeah, that's exactly right. You have to have a text file. Now you can edit, you can like go to a Microsoft Word file and be editing it inside of Word, and you can copy and paste into this window. It's all, you know, you can do all that. In fact, I think if you load, no, it does look for a file with a TXT extension, so you do need that. But anyway,
Ken,
yeah,
can I have a quick question here on the deed reader? And I don't know if this relates to the deed reader, but in my number of years, I've written an awful lot of written property descriptions
yeah,
from my CAD model that's in my Carlson software.
yeah.
And there's a tool in there that is deed.
But that's to help you write the deed description. This is to help you read a deed description and have it create the geometry for you. So you come back from the courthouse and you read this deed, and it creates the line distances and curves and all that kind of stuff. So that's what this is meant for here.
Well, there's a code where you depending on which whether you're northeast or southeast, or there's the 4 quadrants. You give it a quadrant, and then you give it a bearing distance, and you give it a degrees, minutes, and seconds.
Yeah. You're gonna see that when we enter the deed itself. We're gonna type and type in the deed cost.
Yeah.
That's where we do that. This is actually reading the text of a deed. We haven't touched anything. We haven't typed anything, other than I'm trying to get the codes to match up, and they won't. They're just.
Okay. How do you get it to read? What are you having it read the bearings and distances off a polyline? Is that it?
No, we don't have any lines in our CAD file at all. This is reading the bearings and distances off a piece of paper. It's reading it up
like a Word file?
Yeah, just a piece of text, a text file right here. Okay, that's part of that description. And it's telling me down here, it's not recognizing because I don't have my codes matched up.
Okay.
That's what that tool's for. It would be great if it worked very easily. It's very tedious to get it to match. And then once you do, you get it to work for this particular one deed,
Yeah.
next deed's gonna come along and it's gonna be formatted differently, and you gotta go through this process all over again. So it's just not worth it. It's a great idea.
Yeah.
I think Kevin or somebody wanted to see this, and that's and that's
Yeah,
great.
mine's all loaded up fine. What button do I push to have it write it or draw
Yeah,
it?
that's right. Where's my easy button? Yeah, I got to go to Staples.
Mine doesn't have any warnings. What button do I push next?
Yeah. So that's
I
the
was
idea.
hoping for the magic bullet, but you know.
Yeah, that's right. Where's the done button? I want it. So anyway, that's the idea, and you can see
So there's nothing I can push next to make it work with no warnings?
correct. It's
Wow.
really kind of cool. It can teach you a lot about this deed stuff if you'll take the time on your own to go through this stuff. We just don't have time. I got 10 minutes left. I want to, until it's officially done, but I want to show you that really cool trick with the deed correlation tools. Okay. So
Let's see it.
yeah, so let's exit that. And so we're going to go now instead to the next part of the exercise here is instead of, see there you go, it would generate that. That's the actual beginning of the pipe, blah, blah, blah. There's the code that drew this rectangle, and it with those same settings and that same text description back when I put this book together 3 years ago, originally 7 years ago. This would come in here. I just had a little warning that was inconsequential. It still pulled the geometry out and created this plot for me. It all worked. They've made changes to the software. I haven't touched the description or the codes or the settings. I didn't save them. So whatever they've done at the behest of some other customer I wish you'd change this to do that, or they've done something that cascaded a broken effect down into this. I haven't tracked it down. It's not worth it to me because it's too difficult to, once you get one deed to work, you go to another deed and they, that particular set of lawyers used the word DEGREES instead of the degree symbol to write a bearing, or they said NORTH space 45 degrees instead of N, either with a space or without, or sometimes they have one call that is written that is formatted one way, and in the very same deed, in the very same description, they'll change it to spelling out the quadrants or changing the degree symbol to the word degrees. They're not consistent. So it's just not a reliable tool. Okay, but anyway, it's there. So what we're going to do next is we're going to enter this deed right here. Okay. And this is on page 72 of your guide. Now I'm going to put that back over here on my other screen so I can see it. So I'm going to move it back to here so I can see all. And we're going to put that in. So if you've got your book handy, you can open it up, or you can look at it, or just follow what we're doing. So we've got a deed here, and it has a POB, and it has some calls around the boundary. And we're going to just go here and say survey, enter deed description. And we're going to set some layers up. Just leave them on whatever defaults you want. It's going to go on a layer called deed, and it's going to go on, the points are going to go on a layer called PNTS. We're going to traverse by bearing. We're going to set our symbols to be 1/10 of an inch, our text to be 1/10 of an inch. We're going to draw a point format of a complete point, and we're going to label the lines and arcs just so we can see it. Line and curve, label setting, just take the defaults. The deed name is going to be called, let's call this one John Smith et Ux. I love Latin. It's the only time I get one. And I'm going to tell it to draw the lines. I'll create a polyline out of it. I can prompt for descriptions at the corners if I want. That'll be fine. Prompt for the true point of beginning. In other words, it would allow you to do a commencing point and then go to a POB. We're not going to bother with that. create radius points. If I have them, I've got an arc in here, but I'm not going to create the point for the radius. Store to raw data file, yes or no? No need. Store to a D file. Yes, I'm going to do that and you'll see why. And we're going to make this deed file here called deed tools. Let's see, let's look at append sample from text. Now let's have it make new here. We'll just say new, and we'll set it also called well, we'll just leave the same name. We'll call it deed tools. Deed tools. All right. And what this does is it's going to build what we type in and store it in a file, just like a spreadsheet does if you're adding a bunch of numbers. And if we have it to append, it lets us open up that file. We can make a new deed and another property and another property and another property and just add them together and process them all at once. So we're going to say, okay, and pick a point or a point number. I'm just going to type 5,000, comma 5,000. Okay, just out in the middle of nowhere. And enter a point description. That's going to be my POB. Okay. And now it wants me to start putting in my calls. And you can see here, Jim, was where your code was.
Right.
There's I got to put a Q in. If I'm using bearings, I got to put a Q for the quadrant in, and then DD, and then a period, and then the minute, second. So I'm going, according to this, northeast, that's quadrant 1. So I'm going to put a 1, that's my Q. My bearing is 25 degrees, 30 minutes. Oh, since I need to 25 point, 30 minutes, 45 seconds. So that's north, 25 degrees, 30 minutes, 45 seconds. I hit enter. And it wants to know a distance by default, which is in feet, but you can see you can choose varas, meters, rods, and chains. But that feet is 165.45. Boom, there it is. And you can see it's now started to draw and label my distance. Okay. Now it's asking for a point description. I'm going to call that my northeast corner. It's not really northeast, but let's just call it northwest corner. It's sort of more like what it is. And that's all it had. But well, it could be anything. You could say axle or iron rod set or whatever it was. So now my next call is going to be south to east, which is quadrant 2. So it's 2 south, 45 degrees, 0 minutes, 0 seconds. So I don't need to even put the 0.0000. This 245 will be sufficient. So, but if you did, you would, stipulate it like that, but not even any need for that. So 245, and the distance is 200 even. So now there's that. And it wants to know a description. I might say this is a concrete mon. That's maybe a highway down there on the bottom side of my property. Okay. And next we're going to go southwest, which is a 3 quadrant code. And that's 25 degrees, 30. So it's nearly parallel to the beginning line, not exactly though. So that's 3, 25, 30, 30. And that distance is 156.78. Now that's what it should be. I'm gonna do something here. I'm gonna say 165.78 just to show you what this deed does. Okay. And that's going to be another come on, it's already in default brackets, so there it is. And now I'm going to do a curve. So I type C for curve. And the radius of the curve is 200 feet. It's going to go to the right, let's say positive. And now once it can be a non-tangent, we're going to assume it's tangent. So the arc length is 175. And now that's going to go to point description. We're just going to say P corner for property corner. We don't have a description for that one down there. Okay, so that's that one. And now I'm going to go to my northwest. So that's quadrant 4. 10 degrees, 0.15 minutes, 25 seconds. So that's northwest 10, 15, 25 for a distance of 200 feet. And then finally, I'm going to go, I need to give this a description, also call that P-core. And then finally, I'm going to go back to the original point. And I'm going to do that with this deed call, which is in my quadrant 1. It's 25.40, let's 4030 or 4403, B is fine. And it goes to 49.30 feet. Okay. Now, and that is going to be POB as well. And now I'm done. So I'm going to type E to exit and select the entity for area calculation. All right, so it's not going to be able to do it. I'm just going to press escape. The reason it's not going to do it is because I got this big gap in it right there, right? So why did that happen? You know, that should have not have been a problem. And it is,
Curve closure.
yeah, that's your misclosure, and it's almost 9 feet. Okay. Now, when I see a number that is suspiciously off by a multiple of 9, any of you math trivia people, what does that tend to tell you?
Blunder.
It's a blunder, but what kind of a blunder? If something is off by a factor of 9, it is almost always due to 2 adjacent digits being transposed.
Oh,
Because 23 is 9 away from 32. 156 is, let's say, 516. If you do that difference, you're going to find that to be what, 450? That's a multiple of 9. So it's that different. That's a property of numbers. If you see something that is a delta of a multiple of 9, that typically indicates a transposition of 2 adjacent digits. Now, do you remember when I was typing this in, I said that one distance is supposed to be 156.78, and I typed it in as 165.78, right?
yeah.
So let's go back and fix that. And here's how you do it. You don't have to do it. You don't have to re-enter the deed all over. Let's just go to the survey menu and choose process deed file. We're going to find our deed tools. I'm going to open that up. There's our John Smith and his ox of a wife. We're going to select it and choose edit. So let's say we looked at this, we found out, oh, hey, I know what I did. I did this deed wrong over here. It was, instead of 165, it should be 156. So I'm just going to simply come here and change that and hit enter. And you see that hole now magically closed up. And good enough. I'll say okay. And I'll say save, then exit. And so now I would say go to survey, and I could choose map check. Well, let's see. First of all, I'll just get these out of the way. I'm just going to erase them all. And I'm gonna go to my points menu and I'm gonna edit, erase points in the points menu. I'm gonna choose my deep tools coordinate. I'm gonna say by number ALL for the points to erase. Yes, from the coordinate file. Yes, delete symbols. Yes. So now all the points are gone. I've taken those out of the way. So if I said process deep file now, let's go to survey this deep file. So the same one that I did when I made the edit, I can also draw. And I'll put that erasing the previous label to point description, sure. Except I don't have any, I don't think, maybe the label lines and arc, yep, we'll do all that and say, okay. Okay, there we go. Draw's done. And save and exit. So now I've labeled the corners, but you see they're just pieces of text. Okay, so there's that. There's my POB, POP. But the difference between the end of this point and the other, you see it made it a full polyline, and that difference is way less than 9 now. See, it's tiny there. So if I want to see what that actually is, there's actually a little bit of overlap right there. It is. And that distance is there it is. So that distance is what, 0.01. Okay, so not a bad closure for the bead. Right. Let me fill these again. Let's list my points. I think it did not create the points. That's right, still didn't create the points. So if I process the deep file, do the same thing. I can draw it, the erase it, just label the point descriptions. I wanted it to generate points. It's not going to do it unless I add the points. So I'll do that in just a second. I can do a report on it, and I can choose, starting coordinates or angle, distance, and precision. So here's where I get all of the things that came out of my deed entries. And I've got my closure of 1 part in 99,000. And now again, that's a deed closure. It shows you'd expect it to be good. There's your error of closure. And different information given. You can change survey. You can then do a map check by screen entities. And I'm going to go with feet. My distance decimals are 2, and that's fine. I'm going to select the line work to process. So that's the line work, and select a sample of the text. So there's the bearing and distance. And a second sample, or enter to end, I think. Make sure the arcs, just in case they're only different layer. So that sample text, second sample text. Now select the text to process. So that's going to be, just say all. And okay, no match for U plus 0394, 50 degrees 8. What the heck? I probably got a font different, and there's no match for that slash U394. That's right before 50802. Ah, that's the delta symbol in my curve. So let's see. Yeah, let's change those in my arcs with a chord length with an arc length, delta angle with a delta angle of. So that needs to be that slash 504, whatever that was. Let me see if I can find that again. Backslant U plus 0394. So back slant U plus 0394. Anyway, I want to trap this thing down. We'll get to the rest of it. No space. Yes. We got to find out what that particular code happens to be. Now let me look it up. All right, so show the keyboard. You show this. Looking for the delta. All right, so it is there is a delta, but I don't think that's the one I need. Let's see here. See what it says. All right. Well, anyway, all that's doing is doing a map check of the printed text and bearings. So if we go to let's put points on this thing. If I start with, I'm going to my Kogo menu. I'm going to go to just go to points, draw local points. I'm going to set, use my circle. I'm going to put this on a layer called points dash deed. I'm going to screen pick, and I'm going to create a point right there, and that was my POV. Oh, I'm sorry, 0 elevation, and then POV. And I'm going to go here, 0 elevation, northwest corner. What am I? Why is that up here? Okay, accidentally hit. There we go. So now the next one is going to be here. 0, come on. Here, 0, come on. Here, 0, P core. Here, 0, P core. And then finally, here, 0, also POB. Fine. So now I've got some points. I'm going to select pieces of text and just get them out of the way. So now I've got these points and I've got this printed deed description. And I screwed up that. It could have done a check, but we could see also a survey map check by points, report to closure by angle distance precision. And beginning point number would be 1. And it went to 2, to 3, to 4, curve. Secondary. Say, I don't know where this point number goes to the right. I just screwed up. Anyway, divide by 0 error. All right, try to forget. Anyways, various things we could do. You can label the area of this and check it all out. But as you saw right up in here, I've got this point. I've got actually 2 points in here, 1 and 7 that are called POB. Okay, one's, and you saw when it zoomed way down there, there's up here's 0.7 and down here's 0.1. So they're close to the same. And if I were a surveyor, I'd call it the same. That's, you know, 100th. I'd be happy with that if I found some agreement like that in the field. Now, here's what this cool tool is. It's called deed correlation. If you look at survey, deed tools, and this is going to be deed correlation. That's what this is. This is going to give us what we're going to use for this. So I've gone to the effort of coding in this deed and maybe several others, you know, maybe a whole block of the subdivision. And now I'm going to go out in the field and I'm going to bring back a bunch of points, and I want to see if any of those points are going to match up with this deed description. So I'm going to take this drawn property and I'm going to use this to simulate that happening. That's the deed that I'm trying to match, but I'm going to select that and I'm going to right click and I'm going to choose copy from that menu. And it's going to ask me for a from point and a to point. So I'm going to go from here, just over to here. Okay, just nearby. Wouldn't necessarily be. This might be down, you know, at 0, 0, and this might be on state plane coordinates. So you don't have to be close. But I'm going to select that, and I'm going to then select this new thing that I copied, and when I'm going to choose rotate from my modified bar, or I'm going to right. I think I can right click it and choose rotate. Yes, I can rotate. I'm going to pick a point just arbitrarily in the middle, and I'm going to give it a rotation of, let's say, you know, 8. Maybe it needs to be a little more than that. I'm going to rotate this. Let's just click somewhere in the room, just eyeball it. Maybe it really shows up like that. Okay, so it's here's what the deed says it should look like, and then here's what was happening out in the field. Now I'm going to also zoom in here. I know that I've got that misclosure point right there, but I'm going to actually come in here and I'm going to select. I'm going to zoom in here. I'm going to get rid of this point. So I'm going to remove that vertex. And I'm going to also, while that's selected, I'm going to go to the properties, and I'm going to change that to close. Now, it could be that I don't even, you know, I would not even have drawn this figure yet. I've just got a bunch of points over here, but I want to get some points on this. So I'm going to say, Koga, interpolate points. I'm sorry, not, but create points from entities, the one under interpolate. And I'm going to use, I'll draw the points. I'm going to make these as little pluses instead of the circles. And I'm going to call this on a layer called PNTS-FLD, points found in the field. And I'm going to start this from point number 1001. And I'm going to go, it doesn't matter. I'll tell you what, to make this easier, let's not Yeah, let's do that. So the description is going to be IP found. I don't care. And I'm going to now choose this. Created 7 points, avoided the, but I didn't draw them. I'm just going to look at the points. Draw a range of 1,001 to 1,008. Okay, so I've got all these points, and they're not necessarily 1, 2, 3, 4. There's 2, there's 1, there's 3, there's 4, there's 5, there's 6, there's 7. So I've got, oh, that's the radius point, so 1,006. All right, so, and I might even say, let's go to draw locate points, and we'll do some screen picks. Actually, I'm gonna get rid of these points here for just a minute. Because I wanted to distort this a wee bit. I'm going to say pick this and move it out ever so slightly. And I'll take this and just a skosh as well. I'll leave that alone. So I've tweaked a couple of spots. Right. Maybe we'll go one more. Okay, so just a little bit different there. And now I'm going to put a series of points on here. I'm going to choose points, draw, locate points. And this time I'm not going to prompt for elevations. Let's turn this on. Let's see, we'll just uncheck elevations. Point numbers, I'll start back again at 1,001. Points field, that'll be fine. Elevation text, okay, that's very good. Layer, description, note, let's see. Here we go, dialogue prompt, and that will be point prompt label settings. Prompt label, so no descriptions. And I'm going to say screen pick. Now I'm just going to pick that first one there. And we're going to say overwrite with new coordinates. There's my 101. 102. Overwrite with new coordinates. 103. Overwrite with new coordinates. 104. Overwrite with new coordinates. 105. Same thing here. That's number 6. And that's all I need. Now, I may also have a couple of extra points that I found along the way. Let's see if I go to draw locate points. Let's add, let's call it 2003, just to sort of match. We'll screen pick, and I'll put it, say, right there. And add another one up here, maybe it was called 2004. And maybe another one right in here, 2005. Okay. And as you can tell, I'm going to have another one here and here. All right, so I don't know. So I've got 2003, 2000. I've got 1003, and I've got 2003, 4, and 5. I've got 1005, and I've got 2006 and 7. All right, so those are all points that I found in the field. And I want to see how they match up to my deed, see if I can find any particular thing. So that's what our deed correlation does. Let's go to survey, deed tools, and deed correlation. Let's just give it a new file. We'll call it deedtools.dcf. We'll say open. And we need to build a list of survey points and deed points side by side, the ones that we think might happen. And what we're going to do is once we find out the best approach, we're going to change one set of points to line up with the other set of points. We're going to have them move into place. So we're going to say, move our deed points over here into our survey points that we found on the ground, so we make it find the best fit. So let's now add these points, and we're going to add survey point to deed point. So I had 1001 is going to correspond to 1. I'm going to add a point. I had 1002 is going to correspond to point 2. That's the reason I went to the effort of calling these. So 1003 went to 3. Add another point. Now 2003 was also a point I found over near point 3. And 2004 also with point 3. And 2005 was also point 3. And then I had 1004 corresponded to point 4, maybe. And 1005 corresponded to point 5. And 2000, let's see, 2003, 4, 5, so 2006 also corresponded to point 5. And 2007 also corresponded to point number 5. And then we had 1006 corresponding to 6. And then finally 1007 corresponding to, no, let's see, not 1001 compared to 7. So we've got 1001. We've already got we've got 1001 compared to point 1, 1001 also compared to point 7. So we had 2 deed points. We'll just see how they have to fit. We had 3. I don't think I can say that. So I'm going to save this, and I'm going to exit that just because I want to zoom in here to verify. I have 2003, 4, and 5 go to 3. 4 goes to 4. 2006 and 7 go with 1005. So 1005 goes to 5. So 1005 to 5 and 2006 and 7. So that's what I wanted to say. I forgot what I used. So I had 1005. Is 1005 goes to 5, and 2006 and 7 also go to 5. Right? Yeah, 5. Okay, so yep, that was right. So Yeah, 1001 goes 1, 2 goes to 2, 3 to 3, and then 2003 to 3, 4 to 3, 5 to 3, and then back to 1004 to 4, 5 to 5. We also went 2006 to 5, 7 to 5, then 1006 to 6, and 1001 again, because we only found 1 point out there, we'll look at 0.7. Okay, so you should have something similar to that. If you don't worry, just watch what happens and figure out how you do this. So you're going to tell it which direction you're going to move which points into the others. I want to move my deed into my survey points. Okay, so it's actually this set of points, my deed points, I'm going to bring into my survey points, but they have to be graphically left to right instead of right to left. So I'm going to use these tools down here to help me do that. I'm going to say inverse report. And now what this report is going to be is a report of, say, starting on point 1001, just inverse to all the rest of the points. So from 1001 to 1006, so this is all of the survey points in this column, all the D points. So 1001 compared to 0.7, you can compare. So this one has 101 to 1006 from 7 to 6. So I've got a 49.378, 49.3, a 238.165 versus a 241.657. So not so good right there. So you got all these different things. And that's just comparative numbers. It takes each point in your survey points file, compares it to each of the survey points it finds. Then it goes to the corresponding D point and compares it to each of the D points it finds. And you can look at those. It's just like, sitting down and mindlessly running inverses, right? To check your stuff. And in fact, that's why it's called inverse report. Then you're going to do a compare before align. And before you make any alignment, you're going to compare. There's your survey points, here's your D points. Now, these deltas are going to be pretty large and somewhat meaningless because we're talking about points in the field versus points on a deed that we arbitrarily started. But you can see, especially if there were no rotation on it, you would see these distances all being roughly the same. So might be meaningful, might not. So we're going to now say check an alignment because we have a suspicion that we might want to check by holding 0.5, this one down here, because that seemed to be their best thing in the field. So I'm going to check the alignment. And it says, okay, give me from your deed point, what do you want to hold and what do you want to rotate into? Well, I found a pretty good agreement with point number 5 as my help. I'm going to hold that point, and the rotation seemed to see if I rotated from 5 diagonally up that corner to whatever that was, 1, 2, to number. If I hold 5 and I rotate 2, and that's going to be my anchor point, I'm going to say okay. And he says, okay, well, if you hold point number 5, which was the survey point of 2007, 0.5, and the survey point at 1002 goes to 0.2. That means you have to move it this amount, rotate it that amount. And these are going to be those residuals. So it's going to tell you what that is based on what you were saying, I think is going to be the smallest residual distance. All right, so we're going to say okay to that. And I said, well, okay, why don't you define me that minimum alignment? So when you click that, it says, okay, well, you need to hold 0.5, but your rotation needs to be into 0.6. So this bottom bearing over here on this leg, that gives us the best fit so that these residuals are different here. That's odd. The last time I did this, I'm going to check. I'm going to hold, say, 2 to 3. So hold 2, holding 3. So that's a little better. So if I find the minimum alignment, yeah, I just accidentally happened to pick the best one, and it showed me how to do that. I did it in another class before, the one that I guessed at. turned out to be the one that was correct. So it says, no, your best mathematical fit for the least amount of warpage is if you hold 0.5 and rotate into 0.6 as your rotation hold. And then you're going to bring all of that stuff into alignment. That's going to give you the smallest amount of deltas. Okay. So what does that mean now? We've got that figured out. That now we're going to choose apply alignment. And if we leave that alone after we said find minimum alignment, it already populates this box. So I want to move, remember my D points are 1 through 7. So I'm going to go here and bring over 0.7 to 1. I actually might even, leave 7 out of the picture and just say 6 to 1, maybe. And I'll leave 7 behind because that was that closing point. And it says, well, what am I going to start from? My first source point is going to be 0.5. That's my hold point, and my rotation point is going to be up to 6. So it's going to be 5 in 2007, 6 in 1006. I'm going to align some screen entities and ignore the elevation. Now, this is critical that you do this correctly when it asks you for this. I'm going to say, okay. It says, okay, select the objects to align, points excluded. Keep that in mind. The points are going along already because they're in the list. If you try to move all of this by drawing a window around it, so you're getting the points. So the points are going to move based on being in the list, and then they're going to move again based on the fact that they were selected from the screen. So select everything except the points. So I'm going to do a crossing here and select those boundaries and these labels. And I'm going to leave the points alone. And I'm going to say enter to finish my selection. And boom, there it goes. It aligned at 6 points. Left 0.7 over here behind. It brought these in. It held 0.5. Or 6, one of these. That looked like it. There was this green one is the original. The red one was the deed. And so by moving that, I see what it did. It moved this red one into, you see this point here is 2007, but this point is 5. So it did exactly that. It moved that. So it's saying 2007 should have been the one so this one would actually have been right to there. So that's exactly what it was looking at. Okay. Same thing here. I think it said this point, well, that point wouldn't have matched exactly, but that gave the smallest differential along all of those points by holding this 0.7 and holding the rotation up to 0.6. So you see how I tweaked that distance and I made it longer, but it kept that rotation exactly along that line. Okay, so that might give you then a basis for choosing on which points you find in the field belong to actual property points. So that gave you the mathematically best, the mathematically most optimum fit. But you as surveyors, and you all know this, there are other reasons sometimes to hold a point and not hold a point, or hold a rotation and not hold a rotation. It's called rules of evidence, and there's precedent involved in them, as you all know. So those are just some of the tools that you can use to help you process those different things. And the deed tools with this process deed file, I'm sorry, this, process deed file. And I'll show you one other quick thing here. If I okay, so that was a different deed file that we had. This is sample for the text. And I can draw that one. And it went way out here to the side. No. So it was down here. So there was one deed from one deed file. Here was this other deed, and then we've rotated it from another file. And those deed files can have, let's see if I can find the oh dear, let me see. Done. Let's see, projects. Survey class. So that was my deed. Deed tools PDB. There it is. So if I open this with really be all right, so there's my John Smith at UX. That's what got generated and saved in that file. If I did another one, the PDB, I'm looking for PDB. So now here's the sample from the text. I'm gonna take this one and copy and put that in. Deed tools, I'll put that down here. And I don't. Worried. If I had this other one, oh, that's all. I guess there is just those two. The enter deed, the deed tools. Well, the enter deed. That one says lot one, so that's gonna be copied. Wow. Close this one. Save. That's called deed tools. Okay. I'm going to take everything in my drawing here and just delete it. And we go to survey, process deed file, and my deed tools. You see, I've got John Smith, sample from text file, and lot one. Now, lot one should be, that's going to be the same as that John Smith. But I've got sample from text file. I will edit it, and I see there's my little text file that I created. I could select all of them and draw them, and just bada bing, bada boom. Draw's done. Exit that, and so there's the two. One of them I started just sort of art. It looks like I was, when I did it at one point before when it said lot one, I started at a very similar place to where I wound up starting today's. And there's my from text file. So that file, when you do all of those enter data points, this is why I was pointing this out. If you go to enter deed description, and you go to do one, down at the bottom, you say store to the deed file, and you want to choose append, so that if you're collecting those and you just keep building them and they go into the next lot, the next lot, the net lot, and then you've got one file that you can edit and look at all these things together. Okay. Yeah, if you're at a different job, obviously you're going to change, you know, to a different client or a different, you know, thing that you're looking at, you're going to change to a new one. But keep your eye on that and figure out, you know, that you want to do that, yes or no. Now, a couple of other things to point out, and we'll let you go because you're running late, and you'll earn another extension on your PDHs. But is some of these deed tools beyond just that? There are these polylines to a deed file. So if you have a just a polyline maybe that was, you know, you've managed to find a large tract and it was just drawn. If you look at that tool, and I'm going to put it in my deed tools again. I'll choose that and give it a deed name. I'll call it large tract. Okay, done. Now I can have everything gone and out of the way and open up a new drawing to whatever it is. If I go to my survey deed process deed file, there's my deed tools, and there's my large tract. And see, if I edit that, you see there it is. Everything was good. I can make any changes. I run reports. I can also then in this new place draw it. Off we go. Draw's done. Exit. And so there now is my first shot at maybe reconstructing a bunch of properties. And so I've just got a bunch of drawn maps. Okay, and it stays in the deed, and it keeps all of these bearings and distances that it finds in that deed file to let you go back and edit it, just like having a spreadsheet when you're adding up a bunch of numbers. Okay, so those are cool. The other ones, I promise I'm not going through these, but if you look at the area and layout tools, this is where you're going to do things like setting areas by, these are computing areas by closed polylines and such, but you've got utilities. We can do some labels, we can digitize some things, and then you've got these adjustments. These are very, so you know, the hinged area and the sliding side area, radial area, you know, aerial radial from the curve, a bearing cutoff line to calculate a specific area. And then you got these layout utilities where you can lay out some lots and some line work. Fit a structure so it can take a house footprint and fit it on a sort of minimal lot if you want to do so. Parking utilities, these parking layouts are really, really good, and they adjust, they make these dynamic blocks. So we just don't have time to go through all this. And all of this lot network, these are the individual commands that are I mean, these things like this lot file manager, creating lots and all that, those are the, and lot file utilities, those are those individual commands that are all part of this lot network. And that is where you're going to do things like, bring this back across. And so if we had, get to my. That's before all that. Yeah, it's right in here. It's this stuff. So that's where you could, this lot network, and it's this dockable control panel that lets you add roads and intersections. We just, I mean, it's almost a course in and of itself. So unfortunately, it's not time to run through it, but take a shot at it. Try it with some YouTube videos. You've got a data file that will work with some of these settings, so give that a whirl. Okay.
Okay.
With that, and again, I promise I'm letting you go right now. I'm going to close the file. There, it's closed. So, and I'm going to close. Well, I'll leave this one open in case you have any questions on that. But any of you, do you have any questions over these last 2 days? I know, and Jim, you've heard me say this expression before. It's like getting a drink out of a fire hydrant. You know, there's a lot of stuff. So, you know, hopefully a couple of drops made it in and can satisfy a little bit of thirst. But the key is to just keep at this, work with the practice material, and it will start to sink in, and you'll start to learn these tools and sort of these ways of thinking. So, any specific questions?
My question is, I've got a 30-day
Yeah,
copy. Who do I talk to or see? You or is it Mike?
it's Mike. Yeah, Mike Sobel. He's in charge of all the sales and
So I can set up that purchase with him, eh?
yes, sir.
All
And be sure and let him know that you have an existing version is way back. So you're only buying the upgrade. You're not having to pay for a new copy.
Okay, I'll check that out with him. Yeah.
And if you want any of those other modules like the GIS for the aerial imagery or the CAD, you know, any of that kind of stuff, tell him you would like to do that, and he'll put you into there's a package they call Select Suite.
That was where you had that Google Earth with a rubber mat or something like that.
Yeah, the rubber sheeting.
Yeah, rubber sheeting. That was cool.
But there's a package that you can buy called the Civil Suite that has Civil Survey, Hydro, and GIS. But some people might want to get Survey and GIS and Map Check, and that's it. And there's another program for that. Just tell me if you want any of those others. Tell Mike, and he'll get you set up, and he'll get you into the lowest cost, the discount program. There's one that's sort of like, you know, make your own bundle, that kind of deal.
Oh, okay. Yeah.
So, and you get some discount when you buy more than one. I have no idea what it is. I don't even know what this software costs anymore. I just know it's cheaper than the other stuff that you can get.
Yeah. Yeah.
Right.
All right.
All right. So anybody else?
All right.
Well, good. Thank you, Ken. It's nice. Very informative.
Thank you, Ken.
Absolutely. You guys, it's been a pleasure. Kevin, you take care of the natural resources down there. You're close to my backyard, so I want to make sure you're taking good care of things for me. Jeff, you're out in California, so you guys can go ahead and fall off in the ocean for all weekend.
Yeah, I've heard that before. I believe we're fine with that.
No, I'll tell you what, it's the most beautiful place in the country. I'm afraid. I just
It's kind of expensive.
it is, and I will admit with that, I'm not going down this rabbit hole, but I really don't much care for the politics out there. But we'll leave it at that. We're not
Yeah,
going.
well, you just turn the TV off, you know.
That's what you
like to do is just don't watch it.
That's
my
right.
philosophy.
That's exactly what to do. And but anyway, so but again, like I said, it's been and I've done some classes out there. I had a class out in Costa Mesa.
Yeah.
And my wife flew out and spent a weekend. I was teaching out there over 2 weeks. So she flew out and spent the intervening weekend with us. And we just tooled all up and down the PCH, you know, and down to Laguna Beach and up to Long Beach and up toward LA, and just had a grand time. We stopped at all those little beach towns along the way and looked at shops and, you know, all of the stuff that the dudes do when they go to the dude ranch, you know, you got all that. But it was just gorgeous. And of course, San Diego and the Gaslight District is just amazing. So yeah, so you take care of your part of the world too. Hopefully I'll get out there to see it again soon.
All right,
Yeah,
thanks,
we'll try to
Ken.
keep her square.
You bet, guys. Have yourselves a great weekend. And again, remember, send me emails, send me a phone call, do whatever you need if you get stuck on stuff. All right.
Ken, should we expect a
A certificate.
PDHs, the certificates in the email?
Yes, I will send those by email once they get generated and done.
Okay.
It'll be probably well, it might be this weekend, but it'll probably be the first part of next week that you'll get.
That'd be great.
Yeah, you'll get those certificates and the links to the videos.
All
Excellent.
right. Hey, cool. Yeah.
All righty.
All right. Thank you, sir.
You bet. You guys have a great weekend. It's we'll say it's
You
Miller, but I'm not a big beer drinker, so it's scotch and cigar time. So
There.
and you know what, Jim? Just because you've been in the class, I might actually break the mandolin out.
Oh, there you go. There you go. I don't have the harp here. Otherwise, I'd give you a parting serenade.
Yeah, well, and I would I may still pull my mandolin out, even though it's an Epiphone, and you have that Collings that I used to just. Oh man, what a gorgeous instrument!
Yeah, thank you. Thank you.
Anyway, you guys
All right.
take care. It's been a pleasure. We'll see you again soon, I hope, or at least talk to you, that kind of stuff. Be strangers.
All right. Take care.
All right,
Bye.
bye, guys.
We'll talk.
All righty.